Hey everyone, welcome to the 10 hours of coding interviews live stream. Got a bunch of people ready, bunch of people lined up. Check my calendar right quick. Have a bunch. I had a no-show, unfortunately, but I'll try to slot them in. I'll figure out a place to slot them in. What's up? What's up? I just need to eat some breakfast quick. We had a no-show, come on. This first guy didn't show up. But we have some dude from Russia joining in 30 minutes. So that's going to be nice. Got some dude from Russia. I just need to eat breakfast real quick. So yeah, he no-showed. First guy no-showed. Lacked. It's all good. I was predicting some people will no-show, but all these other people accepted the calendar invite. I told them, accept the calendar invite, otherwise I'm going to have to schedule someone else in. But we're going to be doing it a different style. We're going to be throwing them pretty much a coder pad, and then they're going to be working through the coder pad. Yo, Noor, what's good? Let me set up the other aspects of my stream that I like to set up, like the sub count. That's classic. How's everyone's morning going though? You all ready to do some algos? I'll be on here all day doing algos. I'm gonna be a bit more savage about it too. Not gonna be roasting kids, but if they can't solve the question within 20 minutes, we have to move on to the next question. I'm gonna be giving a full rating and feedback on their interview. So yeah, nothing personal, but I have to give an honest rating, and I have a rubric that some like fan companies use. Block the URL a bit. Mods in the building. I need to eat breakfast. Shout out to the mod who's been doing a really good job moderating. We're gonna be doing CoderPad. Print. We're gonna be doing CoderPad. We're gonna. I'm probably not gonna let them run the code. Probably not going to let them run the code. I'm going to do straight up dry run the code. What do y'all think about that? I'm going to grab the... Yeah. I won't ask anything too crazy though around easies to mediums. Also, I'll be asking mostly easy to medium, but I'll be asking 2 questions in the span of 45 minutes. So I'm gonna really get a sense to, so they get more chances as well. Yeah, but me and Alpha is gonna be more of system design. Yo, B man, thanks for connecting. All right. Okay, everything's set up proper. Now we gotta wait for people to roll in. Wait. Today not the day though. Yeah. Today, Paul, I'm running a straight coding interview on you today, right? Where's my... Okay, this is gonna be my rubric. This is how I'm gonna judge candidates. So first, you'll clock it in first. I'm gonna make sure that they clarify or ask the right questions. Just gonna write this down. First, I'm gonna, did the candidate clarify or, wait, let me just do this. The first part I'm going to be marking on is like, did the candidate clarify or ask the right questions? Discussed one or more working approaches, right? Also, I'm going to be seeing, did they get to the optimal solution? Wow. I lived in Kelowna for a little bit. I love that place. Congrats on moving out there. Do you go to UBC? One. Yeah, I like it there. 3. If I go back there, I'll say what's up. Did they get to optimal? Did they get to the optimal solution? Did the code reflect their approach? 5. Like how much autonomy did they have? And then from there, I'm gonna be given I'll give you a rating from strong no to yes to strong yes. So this is the feedback that I'm gonna be giving. I'll be giving that for 2 questions. And let's see how people do. We got 10 of these tonight. Okay, let me grab my food real quick. I might have to move this chat down here. No, chat's tripping. This part of the chat is annoying right there. I'll fix that in a sec. Or I'll move the chat to the bottom. Lico Hard in the building. Let me figure out how to set this up. Maybe I'll put the chat right there. Need the chat somewhere for sure. All right, that's perfect setup right there. Okay, who's supposed to come in next? Who do we got? Who do we got? Yo, yo, chat. How many people you think are gonna pass today? Let me grab my food. Everyone's gonna pass. That's ketchup, bro. That's ketchup. I'm eating eating a little croissant sandwich. Yo, Shashwat in the building. Yo, let's go. I work at later stage startup. Grind don't stop, man. Let's look at the lead code question of the day. Okay, let's answer these questions real quick. Need to find a good place to put this chat. Okay. Do you have any advice for getting into KP? I think just apply to KP. If you get the interview, be able to answer certain questions about startups, like what your favorite startup is, what do you think is going to be the next big trend, things related to that. It's mostly startup related questions for the behavioral because they really want to find people with a passion for startups. What's LLD, low level design? I've been doing system design interviews. Yo, let me change the theme. Oh, that's terrible. So, good question. Yeah, Shaswat, yeah, that's usually high level design. So this is how I'm going to be marking people, and this is pretty standard. So I'm going to be asking 2 questions, easy to medium, and I'm going to be rating them, or I'm going to have this 5 criteria, and I'm going to give them a rating from strong, no, no, yes, to strong, yes. Does that answer your question, Soul? How many lead code questions have you done? Joshua, no. Let's go. I think it does make you a better dev. It makes you a better SWE. And is my eating loud? Sorry, I'll turn it down a bit. I'm eating like a croissant sandwich. Let's go. Leak code will make you a better SWE because it makes you use your brain. It's 10:41 for me. The first interview should be in 15 minutes. Yeah, let's go. You can too. But leak code questions are harder than regular problems. But that being said, also work on real things. I do work on real things way more than I do lead code. I only lead code for content here, and if I have an interview. Most of the other times I'm building projects and stuff. But like, don't make lead coding, data structures, and algorithms are fundamentals. So if you don't know the fundamentals, you should learn them, and that learning the fundamentals will make you a better SWE. Yo, what's up? And nope, it's the Viet place. You want to do a quick one? Fahim, let me finish my food. I'm chugging this thing. Fortune 500? Yes, the interviews are free. Not really free because it's going up on my stream, but I won't be clip fart or like rage baiting you or anything like that. I'll give an honest, regular interview. You know what I mean? How's that behind me? So I live in Cali. It's for Fortune 500, respect. I have some bangers dropping next week too. I mean, those people know what they're getting into when they join the call. Yo, let's go. Are you booked? Are you booked into the? Do you have a interview scheduled with me today? Like, do you have a calendar invite? Have you accepted? Oh, okay. Then I'm booked all the way today. I can send you join the Discord. Join the Discord. DT, what's up? Yo, Fahim, go watch my latest video when I'm helping my friend do like work on his elevator pitch, and then I also help him like answer questions in the star format properly. I help him come up with good examples for the different questions. I just dropped a video on that. There's gonna be two parts. One drop today. One's gonna drop tomorrow. So just watch my latest video. Why should I not hire you? Yeah, that question is elite. Google guy. Google guy in the building. Yo, it goes crazy. How would I answer that? Why should we not hire you? I would say why should they why should they not hire me? It's a good question. Let me think. Honestly, I don't think there's a reason for them to not hire me. Literally. But if you were to not hire me, I think it would be because maybe you asked me some question that I wasn't too familiar with. But nah, that's already a hard question, bro. That question is elite. I would have choked up too. Coder, that's not a good one for a hedge fund. Okay, if I was actually interviewing for a hedge fund, what I'd be like is like, oh, why you should not hire me? I think you should not. I think the main thing that probably I don't have compared to the other candidate candidates is that I haven't really worked much in the financial markets, but I do have experience working in big tech, and I do have a passion for software engineering. So yeah, I've been super focused on that area, and I'm also really willing to learn. I spend a lot of time perfecting my craft, learning new skills, practicing algorithms, and I think those will be applicable to the financial markets, even though I don't actually have that much experience in the financial markets. So if you choose not to hire me because I don't have financial expertise, just know that if you were to hire me, I'm a fast learner and I have a passion for technology and I have a passion for financial markets. Even though I don't have much experience, I'm willing to learn. I'll work as hard as I possibly can to learn that aspect of the business. Something like that. Yo, Paul, we're setting up a boxing match. I found out that he boxes, and we're setting that up. It's gonna be like a Jake Paul versus KSI type. Yo, finish my food. Google guy, of course, man, of course. I'm referring to you. Ollie, it's all about practice. It's all about practice. And honestly, the worst mistake I see candidates do is they don't try to work through an example. They just try to figure out the code or figure out what's happening by just straight up looking at the question and trying to figure out, like, work through an example and figure out why that example leads to a certain expected output. And that shows a lot of your thinking and it allows you to make progress. I only started really doing that recently, and it has made my interviewing skills a lot better. Okay, 5 minutes till the next person. Yo, Paul, I'm gonna send you a link real quick. Let's just test it out. Oh, okay, wait, Russian guy. Yo, wait.
Oh,
What's up, what's up?
what's up? Do you hear me?
Yes, sir. Wait, let me
This
fix
is
up my
great.
thing. Yo, Chad, I got my first person in here. What's up, man? Can you introduce yourself? Can you hear me? Wait, let me fix my...
Um, yeah, but I think um, the first one will be better
First what?
when I'm not hear you right now.
Okay,
To
can
be
you hear me? Can you hear me?
yeah, exactly.
Yo, chat, how's the audio? Can you hear him or hear me? Good? Put like thumbs up if you could hear him good and hear me.
Thumbs up, more thumbs up.
Are you on the chat? Are you watching the stream?
I
Wait. Everyone could hear him fine? Wait. Perfect. What's up, Matt? Can you introduce yourself?
um
You can say
the
anonymous, but
first
just introduce yourself a little bit, or like like how we can keep it like this, or we can just say just share a little bit about yourself as much as you want, and then how many leak code questions you've done, kind of thing.
okay, thank you. The first of all, can I ask you talk maybe a little bit slower because it's not easy to me to understand and
Okay,
speaking.
yeah,
Okay,
okay,
thank you, thank you.
okay, okay. I'm gonna quickly talk with the chat. How's my audio, chat? I'm gonna increase my volume then. How's my audio, chat?
Oh,
Or I'm
okay,
talking to
I'm here.
chat
You good?
to the voice. I'm talking to the stream, but he's too loud. Okay. Wait. Let me turn down your volume a little bit. Okay, can you speak now, please?
Okay. I'm a 20 years old. I'm a self programmer in the algorithms data structure. I'm working a small outstaff company, like a web developer, um, nearly 1 year.
Mm-hmm.
And on the next week, I will be interview final stages
Wow.
in the Yandex company. Yandex company. Did
Nice.
you hear about Yandex?
No. What do they
Oh,
do?
it's a top one Russian. It's a Russian Google.
Wow.
Okay, yeah. So,
You got this,
uh,
man. I'm excited for you.
yeah. Oh, thank you. I'm already passed three algorithmic sections, so it was not easy, but yeah, it will cool. It was cool. So, um,
Awesome, guy. Just wait. Just wait. Just wait. Um. Okay. One sec. I just need to quickly finish this coffee, cause we're about 4 minutes early. I'm going to finish my coffee, and I have to brush my teeth quick, and then because I'm gonna be on here for 10 hours.
okay, no problem. No problem.
Aaron, basically, but yeah, like, how is my voice though? Is it loud enough, chat, compared to his now? I tried to make some changes. A little bit quiet compared to his. Okay.
Okay.
Wait. Let me see
I
how I
can
could lower
something
your.
to difference.
Let me see how I could lower your volume. Okay. Wait. Be right back. I'm gonna brush my teeth quick, and we're gonna start the interview. Can you
Okay.
give me a sec? Russian Google, huh? That's so cool. Here, can you get access to the coder pad?
Um. Okay. Let me try.
Yep, get access. Okay, finish my coffee. What time is it there for you, by the way? What time is it in Russia?
Oh, currently UTC plus three right
UTC
now.
plus three. Okay, I'm at
Yeah.
UTC plus eight.
Oh. I'm trying to access the link, but the page is really slow loading. So, CoderPad is available in Russia, so or not? I don't know.
Is
Just
leak
to be
code
honest.
available for you?
Yeah, Lead Code is available.
Okay, I'm gonna do. Okay, try this out. We're gonna do a warm up question real quick.
Okay. Which of the languages we will use? Python or C++?
Python.
Okay. That's great.
Okay. Hop on this. Piyush, thank you.
Oh, yeah.
Are you in?
Um,
Okay.
yeah, I'm in. Okay.
Okay.
Do you see
This is
my
just
cursor?
yeah. This is just the warm up.
Okay.
Start the question. Explain everything end to end. And I won't be talking because I'm gonna quickly brush my teeth. But explain it to the chat because you're on live stream right now. Explain your whole thought process for this warm up question. I'll be right back.
Okay. The question is 206 reverse linked list. So let's read the description first. Given the head of a single linked list, reverse the list and return the reversed list. So um, constraints here is 5,000 number of nodes. So the problem is ask for a reversing, I don't know, linked list. So we should return the head of the reversed list. So um, and there are many ways to solve the problem, and and there exists one algorithm that can do it one pass or one time and constant time, but I need to remember that. So we can use some brute force solution when we can use additional space usage just to iterate through the all linked list, store the values of the node, then reverse the list and reconstruct linked list by the class, creating a new node like here. It's a linear time complexity solution with linear memory usage. We will store all n values of the nodes in the array. So let's say if we have a brute force solution that will have time complexity of n, and the memory complexity will be also of n for additional memory usage to store all values in the array and reconstruct the linked list. So, and we can use some other approach like uh, uh, it's almost like a two pointers, if I can say that. Let's call this two pointers approach with time complexity equal to of n, and the memory usage will be a constant since we have on since we will only use a pointers, and in one pass we can reverse the linked list and return his head. So I think that's 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 all, at least. So
Yeah, go ahead and implement that.
um uh implement exactly which of these two solution, first one that is brute force or the efficient two pointers.
The most efficient solution, please.
Okay. um Let me remember the general logic of that, but honestly I remember that we have a previous node that will be initially uh equal to just a none because we reverse a list. So, and we have a temporary variable that will be equal to our current hat node, and we will make this the logic that um we showed. Where is that? Okay. Okay. We have some while loop here, so and we will do the next, starting from the while let me pass this way like that, and later on fill that value for remember. So we have a next value that is equal to temporary next. So
Sure.
and we should assign our current value temporary variable temporary next um
Mm-hmm.
tmp next will be equal to previous, like in this example one we showed assigning this to, if we reverse this node, we have like if we have example 1, 2, 3, 4, and 5. um um okay, we're just reverse node. Okay,
Mm-hmm.
like if we had a pointers like this, we will do the next. We will firstly we save the next node in our initial order in the next variable. Then we assign we change this pointer that is currently equal to tmp to our previous node by this line of code. It's like something like this, and then our next variable will be equal to, we should swap to the next variable like while tmp next, I think, or tmp, something like this. Then we need to move our temporary variable next that it is by this statement, and then make this move tmp is equal to next.
Mm-hmm.
Let me write pointers if to be more clarify. Let's say if you have t and the next pointer. Initially, we start with that logic. So first of all, we save uh, our next node from the root, which is equal to 2, to the next variable. So we store it in this variable. So then we bind this pointer to the previous node, like in this example, to the none. So after all that, we need to move our temporary variable to the right by making this assigned. But before of that, we need to move to the right our previous pointer. And we do this in the 13 line, previous equal to temporary. So we'll make something like this. Yeah.
Mm-hmm. Keep
So,
going.
okay. Let me make our pointers to make this. And the next line is also the same. Yeah. Then we repeat our cycle um, and do the following code. Like we store the next node in the temporary variable next, and
How's
bind
it?
the
How's my voice compared to
current
his
node
now? Is it
with
close? Let's go.
previous one, like this. Then move our previous
Okay,
node to
let
the
me
next
increase my.
pointer, and the
Finally.
t will be
Crap.
moved also to the
He
next
can't hear me, by
pointer,
the way,
like
because
this.
I'm muted.
And we will repeat this process until there will be
Okay, I'm gonna
tmp
lower his a little bit more.
and tmp and tmp next. It means that
Okay, what about now?
if we here let's proceed the code, simulate the process.
What about now?
Hit this and
He's too quiet now,
go
huh?
to the
Or is he good?
go
Okay. Say less.
to the or not just the TMP. Go to the 5
Okay.
and
After this, it's
the
over.
final
It's over.
code will be look something like this. Yeah. After that, we need
How's that,
to
chat?
if
Perfect.
we had TMP next will be equal to none, and previous will be equal to TMP like this, yeah. And in our case, T will equal to none. T is a temporary variable, so at the end of the cycle, we should return our previous variable like this. So it will store the reversed linked list. So yeah, let's quickly simulate the process. Like have previous, we save the next node, we bind previous to the current node, then move previous node to the current, and move temporary variable further on.
Sounds good.
Yeah, and we will move our current node until we don't reach the tail or end of the linked list like this. After a 5, we have a none. So after this assignee, on the next iteration of the cycle, it will not execute this area of code. And this while loop will be finished, ended. So, and the pref variable will store the last value of the initial single linked list, and this will be the answer or the root of our reversed linked list. So
Awesome. Yeah. Thanks for walking through that. Try running the code and see if it works. I'm just finishing my setup. And then we're gonna go into the actual interview.
okay, should I submit the code?
Pardon?
Can I submit?
Yep, submit the code, please.
Okay. Oh, uh, seems that it's past 028 test cases, so
Okay, submit fully. Good job. Reversing a linked list. Classic question. Classic. Okay, I'm just getting a sense of the level you're at. Good work.
thank you.
How do you feel about how do you feel about that question? Good warm up.
Oh yeah, good warm up. I'm a little bit nervous,
Yeah.
but I think warm up was good.
Awesome. Okay. One sec. All right. We're gonna move on to the next question.
Okay,
End your stream. Be like, or end the collaboration. End the collaboration because I'm gonna send you the next question.
okay, no problem. I'm ready.
Okay. Let me look for two good questions. Okay. Okay, I'm gonna find you one quick. Okay, I'm gonna turn this into a video as well. So I'm gonna start with some introductions, and we're gonna go straight into the real coding interview. Okay.
Okay.
One sec. Okay, this is gonna be a recording. So, hey everyone.
Okay.
So today I have a friend from Russia joining in, and he's gonna be going through a coding interview. So we're gonna ask two questions, and we're gonna try to keep it under 50 minutes. And I have my rubric here. I'll be marking him, and I'll be giving him candid feedback on his interviewing skills. We're gonna try to get through at least two questions in the next 50 minutes. Could you tell a little bit about your background and where you're gonna be interviewing for?
Okay, hi everyone. My name is Peter. I'm 20 years old and I'm self-taught programmer.
Hmm.
So currently I'm working nearly 1 year in a small company out staff as a web developer, Python web developer.
Hmm.
So and now I complete the final stage of the on-site interviews at Yandex company. Before that, I already complete three algorithmic sections interview. So, and on the next week, I show the complete the final stage with team meetings.
I see.
Okay, okay.
Awesome. And then like how many leak code questions have you done, and what would be like how good you think you are at leak code?
Oh, if there is a 10 scale, I think I'm under the 7, maybe 8,
I see.
10. So, okay, nearly done of 1,000 problems on lead code.
Wow.
So,
Good job. Is leak code big in Russia as well?
I think there's more famous like code forces,
I
if
see.
you know. Yeah.
I see. Code forces. Cool. All right.
And yeah,
Or go ahead. Go ahead.
okay. Um,
Um. Cool. Let's just start this interview then. Um. I'm gonna be sending you a link to a question. So
okay,
you're gonna
okay,
have 20 minutes to solve this question, and I'll give you a proper rating.
okay. Yeah, I'm see the link.
Okay.
It's a problem. Find the peak element.
Sure.
Okay.
Okay. Go ahead. Timer's at the
Um.
top right. At around 20 minutes, I'm gonna have to stop you, and we're gonna move on to the next question. Okay.
Okay. So, in under this 20 minutes, I showed um tell about algorithm idea and write the code, right?
Yep.
Okay. Define peak element. Peak element is an element that is strictly greater than its neighbors. Okay. Then its neighbors. Given a zero index integer array nouns, find the peak element and return its index. If the array contains multiple peaks, return any of the peaks. Okay. You may imagine that nums. In other words, an element is always considered to be strictly greater than a neighbor that it's outside the array. You must write an algorithm that runs in logarithmic time. Oh yeah. Hmm. Yeah. We went from the array is under the 1000, 10 power of 3. So in the range of the nums is um in the integer range. So and there is no duplicate. That's it here.
Yep.
There's no adjacency elements that are equal. So now we should use something faster than a linear passing through the whole the array and make it efficient. So
Mm-hmm.
okay. Okay. Logarithmic time. Okay. Um Order of the elements is not talking about this. Okay. Interesting question. So we should return index of the element, zero index element. Like in the first example, there are three. So if we show that in the logarithmic time, it seems that we should use a binary search here, but um how can we do that?
Mm-hmm.
Um, um, oh, we should find that number that greater than all of his neighbor. So let's consider that we have some number, and we this number should be greater than his adjacency neighbors. So, and how can we use binary search here? Hmm. Then it's neighbors.
Sounds good. Makes
Okay.
sense. So, okay. What are you thinking for approaches?
Um, for a binary search, we should use order it, some sorted sequence. So, um, how can we use this to find the peak number? So, um, currently, I didn't have idea how to use binary search because the input sequence is not sorted. So, um, um,
So our goal here is to find a peak element, right? Just any.
any of the peaks,
Yeah.
any of the peaks. So, okay, oh, his neighbors, greater than its neighbors. Okay, um, what is the logic statement we should use in the moving our left and right boundaries of
Mm-hmm.
binary search? So, um, okay, mm, okay, one. Mm, mhm. Um, 1, 2, 1, 3, 5, 6, 4. Okay. Um, Quick element. Okay. Um, my first thoughts was about a brute force solution, which is
Sure.
have a linear time complexity. We just scan through the whole array and check greedily um, left and right neighbors of the number and pick a first one that have a property of the peak element, but the time complexity of that code will be linear, but in the description of the task we shall do it faster in the logarithmic time.
Yeah, exactly.
So how can we use the property on binary search in the
So
logarithmic time?
there's always going to be a peak element for sure, right?
um,
We'll know that for sure. And we'll
eh,
also we'll know three things. I'll give you a small hint. We know three things for sure. We know all adjacent numbers are not equal to each other. So we can never get something like one, 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 right? And we also know
yeah.
the bounds are negative infinity. That's what they say. So all the numbers are going to be are all adjacent elements are not equal to each other, and the bounds are
Okay.
negative infinity. What would be the peak element here?
In the description, we see that the elements that are in the boundaries of the array
Mm-hmm.
always greater than their neighbors that outside the array, like minus infinity in this example. So, uh, if we see at this example, peak element in this array is free because he is greater than the his neighbor from the left, which is
Okay.
2, and outside of the array, value is minus infinity, so by default, element is more than this. So answer is 3.
Okay.
Okay,
Yeah.
so
Try it on this example. Try on this example. Example 2. I think you should work through an example and understand what's going on there.
okay, in this example we have also 3 as an answer because 3 is greater than his left neighbor and greater than the right neighbor. So, but what- mm, the problem
Chat,
here
how do you think he's
is
doing?
that I
What's the
don't
rating so far?
understand the logic of the binary search. So, if we have some middle value, like let's say that if we have 2, yeah, we compare this with each with left and right neighbor, and this is not a peak element. So, what do we need to do next? So, we need to move our left and right boundaries, but how? What is the question? Um, hmm. Okay.
So how can we remove half the search space every time?
Um. Okay. Uh. Let's half search space. So, what thing? This number is not a peak. Okay. Let's simulate the process of the binary search. Yeah. This
Mm-hmm.
is not a peak. Which of the pointers should we shrink, left or right? Let's
Mm-hmm.
think of it.
Yep. Let's think a little. Grab the mid and figure out should we search in the right or should we search in the left?
Um, let's think about if the current middle element is less than like is less than his right. Uh, his right neighbor we showed move left plus 1 pointer. And vice versa if the middle element is less than less than left neighbor, we should move right minus 1. But um, uh, general idea here is consider this number 2. We know that it's greater than the left neighbor, so and for sure if we move our pointer to the left, his neighbor will be not a peak element because 2 is greater than 1. So,
Sure.
by definition, 1 cannot be the peak
Mm-hmm.
element. So,
Sure.
we shall try another uh, area and move to the right.
Sure.
I mean, shrink pointer to the left is equal to my middle plus 1. So, and compare this. Um, if current in this example it will find the answer, but if the same logic is here, if like we have 4 and um let me do that like 7, something like this, we move from 2 to 3 and check
I
that
mean, but four is a peak element there, isn't it? Four is a valid answer.
um if we move um let's consider this example right here. If we move the next pointer to the left equal middle plus 1, we have boundaries like 4 and right here, and make binary search again, then check if 5 is less than the left child, we move to the right, and if the 5 is like um what is the example of
Okay,
that?
can I ask a question here?
Yeah.
What could you just explain to me what a peak element is? I just want to make sure you have a understanding of what the question is asking.
Peak element is the number such that greater than the left than his corresponding left and right neighbor. And if neighbor is not exist, in the case of the outside of the array,
Hmm.
the number will be by default greater than
Okay.
number outside.
Is
So
there is there a possibility that there's more than one peak element in the array?
uh, um, I think yeah,
Okay.
because um, there's no guarantee that integers are this guarantee us that adjacency integers are not equal, but some other integers like this can meet because 5 and 4 is not equal, but in the entire array we have double 4.
I see.
So
Okay, is there a pot is okay, for the answer, do we can we return any of the peak elements or just a single peak element?
we can return any of
Okay,
them.
sounds good. Okay, I think your example is too large here. Let's work with let's build an algorithm for a small example like this. A small example like this, and then maybe an example like this. And then I think you'll be able to come up with a solution. You're on the right track, but I think you're building too big of an example. Try to
Um,
build the algorithm to solve these two cases or
okay,
these.
can I write some lines of code just to
Sure,
clarify some?
sure.
Okay, let's consider that we have bound, okay, we can do this like left pointer will initially be is initialized by 0, right will be like 1 nonce, minus 1, and we will be iterate while left less than right, yeah. We will be calculate the middle element as left, right, minus left, something like this, yeah, and then check the answer for the medium peak. Let's make this. If firstly, let's check if the current middle number is a peak element. So
Sure.
to do that, we need to check if um, in the case of the middle minus one is if my middle minus one y commands middle greater than the something and the nums middle greater than something. What is a something? Something is nums middle minus 1 if middle, in the case where the middle is not 0, vice versa, it's a float minus inf. So, and let's use braces here to write this like this, and nums greater than nums middle plus 1 if middle plus 1 less than the length of the nums. Vice versa, it's also the float inf minus inf. If it is, if middle is greater than all his neighbors, we should immediately return the middle
Mm-hmm.
because this is a zero indexed output expected. We can just return the middle. Um, if middle is not a peak value, we should check if middle is less than his left child, like nums. We can use some variables to left, something like this. And the right. Else for minus inf, then check if middle greater than the maximum of this. If it is, we can just return a middle, or if middle is less than a left neighbor, then we know that potentially left neighbor can be the case here, something like this. Yeah. If our middle element is less than the left neighbor, it means that if a statement above not execute, that sum of neighbors of the middle, nums middle, sorry, sum of the neighbors of middle number greater than the middle number. So, and we show the choose which ones that are greater. So in the 11 line, we check that if left neighbor is greater, it means that we should shrink our right pointer to the left, and otherwise, if the right pointer is greater than the nums middle, we should move our left pointer to the right. So
Sure.
I think this will work.
Sounds good. All right. Good job. It was accepted. Let's move on to the next question.
Okay.
Okay. Good work. Let's see.
I should close it up. Close it up.
Yeah, and end out that interview collaboration.
Okay.
I'm gonna send you the next element.
Okay, thank you.
Okay. And I'll give feedback at the end of. But good job overall. Good job overall.
Thank you. Thank you.
And am I talking like good enough for you to understand as well?
Yeah. I can understand, but it's hard for me
To talk, right?
simultaneously speaking and think about the code. So,
Yeah. Obviously,
yeah.
because you also have to speak in
Yeah,
Russian, right?
yeah. But I can fully understand you. So,
Okay, makes sense. Cool. We're gonna move on to the next question. I'm gonna send you an
Okay.
invite. All right, join in.
Okay, wait me a second. Okay. Okay. Yeah.
All right, go ahead.
Shortest path in a binary matrix. Okay, sounds cool. Given a square matrix, binary matrix grid, return the length of the shortest clear path in the matrix. If there is no clear path, return -1. What is a clear path? Clear path in a binary matrix is a path from top left to the bottom right, such that all the visited cells of the path are 0. All the adjacency cells of the path are adirectionally connected. They are different and they share an edge or a corner. The length of the clear path is the number of visited cells of this path. So, what is the length of the grid? It's 100 and power of 2. So, length of the shortest clear path, and the clear path from top left to the top right, bottom right, and we showed with only zeros. And yeah, we can move in the A directions by up, down, left, right, and by diagonal, like 8 moves. And all of the paths should be connected by some corner or edge. It means that we cannot jump over the one cell, so
Mm-hmm.
it will be a consecutive path. So and length of clear path, the number of visited cells of his path. We showed return shortest path. Okay, shortest path problem. Um, okay, for firstly, I think about something like a backtracking uh, approach that will just use all possible moves and after all possibilities return the answer. But complexity of that code will be 2 power of no, it will be 4 power of n because we have 4 direction and on each
Mm-hmm.
path we can move to the maybe greater. So uh, if we know that we need to find the shortest path in this uh, matrix, and let's think of this how a problem on a graph, yeah,
Yeah.
and we know that we did not have cost or weighted graph. We
Mm-hmm.
didn't have a cost of destination from one vertices to another. So, and the cost of the path, overall path from the top left to the bottom right, will be equal to the length of the vertices that will pass from start to the end. So it means to find the shortest path, we need to make at least as possible. Uh, we need to use at least vertices as we can.
Yeah.
So to doing that, we can use a breadth first search because breadth first search approach will move by one on each move, and at as in the time when we get our top bottom right cell, we know that it the shortest possible path between over all possible paths
Mm-hmm.
because it's shortest one. Why it's shortest? Because of the property of breadth first search. We iterate through the all iterate level by level. We um, uh, we discover our path one by one at a time by
Sure.
breadth first search, and when we meet our final cell, like n minus 1, n minus 1, it means that if we move one by one at a time, it is the shortest path because we can do that. So we can create um, okay. So uh, firstly time complexity of that code will be all of um um and okay n times n times n
Okay.
square
So let me just get a
uh
sense of what your algorithm is. You're gonna start from the top left corner and you're gonna do a breadth first search to the bottom right.
yeah, exactly,
And
exactly.
since the
We should use a q
okay,
to make a FIFO order of the
and you think that it's gonna lead to the correct result because the weights in the graph are all the same, you said?
This is because we move one by one each time, and we to find a clear path, we should not make move on the cells that have a one that have ones in each value in his value. So we should move only by zeros, and cost of destination by each vertices from another will be just a number of moves that we make from the start to
Okay,
finish.
sounds
So
good. Okay.
by breadth first search, we can shorten our path as smallest as possible, because one by one we will be traverse from top left to the bottom right.
Okay.
So
Go ahead and implement that, please.
okay, we can create an adjacency matrix of Boolean to keep track, not repeating values, or just to simulate process, because one by one we if there one problem here, if there exists clear path, it means that if we did not if we not keep track already visited nodes, we can get div into infinity loop and infinity loop,
Mm-hmm.
because we will be just go through the cycle, and will not reach the bottom right. If like in the first example, we have one possible move by diagonal, but if in the n minus 1 in the last cell, uh, values of the cell will be not 0 but once, we cannot reach the end of the path. So, and there is no answer for us. So we can use either uh, hash set, to keep track of already visited nodes, that will contain a tuple, where the first element is a number of row and the second element is a number of call.
Sure.
So let me this, or create an adjacency matrix to mark for a constant time that we already visited. And I think I think we can use a hash set here, because um the values of the size of the matrix are under the 100, so it will be enough to store just n square possible pairs, possible cells in the matrix, which is equal to 10,000. So I think it's pretty enough. So let's create a set that will store a tuple of the initial pairs, then create a queue. Uh, to do that, we can use data structure, name it a queue. In the Python, it's the key from the collection model, or we can use a double lists,
Sounds good.
double arrays. First one will represent the current nodes, and the next one will represent the neighbors of the current nodes.
Mm-hmm.
So, or just use a single queue.
Okay.
So,
Sounds good.
um,
Hey, chat. How do you
let's
think he's doing? What are you giving him so far?
create a queue. Let me call this as a queue that will be store list of the tuple and int. Yeah.
Mm-hmm.
Let me write import here. Yeah, exactly.
Yep. Okay.
Deck and append queue, append our started value, which is 0 0. So, and in this case, we shall check if our start pointer are not 1. So if we start with a cell with value 1, and this cell is in the position 0 0, it means that there is no solution.
Mm-hmm.
It's guaranteed that there's no solution. So, and the size of the all matrix will be at least 1. So we can use just uh, direct index notation, like if grade 0. 0 it's equal to 1, just return -1 because there is no solution. So
Okay.
next we append to the queue our start position and mark this as a scene, as we seen that um as seen it, or okay, let me scene add 0 0. So then create a cycle while our queue is not empty. We will iterate through that. And first we need to current row, current call. We need to pop from our queue, pop left. So, and then we need to check if the current row is equal to current call, it's equal to n minus 1. We showed immediately we need to keep track the distance of the path, not destination, the distance one.
Yep.
So um if we let's add some third argument here, like a size of our path, and initially it will be equal to 0 because starting from the row 0 and the call 0 we didn't make any moves, so the path will be 0. So and we make the same cure path, something like this, or not a path, like a cost. I think it's a better meaning. So if we find the answer, we should immediately return the current cost of that. So
Sure.
uh, next we should check all
And just want to
possible values.
give a quick time check that we have about 5 minutes left for coding. So yeah, just want to give a time check.
Okay, let's hurry up. So let's check all possible neighbors that we can visit. So for we can use the tuple of the tuples for all. Let me create this, like list of tuple int, which is equal to this, which is equal to, if we start at -1 it's diagonal, and we have -1 0, which is just up, which is equal to -1 1. Then we have 0 -1. Then we have 0 1. Then we have 1 -1, and then we have 1 0, and we have 1 1 in diagonal. And the count it's 3 3 7 8 possible moves. So okay, for x y in the moves, next row, next call will be equal to cure row plus x, cure call plus y. And let's check if we don't go outside the boundaries first. So if the minimum of the next row and the next call greater or equal than 0, minimum of them, and if we have a square matrix, we can use like max of the next row, next call less than n. So if it is, we did not go outside the array. And the next we show check. And let's create this once. Braces, do this. Let's hurry up. Let's hurry up.
Yeah, don't like just code it now at this point. Go fast as you can.
Okay, okay. And
You don't have to explain every step. I get your
okay,
solution, but yeah, we need to keep it under the time because usually in the interview we don't want to go over.
So let me check this. I think I'm not mistyping. Or Q append next row, next calculate costs in add we show that a tuple instead of this. So show create a tuple here. So um integer integer scene is a set, not a list. So we have one great moves we did not comment here. So um and the path we showed q cost was 1. So what is the statement here? Synad next row next call. Um q append q cost next row next call. And the minimum of the next row next call greater than 0 and the maximum then was an n, and current next step is not 1, which is not, and the next row next one not in scene. If it is should x move.
You're
So
off by one. You're off by one. I think just include, like, just know that it's the number of cells that you visit. So look at example one.
okay.
So you shouldn't start at
um
0 essentially.
um here's I make a step in number of moves minus 1, which is this, minus 1 this, minus 1 0 can up, minus 1 1 0 minus 1 0 1 1 minus 1. Oh, yeah, here no,
No,
1
your
0.
solution is good, but you're off by one, right? Your output is one when it should be two, even for the simple example of the very first example.
Oh, yeah, we need to initialize our Q cost of the so.
Awesome. Yeah. Cool. Yeah. Looks like it's working. All right. How do you feel about your performance? How do you think you did?
So maybe it's nervous for me to speak and code, so I think it's maybe like a 3/5,
Three
like
over
this.
five.
So I think I will do this better. So
Okay. 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 I'll give you my feedback, and I'm doing it out of four, right? My rating is out of four. I'm gonna give
oh
you a 3 out of 4, right? I think what you did well is you have clean code. You're able to give a good thought process of what you're doing. Like, I understood where you're going and what direction you're following, because you're able to good have a good thought process. Yeah, I think I definitely could have this. I could get a sense that you know how to code and you know how to work through the solution. The main advice that I would give is, like, work through an example. Work through a very small example and try to make sure you understand what the problem is asking. For example, in the find the peak element, you weren't really working through an example, which made it so that it took you longer to find out the answer. Does that make sense?
yeah.
And even when you did work with the example, your example was too large. Like, it wasn't a good test case. So I started giving you hints on test cases that you can run, like very small ones, for you to get the algorithm, right?
Yeah, you're
So
right. Yeah,
so when you're stuck, work through an example, a very small example, and most of the time the examples that you're going to use are going to be small. It doesn't have to be a large example. But,
yeah.
like,
Understand.
interviewers
Yeah,
will
yeah,
also see how well you are at coming up with examples, because coming up with examples could show that you can capture edge cases,
yeah, yeah.
right? Okay, so I
I'm
think
I'm
with enough practice you can get to a 4 out of 4. But actually, my genuine feedback is it's a 3 out of 4, and the main advice would be work through small examples so you can get yourself unstuck. But overall, really good job.
Thank you for this opportunity. I'm happy to take a mock with you. So thank
Yeah.
you.
No, we can do it again. And when is your interview? When is your next one? We could probably do another one, and then let's see if you can improve on it as well on the next time.
Okay, okay. This is a great idea. So
Cool. All right. All right. Thank you. I'm gonna take on the next caller. Thanks for hopping on.
okay, thank you so
All right.
much.
See you.
Goodbye.
Good luck. Good luck.
Yeah,
Good luck.
bye.
See you. Yo, chat. How do you think he did? Who's in the chat? Who's in the chat? Chat. What are y'all thinking? 6 out of 10. I only give. I only go out of 4, so I would give him a higher, honestly. Hey, how's it going? What's up? Yo, how's it going?
Yo, what's good, bro?
What's up, man? How you doing? How you doing today?
I'm doing pretty good. I was a little tired because I was watching the Lakers into UFC, but I should be chilling now. How about you?
Lakers versus USC?
No, Lakers into UFC because Lakers played the Celtics.
Oh,
Yeah, yeah,
what do you think about that? The UFC and I mean, Lakers got slapped, right?
yeah. I mean, it wasn't that bad, bro. I was like in a VC with my friend. He's a LeBron fan. Like he was pretty mad the whole time, but I
Yeah,
was pretty sad that Pereira lost. Like I wanted him to win.
I heard it was boring. I didn't get to watch it though.
Yeah, bro. At the end, I'm pretty sure the guy just held on to Pereira so he couldn't like get any strikes on.
Yeah, I saw it was like right on the cage, and he's just like basically pushing up against the cage the whole time.
Yeah. Did you see the roofie fight?
No, I didn't. I didn't watch the fights at all yesterday. I
Oh
was out.
yeah, bro. There was this crazy knockout yesterday. I'm pretty sure if you search on Twitter, you'll probably see it.
Oh, the Justin Gaethje one. Oh, the spinning heel.
Yeah,
Yeah,
spinning heel, bro. Yo, that was crazy. Oh my.
nice. Yeah. By the way, you're on stream right now, so I
Oh
would.
yeah,
Yeah,
yeah. I
yeah.
was tuning in a little earlier.
Nice, nice, nice. Yeah. So if you don't want to leak any of your personal information, just, yeah, don't
It's
say
all good.
anything, names and stuff. But I'm gonna start the video, and we're gonna get right into this too. Okay, 3, 2, 1. Hey everyone. So today I have another coding interview with one of my friends who's ready to. Yeah, we're gonna do some leak code. Could you quickly introduce yourself and what companies you're aiming for, and also how many leak code questions you've solved?
Yeah. So my name is Richard. I go to the University of Waterloo. I'm currently a second year.
Nice.
I think when it comes to aiming for companies, I want to break out of Canada and get into the US. So anything like big tech, startup, late stage startup, like all those I'm pretty interested in. Um, I guess when it comes to lead code, I've done like a little over 500.
Wow.
Um, yeah, but I've just been like prepping for next year because I have something lined up for the summer. So I just want to
Nice.
make sure that like when the time comes, like I'm prepared.
Is it in Canada or in the US?
It's called Shopify.
Okay, I know. I'm from Canada as well, so I went.
Oh
I
yeah,
went
for
to
real?
Calgary. I'm from Calgary,
Oh,
so
nice.
are you
Yeah,
from
yeah.
Toronto?
Yeah, I'm from Toronto, but like I'm doing a co-op right now, so so I'm in Ottawa. Like there's
I
nothing to
see.
do
I
here.
see. All right. Cool. Um. Yeah. So we're gonna be working through some questions here. I'm gonna send you. I'm gonna try to get you into this coder pad. One sec. Try out this coder pad thing. Let me just bring it here. So, how many interviews have you done? How familiar are you with interviewing?
Um, I mean, like I feel like when it comes to like lead code interviews, I haven't done too many.
Hmm.
It's mainly been mock interviews with my friends.
I see. Okay. Are you
Yeah.
able to get into this chat? or get into the?
Yeah,
It's
I can
good.
see it
Okay,
now.
okay, 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 okay. Does it let you change the name or no?
My name?
Yeah, change the name quick or something. Or like log in with a bird.
Uh, I think it should be fine. I don't really mind my like name being
Yeah, they're
here.
gonna find
I
you.
don't really know how to change it either.
So what's a like? Have you been able to get interviews at U.S. companies? I know you work at Waterloo, and lots of kids from Waterloo try to get
Yeah,
into
nah,
US.
I haven't had any luck. Like, I'm gonna be honest. I think a lot of the times it's like pretty hard to get at a second year, but like I
I
know a lot of
see.
my friends are getting it, so I'm just preparing so like I don't get like because like half of my friends are already like about to go to the US, so I'm just making
Nice.
sure that I don't fall behind.
Yeah, yeah, you got this,
Yeah, I
bro.
haven't gotten the US ones yet.
All right, okay. I'm gonna set this up real quick, and we're gonna get right started with it. We're not gonna. I'm gonna disable code execution, and then from there, um, yeah, let's just hop straight into this. You said you did 500 questions, right? Let's start with
Yeah.
So this is how I'll tell you how I'm gonna mark it in a second.
Mm.
Um, so I'm pretty much, yeah. I'm gonna ask you two questions. You're gonna have 20 minutes to solve, around 25 minutes to solve each question. I like
Mm.
to do meta style interviews where you pretty much only have you try to solve two mediums within 20 to 25 minutes, and I'll mark using
Mm.
the um.
Yeah, sounds good. I think Meta is like one of my main targets that I want to get
All right,
into.
perfect, 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 perfect. I'm gonna drop this question in, and then you're gonna have 20 minutes to solve it.
Oh yeah, for sure. A string can be abbreviated by replacing any number of non-adjacent, non-empty strings with their lengths. The lengths should not have leading zeros. For example, a string such as substitution could be abbreviated as, but not limited to, S10N. So you have 10 letters in between the S and the N. You have SUB, 4 letters between the U and 4 letters between there. 12, so every letter gets substituted. SU, 3 letters in between I, etc., etc. The following are not valid abbreviations. So replace substrings are adjacent, so you can't have 2 substrings next to each other abbreviated as numbers. Can't have any leading zeros. You can't have any empty substrings. Given a string word and an abbreviation ABBR, return whether the string matches the given abbreviation. So a substring is a continuous non-empty sequence of characters within a string. And here we have an example. So I guess like without looking at the output yet, um, we'll have the word and we'll have its abbreviation. So I assume what's happening here is that we have our I and then we have 12. And that kind of replaces the 12 letters right after this I. So if we count 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then we are over here. So I'll just put a little break. And then now we're at this I, we're at this Z, and then we go 1, 2, 3, 4, and then we're at the end. So this should output true, which you can see right here.
Sure.
Yeah. And this one does not work because it's missing the L. So when you do A to E, you're doing APP and you miss the L and you have the E, so it's a false. Okay. So the constraints we have, our word is maximum 20 letters. That makes it pretty brute forceable. Our abbreviation length is at most going to be 10. An abbreviation consists of all lowercase, so that's important. English letters and digits, all the integers will fit in a 32-bit integer. Okay, yeah, I think the approach that first comes to mind is a two-pointer approach.
Sure.
So pretty much like what we're gonna do is that we're gonna track abbreviation and word with a pointer each. And then I think the main challenge of this question is somehow parsing out the numbers, which represent like the substrings that we're skipping past.
Mhm.
So ideally, like when we come across a number, we want to move our abbreviation pointer to the end of that number, and then I guess like yeah, because the number can't be like over 20 because of the constraints. Like we don't really have to worry about any like crazy long numbers. And then yeah, pretty much like after say you parse out a number, what you want to do is that you just want to skip that many places in the word pointer.
Sure.
And then once it's done, you want to make sure that everything matches properly.
Okay.
Yeah, so yeah, does that approach make sense?
Yeah, I think that solution works.
Okay, yeah, perfect.
Go ahead and code
Is
that.
there sorry?
Yeah, go ahead and write the code.
Okay, yeah. No function signature, right?
Let's see. How would you structure it?
Yeah, so I guess like if I were to follow the leak code, I would just go like valid abbreviation,
Hmm.
and then with itself you'd have like your word string. I guess they don't have string. Do they have string for type safety?
Don't worry about typing it.
All right, word. You have your
I'm just looking
abbreviation.
for optimal solution.
All right, yeah, perfect. And then it goes into a bool. So yeah, I guess like first we'd have our pointers. So I know like a lot of these coding interviews care about really good naming. So I guess we'll have like a BBR pointer,
Mhm.
and we'll also initialize our word pointer.
Sure.
Yeah. So pretty much the idea here is we want to compare the letters, word and ABBR, the abbreviation, using their pointers. If at any point they're different, then we can instantly exit out the function return false. If at any point they're the same, we can continue until it reaches the end.
Uh huh.
And the case where we do have a number, then we want to continue moving word pointer forward until we no longer have a number to kind of um, parse out the number that we have to skip across for our word, right? So I guess like what we could do is we can use a while loop. I feel like a while loop really works with what we want to do here. Um, yeah, so while and I'll just have a variable for the length of the word, and maybe let's do like I think we'll need to have it for both. So I'll have like yeah. And yeah, so pretty much the idea is that we are going to like our first while loop will kind of track the word length, and then the optional second while loop is going to track any like number that we see in our abbreviation.
Sure.
Yeah. So while word pointer is less than length of and then I guess we can also check this just for safety. And if we see that it's a number, so I believe like Python has built-in checkers for characters. So we have like is alpha and is digit. So we're just gonna check if ABBR of ABB pointer dot is digit. So I'm just gonna read the question just to make sure that yeah. So I guess like we are assuming that we're given like invalid substrings in the sense that like there's gonna be zeros, so empty substrings, and we can't have that. So I guess we'll first check if it's zero.
Sure.
Return false. And then what we're gonna do is that we're gonna extract our number. And in this case, we're gonna keep track of our number as 0. We're gonna loop until ABBR pointer, or like our while condition is while it's like while that ABBR pointer is within bounds, and it's also a number, so it's currently tracking a number. So while so we can check if it's is digit. And in this case, what we want to do is that we just want to multiply our current number by 10 to kind of like track that digit shift. And then we're gonna add the new one. So we'll have number is equal to number times 10. And then we're gonna add our current pointer, I believe. And then we're gonna increment our ABBR pointer.
Sure.
And then in this case, what we want to do is now we want to move this amount in our other pointer. And I guess like to save on some time complexity, instead of like manually going through each letter, because we don't really need to check anything for these letters, I feel like we could just increment our word pointer by that number we just extracted. If that makes sense. So word pointer plus equal to our number. And then now comes the case where we need to check if they are the same. So after we increment, what it will do is that it will like what our code will do is that it will go to the next number after the digit, and now we can like start comparing it as normal just to reduce duplicated code here. So what we're gonna do is that we're gonna check if the word does not equal to ABBR of ABBR pointer. This is like instantly one case where it's gonna be false, right? Or I guess like if we had some edge case where like our abbreviation maybe has like a number like 120 or like 25 or something crazy that's more than like the word length, then we'd probably get an index out of bounds right here. So I think it's probably smart to first check if we're within bounds. Does that make sense?
Yeah, that works. That makes sense.
And then otherwise we can just increment both pointers. Sorry, I'm used to using I and J. I don't really use these long. And then I guess like until the very end, when we're outside of our execution, we can return. Okay, let's think. I think there's like some edge cases when you look at here.
What edge case?
Yeah, so I think like immediately like I was thinking like, okay, return true because like everything executes properly, but there could be an edge case where like we get to the end, but our word pointer doesn't reach the end of the like we could have like A B B B E, and then maybe we have something like A to B. Like this would exit out without any issues, but we don't really encapsulate this last E. So we just want to make sure that both of our pointers like reach the end of their respective arrays. Is that, or like strings? So I guess like even if we had like A to B E E, yeah, I feel like that's the same thing, like where abbreviation doesn't reach to the end of its string. So pretty much the edge case, not really an edge case, but just to kind of make sure that we're capturing the right answer, we want to make sure that every string matches the substrings. We want to make sure that each letters match, and we also want to make sure that by the end of this entire loop, we want to make sure we get to like the end of both strings. So we can easily do that just by checking if word pointer is equal to our word length and abbreviation pointer. And I guess like yeah, so I guess if this is good, I can go through like one of the examples.
Yeah, let's do a dry run.
Oh yeah, perfect. Let's do the first example. Yeah, so pretty much we're gonna start with our word length and abbreviation length. This is a long word, I can't lie.
It's a
So we
long.
have 5.
Drop a like smaller example. Like
Okay, yeah, we can do like this one.
like craft your own small one.
Oh yeah, yeah, sure. So we can honestly go over the one that I had earlier, if that's good with you. So if we have A B B B, and we have like abbreviation equal to A to B, so expected should be false. Does that make sense? Because it doesn't get the E at the end. So if we run through our execution, we can see our word length starts at 5 and our abbreviation length starts at 3. So we instantly get into this execution where this condition is true trivially because our abbreviation and our word are both less than the length. So now we're checking if the abbreviation is digit at 0. So the first letter is not a digit, it's A. So we get to this part of the execution where now we want to check, do the words match and is the word pointer within bounds? So we already know that the word pointer is like within bounds, so this is false. And we can see that they're both equal as well, AA. So this part does not get executed, and what we would end up doing is that we would increment like our word and abbreviation pointer.
Mm-hmm.
So now like I guess for easier dry run tracking, we can just say like word pointer points to our B, ABBR pointer points to our 2. We see that it's a digit, so we get to this execution area where we see that it's not 0. We want to extract a number. Number is currently 0. We're pointing at a digit, and our pointer is within bounds. So we have numbers equal to 0 times 10 plus 2.
Mm-hmm.
Or I guess like I should convert this to an integer. I think that's one thing I forgot to do. Or else we will just be trying to add a string to a 0, which wouldn't work.
Sure.
Yeah. So then we increment our pointer. We see that now ABBR pointer points to B. And then say, okay, this is not a digit. Our number is just 2. We increment our word pointer by 2 more. So we're here originally. We go to the end, which is still pointing at B, but not like this B. And then we would go to the next execution. They're both pointing at B. We get to here. We see that they're both B and they're both within bounds. We increment both pointers by 1.
Mm-hmm.
So now ABBR pointer is now equal to 3, which kind of like violates this right here because our length was 3 and 3 is not less than 3. So then we get to the end of this execution, but we see that this one hasn't reached the end. Word pointer has a like its value is 3, but our length is 4. So because it's not equal to the length, it would return false. Even that this one is true, this one would be false. So it would just return false overall. If you like, I can also go through like a true example.
I think we're fine. Let's move on to the next question.
Oh yeah,
Good
perfect.
job.
Thank you.
Yep. Gonna probably delete this right here. So this is the next question. I'll explain it to you. I'll explain at a high level. So essentially, what we're doing is we're given a 0 indexed array of positive integers. Wait, let's see. Wait, is this the right question right now? Wait, let me read over it quickly.
Yeah.
Okay, let me give you a different one actually.
Yeah, I think I recognize this one. I remember I skipped it on the meta list because it looked pretty painful.
Let's see. Yeah, on the quarter pad, some of the questions are harder to to look at.
Yeah, I feel like when I switched from doing my mocks in leak code to quarter pad, it instantly became harder because I was so used to looking at leak code.
Yeah, exactly. That's why I'm kind of doing it on here.
Yeah. I'm pretty sure this one most companies do too, right? They
Yeah,
just do like
exactly.
when it okay, yeah, perfect.
Okay, so we're given a large n by n binary matrix, and you are allowed to change at most one element and convert it from 0 to 1. And you want to choose an element that will create like the largest island in the grid. So the grid given to you is going to be have like some islands in it, and then you can pretty much flip one bit from a 0 to 1, and your goal is to try to build the biggest island. Does that make
Okay,
sense?
wow. Okay. Um, yeah, so I guess like to understand the question better, I'm first gonna look over a couple of examples.
Nice.
So we have this grid, which I think is easier to visualize as just like 1, 0, and 0, 1. So it makes sense that if you flip like this one, we get 3, and this one we get 3 as well. So our output would be 3. Um, and then this one we can make 4 just by changing this last 0 to 1. And then this one is already 4, so you can't change anything. So I don't think I don't think these examples really do anything for us. So I'll create like I guess like a better example that
Sure.
might, yeah. So let's just say like we have something looking like this. Probably gonna extend this one more just so we can like try out different options. Yeah, so okay. Guess like we'll do what the hell? Actually, yeah, I feel like no matter which 0 we choose, we can kind of get that. So notice how this island up here has a length of 6,
Yeah.
um, or like a size of 6, this one has a size of 2. If we connect this 0, then it would be 2 plus 6 plus 1, so it will give us 9. However, if we just add it here, then it would only add 1 to this existing one, so 7. And this one is the same one as like the one we talked about earlier. It will give us 9 because it connects these two. So I think my first approach would probably be like it seems like a union find question where we have to connect like disjoint sets, but in this case our sets are looking like islands.
Mm-hmm.
And pretty much I think the hardest thing that we have to do is somehow know like if we're looking at each 0, like how do we know what the size of the island above, to the left, to the bottom, to the right is? And I think like the way that we can do that is that we can do some sort of hashing to make all one lookup, because obviously it's not ideal to like do brute force. So brute force would be to check every single 0, and then for every single 0 we would look up, left, down, right, and then count every single island. I think that's like super time intensive. We're doing a lot of repeated island calculations. So I think it's good to hash each island somehow. And the way that we can do this is that like if we were to traditionally look for the number of like or the size of each island, what we can do is that we can like go up, down, left, right at a 1, flip to a 0, and then eventually store your count through some sort of BFS or DFS. But because like we have unique islands, I think what we can do is that we can flip it to like an ID. So flip it to like 1, 2, 3, 4, and then by the end of our execution, we can store this ID to its size. And that's actually really convenient for us, right? Because when we're searching through the zeros, if we look up and then we see like let's say we ID this island as like 2, 2, 2, 2, 2, and then we store this 2 as like a hash. So we hash 2 to the size of 6, and we have 1 stored to 2. I think like what we can instantly do is that we can go like, okay, above me is the island 2. We can add 6. To the right is the island 1. We can add 2, and then we can add myself. So that way we can like very quickly access the size of islands. Does that make sense?
Okay. Yep.
So I think like this is not actually a traditional union find approach. I know like we don't really have to like have parents, I believe, or have any like helper function to find parents, no like unions. We're just kind of going through islands one by one and then hashing it. So I guess like if we were to do a function signature, let's just go connect islands self. Do we have anything other than our grid? Yeah, so we just have a grid, which is a matrix of strings, or okay, yeah, there's no strings here, so it'll just be an int. Yeah, so let's just first, is it a square grid? N by n, yeah. Yeah, so let's just first declare n as the length of the grid, and then let's also have our ID. I don't know if this is a keyword. I don't think it will matter, right? We'll have our ID start at 1. We'll have a helper to get size of island. Flip each land to a given ID. We'll have a hash map. So I think like it's really good to be very clear on what this hash map is storing and what it maps to, just so we don't get confused later. I guess we'll just name the ID to size. And what this will do is that it will map an ID to an island size. And yeah, so I think like when it comes to the helper, I'm more comfortable doing DFS, or not DFS, BFS.
Sure.
But I think traditionally it's done with DFS. I'm not sure. Yeah, so we're gonna be given an IJ and we're gonna be given a ID. So what we're gonna do is that we're gonna have our count is equal to 0. So this is just counting the size of our island. I guess a more fitting name would be like area. I guess we would start
Are you gonna do
it.
2 passes? Like, are you gonna first capture all the size of the different islands and then try to flip them, or do it all in one pass?
I'm trying to do it in one pass. So what we're doing is that, like, I know for traditional BFS we'd have a visited, but something cool that we can do is that we can modify the matrix in place. And what we're gonna do is that we're just gonna see all possible connected ones. We're gonna add those to the queue. Once we get to that area, we're gonna flip it to the index. We're gonna add it to our count. And by the end, what it should do is that it should just return our area when like our BFS is finished,
Sure.
if that makes sense.
Okay.
Oh yeah, and also let's have directions because this makes our code a little neater. So 1 0 0 1 -1 0 0 -1. Yeah. So what we're gonna do is that we're gonna have our queue is equal to a double inner queue, and I think in CoderPad I always have to import these. So we're gonna do q.append. We want an ij. That's all we need. We don't need, because we're not doing like DFS. We don't really need to like pass any dist or like area. So just kind of following the framework for like a normal BFS. What we're gonna do is that we're gonna do our cur ci cj. So this represents our current I and our current j is equal to q.popleft. What we're gonna do is that we're gonna flip our grid of CI CJ is equal to our ID. So this is kind of like almost tracking our visited. And then we're also going to increment our area. Now for DI DJ, so this is for each direction we can move in directions. We're going to have our new I and our new J is equal to CI plus DI. And then we'll have CJ plus DJ. And then here, what we're going to do is that we're going to have to check, okay, first, is it within bounds? So if 0, n, and 0, nj, n, and we want to make sure that grid of ni and nj. So first we're checking, is it within bounds? Second, we're checking if it's equal to a 1. So this means that, okay, this is a adjacently connected section that we haven't explored yet. What we're going to do is that we're just going...
Just grabbing water. Just keep explaining.
Oh, yeah, no worries. Yeah, no worries. Yeah, so what we're going to do here is that we're going to append to our queue. So we're going to append our new I and our new J. And then by the end of this execution, what it should have done is that it should have flipped all the IDs or flipped all the adjacent ones of this island that we're exploring to the IDs and also return the area, right? So by the end of this execution, I think we can just return area. And I think that's good for this BFS part of it. Yeah, so let's see. Now what we need to do is that we need to get all the areas, map it to an ID. And once we kind of do this one, like we pass through it once, maybe like to speed up so we don't have to go through and check all the zeros another time, we can like store our zeros maybe in like a list or a set of tuples. So we're gonna check our zeros as candidates.
what's up?
So let's just see like zeros.
Yo, chat, how do you think he's doing so far? What's everyone giving him?
Pretty much what we're gonna do now is that we're gonna go for I in range n, for j in range n. So what this should do is that it should loop through all of our possible coordinates. And now we're gonna check like, okay, if it's a 1, we're gonna explore the island. So when we call this helper, it's gonna recursively change all the IDs to our like specified ID that we pass in.
Okay.
If it's a 0, we're gonna add it here.
Doing DFS multiple times on the same.
Sorry?
How do we avoid doing DFS multiple times on the same cell? Like
yeah. I think like the way that we avoid this is that pretty much when we're doing DFS, so our condition to start DFS is if we encounter a grid that's equal to 1. So notice I just changed the ID to 2 because if we keep it as 1, then it might like do it continuously. But pretty much if each island is mapped with a unique ID that's not 1, that means that only like when we come across the 1, we can guarantee that 1 hasn't been explored yet. So that kind of allows us to avoid doing DFS on the same island over and over again.
Okay.
Yeah, good catch. I forgot ID should be 2. So we don't check that island over and over again. So pretty much if grid of ij is equal to 1, what we're going to do is that we're going to get our area, because this returns our area, we're going to do get size of island, and then we're going to pass our ij and our id. We're going to take our id to size map. We're going to hash the id, which is the, like because we changed the grids values in place to the ID of that island. This allows us like for any 0, we can check up, down, left, right. See like if we have something that's not 0 or 1, we know the ID of that island and we can instantly access its size without having to do DFS again. So this will map to its area, and then we'll have to increment our ID so we get unique ones after exploring the current island. Otherwise, if grid of ij is equal to 0, I'm going to add it to our like current set of candidates as tuples, because I don't want to risk like, say we have like some example where we have like 1, 1, like if we check this one, right, because we're going left to right, top down, by the time we get to this 0, if we check like up, down, left, right, then this one hasn't, actually it will have been explored yet. Yeah, so now this like bottom part hasn't been explored yet, so we haven't changed any IDs, we haven't saved it in our map. So we're missing out on our correct answer, which is why I think we're doing like kind of a 2-pass approach, where we first like go through all the islands and then we check zeros. And then like after this is done, we'll be processing each 0. Does that make sense so far?
Yep.
Yeah, so now it's time to process our zeros. So pretty much like we'll need our max area. And the idea between this of this is that we go through our zeros. We go through all of our directions, so up, down, left, right. We first check if it's within bounds, just so we don't get any index out of bounds.
Mm-hmm.
And then we check its ID. If we haven't seen its ID right now with 0 as a candidate, then we want to add it to our max area. Otherwise, we just continue looping through directions. And then by the end, like we will check our current area against our max area, if that makes sense.
Yep.
So for ij in zeros, check all 4 directions. And then we'll have our current area is equal to 0, or let's say it's 1, because we have to factor in the fact that when we flip our 0 to the 1, we'll be guaranteed to start at 1.
If for time check, we have 5 minutes of coding left, so let's make sure to, yeah,
Okay, yeah, all right, yeah, for sure.
do a good pace.
So dij in directions, we're going to check and we're also going to store a set just to make sure that we don't overcheck an ID, say in case like an adjacent island like envelops around the 0. We're just gonna use a hash set to store our IDs. If so we're checking if it's not a 0 and it's not a 1, and grid of ni nj not in set, so not in our scene set. So this is just checking like, do we have a unique island? Current area, we're gonna plus equal to our ID to size of grid of ni nj, and then we're gonna add it to our scene. And then at the very end, after this executes, we're going to compare it against our max area. So at the very end, we can return max area. Are there any edge cases that I need to think about? So if we have an entirely empty grid, we won't check any islands, right? And then we just flip our 1 over. So our max would end up being 1. We can run it like with a very trivial example, like right here.
Mm-hmm. Well, it's just looking good, looking solid. All right.
Yeah, so pretty much like I won't track down every line of code because it's kind of a lot.
way
I think we're short on time.
Yeah.
Yeah, so we're just gonna change this ID to 2 and change this ID to 3. This is like theoretically what I want my code to do. I'm pretty sure it does that, like, I hope.
Yep.
And then we'll have 2 mapped to an area of 1. So this is just in our hash.
Yep.
We'll have 2 mapped to our area of 1. We'll have 3 mapped to an area of 1. We'll have these 2 zeros as our candidates.
Mm-hmm.
So we'll have this is 0, 1, and we'll have that one as 1, 0.
Mm-hmm.
We'll check like up, down, left, right? So for candidate 0, 1, area is currently 1. We check up, that's 2. So we get 2. We check right, that's 3. Down and left will be both out of bounds, so we don't do anything there. So then our max is equal to 3. And then now for this candidate right here, our area is 1. We check left. Max is equal to, or our area would be 2. And then we check to down. Area gets added again. Compare against their max. Their max doesn't change. And this does give us our expected answer.
I see.
Wait, one edge case that I might be seeing is if we have a completely full grid, then we don't have any 0 candidates. So maybe like, yeah, in that case, we would be returning 0, which is incorrect. I think like we should set max area like before, like while we're processing each island. And then I think like while we're processing the island, we can have like the max island right now as like that max. So we can like check it here. Does that make sense?
Mm-hmm.
And our area. So yeah, I think that should do everything. It goes over all the edge cases.
I see.
Um,
Okay. What's your time and space
Yeah.
complexity?
yeah, so let's see. We first loop through every single ij, so that instantly puts us at n squared. But while we're like, the reason why I don't think it would be is because while we're like going through and then getting the size of each island, we're kind of changing the graph in place, and then we wouldn't really be doing any processing there. So I think like since we are visiting each island or each cell once, and then we call this helper, which doesn't really contribute because it's also traversing, and then we skip it if it's not a 1, and then we process all of our zeros, which would be O of n squared worst case, so it would be added on. And then this, we're looping through 4 directions, is bounded by a constant, so that doesn't contribute to our time complexity. You just make it like this part as 4n. I think it would be something along the lines of like O of n squared plus 4n, which eventually like reduces down to just an O of n squared solution. So our time would be O of n squared.
Okay. What about space?
Time. So when we look at space, we look at what we're storing, right? So worst case, maybe we have like n squared, or not n squared unique islands, but like our unique islands, worst case, will grow proportionally with our grid. So I think because we're hashing each, that would be already n squared. So I think we would also be like worst case O of n squared space complexity as well, because I think
Space
our hashes are. Sorry?
Okay. I see.
Yeah, area would be constant.
Are we can get an O of n squared? When are we gonna have an O of n squared space here?
Yeah, like what I was thinking is if we have like a checkered grid almost. So we have like 0, 1, 0, 1, and we have like 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0. Like even though we have like n squared divided by 2 different IDs we need to hash, I think like, yeah, worst case is if we have this like checkered pattern, which does grow proportionately,
Awesome.
but it's like a very weird like edge case. I think like usually it would be like, I mean, I guess it would be O of n squared because we can't really say like if, yeah, we'd
Yeah.
always have to account for a worst case. So I think it would be O of n squared as well.
Yep.
I'm not sure. I think
Okay.
like, yeah, I guess like size of recursive stack, we're not really recursing because we're not using DFS. We're storing directions. This is constant. This is constant. This is constant. This is constant.
Okay.
Yeah, I'm pretty confident it's O of n squared.
Okay. Sounds good. All right. We're gonna end the interview there. How do you think you did?
I think like surprisingly for me, because like string is like not really my strong suit. I feel like the first one I could have been a little bit more confident. I'm not sure if I got that one right. My code was kind of like long. Was that one in LeetCode easy?
It's a leak code easy, but people trip up on it
Yeah,
sometimes.
yeah. This one, I feel like because like I really enjoy matrix graph questions, I feel like I was a little bit more confident on this one, but it was just very long. So I feel like there's like a lot of places where I messed up on. Um, I think I communicated decently. Um, yeah, I always try to make sure like my interviewer understands my approach before I
Mm,
start coding. I think I give myself like out of 10, maybe like a 8.5.
nice. Okay. All right. I'll give you my feedback. I think overall, I would give you how these interviews are rated is usually out of four. So, like one is a strong no, two is no,
Mm-hmm.
three is yes, and four is strong yes. Like all the companies I've interviewed at, they just give you a rating from one to four. I'd actually
Mm-hmm.
give you a strong yes, honestly, over the
Okay,
four
that's a
questions.
relief. That's a relief. Appreciate it.
So let me go through my feedback on Q1, right? You did a good job reading through the question, understanding the inputs and the outputs well, and then reading the constraints and capturing the constraints. So you did a good job actually clarifying the question. You walked through your approaches, and it sounded before even writing code. You walked through the approaches, and it seemed like you knew exactly the solution. And then
Mm-hmm.
also you were able to get the optimal solution. And then afterwards, not only did you kind of propose your solution, the code that you wrote reflected the same solution you wrote. Sometimes people will say one thing then implement another, but you were able to do that. And I think
Mm-hmm.
that would just be a yes, but I think your autonomy, being able to lead the whole conversation and walk me through how you would solve the question, would push you over to a strong yes, and also your clean code and everything like that. I think that would
Mm-hmm.
have pushed you to a strong yes on the first question. For the second
Okay.
question, yeah, I think the second question, similar kind of stuff. You ask good questions. You're able to read the input and outputs well. Your code was really clean. You discussed the multiple approaches, and I could understand that you're going the right direction. You're walking me through your thought process really well. You like there were some edge cases that you missed, but you were able to catch some of them. Not really marking for like we're not really running the code, so I just want to get a sense of your
Mm-hmm.
thought process, and you explained that well. Good Python skills, good clean code. Yeah, and again, good autonomy and being able to catch the edge cases. That's why I'd give you a strong yes on the interview and move you on to like the next round.
Perfect. Appreciate it, bro.
Yeah, good luck
Um,
on more of the stuff. Do you have any questions for me on like yeah?
yeah, I guess like yeah, how's the YouTube going? I remember you recently hit 10K. I thought that was pretty sick because I was watching you like when you were like under a K.
Oh really? Nice. That's
Yeah,
crazy.
yeah.
I think it's going good. Like just keep dropping content. People really like these interview style questions, and I'm just trying to get as many people from different backgrounds and different schools
Mm.
just to get a sense of where people are at. Like I just interviewed some dude from Russia, and I want to interview other people from other places and kind of get a sense of
Oh,
like where everyone's at. I think everyone's pretty good at getting better at lead coder. The ones who want to hop on the stream definitely are pretty good.
yeah. I guess like another question I have is like, do you ever do like streams where you grow resumes or like anything behavioral
Yeah,
like outside the technical?
yeah, I do behavioral interviews. I just dropped a video where I was helping one of my friends for his first behavioral interview. And if you send me a resume and anonymize it, I can grill it.
Okay, perfect. And I guess like last question, you're Canadian, right? I remember
Yep.
you mentioned you were from Calgary.
Hmm.
Yeah. I guess like how's your experience like breaking into the US?
I think it was a good decision to move from Canada to US. I mean, Canada is good, but a lot of the jobs are in Vancouver and Toronto, and they'll
Mm-hmm.
still pay significantly less than the US companies. And then there's a lot of other companies that don't even hire in Canada at all. So I think it's a
Mm-hmm.
good decision if you're trying to make money, if you're trying to accelerate your career to go to the US. I mean, long term, maybe I'll go back to Canada. I actually like how people live in Canada a bit better. I like the vibe in Canada. obviously it's a lot colder and stuff. So like either I'll stay out in
Yeah,
Cali or I'll go back to Canada. But I like Cali.
yeah. I feel like the Cali weather is like low key a dream compared to what we got here. Like
It
I remember we
is.
had
It
a
is.
week straight of -20.
Bro, Calgary's even worse.
Yo, do you watch any sports?
Yeah, I watch. Like I actually run a UFC calendar too. Like I have a Chrome
Really?
extension, the UFC calendar Chrome extension. I run that one. Um, let's see.
I'll check that one out. Do you have a
Yeah.
favorite fighter?
Right now, my favorite fighter was John Jones at one point. But
Oh,
like,
you saw the John Jones versus Stipe, right?
yeah.
Yeah, that one's crazy. But yeah,
So
I,
I
I
watch.
appreciate you taking the time, bro.
Yeah, I watch basketball. I watch UFC. I watch. I don't really watch football, American football or soccer or anything. I pretty much watch just NBA and fighting. Like, but I also watch boxing.
Yeah, who do you support in the NBA? Or like, which team do you really mess with?
I was a big KD fan, but the Suns kind of suck right now. I like OKC
I
right
thought
now
he was
though.
getting traded.
I hope he
Oh yeah,
gets traded
OKC.
again to a good team. I mean, the
Yeah,
Suns were good until he came, so I don't know.
bro, I'm a huge Jokic fan, bro. Like when
Nice.
he dropped 30 20 20, that
That
was
was
crazy. I
crazy.
can't lie. But yeah,
All right, man. Nice
I
to
think
interview with you. Like, just message me.
yeah,
Like, do
same
you have
here.
me on LinkedIn and stuff?
Nah, let me
Yeah,
see.
like message me if you like looking for tips on resume, how to break it, stuff like that, referrals, all that stuff.
Yeah,
But
for
yeah,
sure, man. I appreciate you. Like, I appreciate what you're doing. Like mock interviewing a lot of engineers, like giving all this feedback.
yeah.
Um, and yeah, like good luck on your 10 hour stream, bro. I know 10 hours is crazy. I can't even get past like two or three sometimes when I'm mock interviewing my friends.
Yeah, no problem, man. All right, okay.
But
See you,
yeah,
bro. Good
all the
job.
best, bro.
All right, catch you.
Thank you, man.
See you. All right, who's the next guy? We got the next guy coming in. Yo, what? How does everyone think he did? What is everyone giving him? Yeah, I think he did good. I think he did good. Let's rest up for a few minutes. Yeah, strong hire for sure. Coding portion. Okay, we got somebody coming up in like 2 minutes. Let me take a 2 minute break. Nobody leave. 2 minute break. Hey, how's it going? What's up?
Yo. How's it going?
How you doing? I'm good. I'm good. What time is it
Pretty
over
good.
there?
Pretty good.
Where you based? In the U.S. or somewhere else?
No, I'm from basically Toronto, Mississauga.
Oh, nice, nice. From, are you in Waterloo too?
No. I'm not cracked by any means. I go to a regular school.
Are you in high school?
Um, Second year computer science student.
Alright. Damn, I got all the Toronto kids out here. Are you in the
Nice.
stream? If you are, just drop out the stream just so we can have a.
You left the stream. I think I should be
Okay,
good.
perfect. Because it will be like feedbacking and stuff.
Sounds good.
Alright. Okay, wait, we'll start this up. Let me get you into the quarter pad real quick.
Sounds good.
Mississauga. You live near the towers?
Yeah.
Or you live in the towers?
No, I don't live. But I live beside Square One, near, close enough. But yeah, it was nice to see Drake do that. Take a photo.
That's nice. How you feeling about the album?
Honestly, like I'm pretty nostalgic, even though I'm pretty young. I'll say like old Drake is really what I'm chasing. What I still listen to.
I feel like that was some old Drake vibe though.
Not even.
That was even like some P&D 2015. Classic.
I mean, it was good, but it's like the last album I really liked was Scorpion.
Oh, you like that? Yeah.
It's really just singles.
Yo, I was in high school when he dropped Nothing Was the Same. That's kind of how I got into him.
For me, it was I never used to listen before, and then I listened to Starboy by The Weeknd in grade 8, and then Drake dropped Scorpion when I was in grade 9, and it was just over from there.
Everyone's talking in their Toronto accent in the chat.
Awesome.
Let's see. You're in the try if you want.
Yeah.
Join with a random account, like a random email. If you let's see, it's gonna it might show your name.
Okay, let me see here. I mean, I don't have a random account, but does it show my full name right now, or does it show just my initials?
Let me find it. Okay, it shows your initials. Yeah. Cause someone hopped in
That's
last
good.
time with their full name.
Yeah, that's fine. Initials is probably
But he
common.
doesn't care. Yeah, everybody's from Toronto, Mississauga. This is lit. All right, let's run
Awesome.
it.
Are we live by any chance?
Yeah, we're live.
Okay.
All right. Okay, I'm gonna start. There's gonna be like a separate video itself too.
Mhm.
So I'm gonna like do a little intro.
Sounds good.
Let me just set up my notes. How's it out there though? Are you cold? Is it cold?
It's been really like cold, windy lately.
Okay, I'm gonna run this. Okay, I'm gonna start this up. Hey everyone, so today I got a friend from Mississauga joining in. He's about to do a coding interview. We're gonna try to get through a couple questions in a span of 50 minutes. Spend about 20 to 25 minutes in each question. Could you quickly just introduce yourself? Like basically just tell me like what year you are in school, what companies you're aiming for, maybe how many leak code questions you solve, where you think you are with algos and stuff like that.
Yeah, hello everyone. I'm a second year computer science student.
Yo, chat, how's the
I
audio?
wouldn't say I'm cracked by any means. I've done maybe 40 to 50 leak code questions, and most of them easy. Yeah, just kind of wanted to see where I'm at and how far I have to go.
Nice. Cool. Yeah, let's just get started with the first question. We're gonna go with we'll do some warm up. I'll post in the question.
Sounds good.
Yeah, I'll give it like, yeah. Let's work through this question. This is the first question. So, I'll say it at a high level. We're given a string, right? And we want to see if the string, we just want to return a Boolean value. True if the string could become a palindrome, and false if it's not a palindrome. But we could remove up to one. We can delete one element there. So yeah, you can see the first example is just a palindrome without deleting anything. And then you can see example 2 is a palindrome, but if we delete one character. So we could choose to delete a character or not delete a character, but we just have to return a Boolean if we or if it can get to a palindrome. Does it make sense?
Yeah, that makes sense. All right. So I see here you already have the constraints for us. So that's convenient.
Exactly.
I'm just gonna read over the question and then see if I understand it correctly. So just to confirm, a palindrome is a word that's the same forward as it is backward.
Yeah.
And we can have at least one character removed, so we can just ignore it and see if that string is still a palindrome.
Yeah.
Okay, so let's see here. Immediately, like what comes to mind is maybe we have a pointer in the beginning and a pointer at the end, and we just constantly see if they're equal, and we have like a count of like differences, and if there's more than one that's different, then we can just return false. Otherwise, we keep going until the middle character, and then we return true at the end if it does work.
Yeah.
So that's what I'm thinking right now. Does
For
that
palindrome?
sound good to code?
Okay, let's walk through like example 2. How would that work?
Okay, so I'd have a pointer. Maybe here. Oops. So let's say if this was the word, we would have a pointer probably at A and a pointer at the two A's, and essentially we should be good because they're both equal to each other. And then let's see here, we go on to the next loop. So we move B up 1 and then we move C up 1, and here we see B and C are different. So we can try. Okay, I see here where I might be flawed because B and C here. Which one do we move up? That's an interesting point because actually it wouldn't really matter in this case because if you remove the B or the C, it would work out. So you get rid of any and see if that works. And in this case, let's just choose to get rid of the B. Oops. So if you choose to get rid of the B here, and we set both of them to the C, then we see that is indeed a palindrome, and then we can return true at the end. But it does feel convenient that it worked out here. I would imagine maybe, let's see here. Let's say we had a scenario. Over. Really trying to think this through. Let's say maybe this was separated by like a G here. A and B are the same, and then we say C and C. Will this still work out? If A and A, C and C is the same. So, here. Well, I guess in the case where they're beside each other in the middle, you can get rid of either, so it should not really affect us. Interesting. Okay, so in that case, I think I should start coding. So
Let's see. Okay. So what's your solution for, okay, we have a mismatch. Which one do we delete?
mhm. We have A, C, B. I'm just gonna assume to remove the leftmost one for now. Um,
Left one?
or maybe we could check the next character over, um, and see if any of the two characters equal to that next over character, and then from there we can do the comparison. Um, but we'd also have to check the constraint where the left side is not greater than the right side, because then that means we're overlapping. So, and if we do find more than one character, then I guess we could skip it over. Would that make sense? Or does that
Oh,
does
wait,
that
wait.
sound?
Okay. Sorry, I was looking at the chat. Could you quickly explain again, like what happens if we have a mismatch? Pretend like we have A, B, C, A, and then like D here. How do we handle this mismatch?
Okay, so we have the two A's at the end, then we check that and it turns out fine. Then we have the B and C. We do compare that.
Mm-hmm.
We see that they're not equal. So to figure out which pointers we're gonna move forward, first of all, we're gonna increment our mismatch count, right? Because we know we can only change one character or remove one character,
Yeah.
and then we're gonna compare the next over character. So if it's on the left side, the next character would be D, and then if it's from the right side, we'd see it would also be D, and we would essentially compare, does B and D equal? Because if it does, then we know that we want to increment the right side. We want to
Okay.
skip over the right one, and then with the opposite, when you have B and C, then if they're equal, so for example, if C and D were equal, then we skip over um, the left side.
Okay. I mean, try. Yeah, I think we can get to coding. Try it out.
Okay, so assuming we get S as an input, um, I guess that's all we really need. So if we were to make a function, is pal, and then we get S as a string.
Sure.
Okay, so really we want to have two pointers, I guess. Our left side is we're gonna have our left and right side. Left side is just going to be initialized to 0, and then our right side is going to be set to the lengths of S. Oops. S minus 1.
Sure.
And then also, before that, we also need to check, because we know it's a palindrome automatically, if the length of S is equal to. So if it was anything less than or equal to 1, then we can just automatically assume it's a palindrome. Or at least that's what I'm assuming. Is that safe to assume?
Sure.
And then maybe you can just return true right away. Oops. Okay. Oops. Okay, so we have our left and right pointers. So now essentially, while the left hand side is less than the right hand side, what do you want to do here? So as we discussed earlier, we're essentially going to see if our string of the left side is equal to our string of the right side. And if they are, then we can just continue. So no issues there. So actually, let me just reverse the logic here. Oops. So let me say we're only really concerned if they're not equal. So what do you do if it's not equal? We have our two A's. If we get outside of this, then we know that they're equal, so we can just increment our left pointer, and then we can also subtract our right pointer. Let's see here. Why is failing at me? But otherwise, for here, now we're gonna deal with the case where they mismatch. So we have A and A. Let's use this as an example. So we know that in the second run where B and C, we're looking into that. With B and C, they're not equal. So we do need our other variable that keeps track of mismatches. Mismatch. I want to have that as E0, but we also know that mismatch is at 0. Let's see here. We have A and A, B and C. So we will first want to increment our mismatches. Oops. Let me see if I can just quickly pick that mismatches. And quickly check if mismatches is greater than 1, because that's all we're allowing at the moment, and we can return false if it is. Otherwise, outside of this loop in the function, we can just, I just want to remember to return true here. True. So we have our left here. Okay, so that's good. Okay, so we have our left side and the right side, and then mismatch the other one. Mismatches, okay. So now that we know that mismatches is less than 1, we'd probably want to see which pointer do you want to move, the left or the right side. So earlier, what I was saying was the B and the C. So let's see here. We want to look over at the one next over and compare that to see if they would match. So, so the first thing I'll probably check is if, since we're jumping over now, I guess we do kind of have to see if left plus 1, whoops, if left plus 1 is still, if it's greater than, and I'm kind of at the point where my solution is probably bad because I'm overwriting, like the code is not very succinct, but I'm still going to continue now. If left plus 1 is right, let's see here. I just want to recheck the condition just in case, because if left plus 1 or right minus 1, so if left,
No, it's talking to.
yeah, you good.
Talk to someone in the chat.
So let's see here.
So what's happening here? You're trying to figure out which one to delete.
Just give me a moment to think about this, because I don't have much faith in my approach right now. So let's see here.
Yo, chat. How you think he's doing?
Yeah, the A and A. And I'm just thinking like hash map somewhere, maybe.
Hash map.
Listen, when you're confused, just throw a hash map at it. Okay.
Okay, where are we at right now? Like, okay, we're removing the left and right pointers. That makes sense.
Mm-hmm.
If there's a mismatch, We're gonna increment the mismatch. I think everything is working there properly, but where you're trying to figure out is like, what do we delete?
Yeah, which pointer would you move up? Um, Honestly, like, let me see here. If B and C are not equal, just ignore either one of them. Doesn't matter. But in this case, we have B and C here. Which one do you move up? Let's say like this was B. Naturally, you would want to delete the D itself. Oh, that's interesting. I did not even account for that in this scenario. So you have
Okay,
A, B.
let me think about this case. Back up real quick. Oh, sorry. What if this was a B? Who are we deleting?
We would definitely delete the C.
Okay, we delete the C. Okay.
Let me just think about it.
What if we had this? Which one are we deleting?
You delete the C still.
On the left side, right?
Yeah.
Okay, I'll give you a small hint.
Mhm.
Just try deleting both. And return true if one or the other works.
Okay, so you delete the B and you delete the C. Let's see what would happen there. So you delete the B and you delete this. So
Or no,
if you just
try
move
deleting one or try deleting the other. You can't delete both, you only get one deletion, right?
Okay. So if you were to delete. Okay, so let's say you delete the left one and then you see if that works. And then you delete the right one to see if that works. Okay, and then you go with the one that works.
Uh-huh.
Now that makes sense. Okay. So you have the left one and then you have the right one and then you delete the one that wouldn't work.
Mm-hmm.
So you have C. Okay. So you have your left pointer, you have the right pointer. A, and then you go C, B. And then let's say you want to try the left side first. So you delete the left side by moving the pointer up. And then you return it back if it doesn't work. And then, okay. So in that case, so what I would do is I would compare. I'll move the left pointer. Okay. That makes sense. Okay, so I would move the left pointer up, see if it's equal to the right pointer. And then if that doesn't work, we're gonna try one more. We're gonna return the left pointer back. And then we're gonna try moving up the right pointer. And if that works, we're gonna continue with that, but we're gonna keep the mismatches +1.
Yep.
Okay. So we have S of L does not equal to S of right. You add the mismatches +1. So what we want to try is here. We want to see if. Let's first try moving up the left side up 1. Oops. Let's see here. So you have S of L, and we're gonna try moving up the right side up first. We're gonna see if that's equal to S of the right. So if it is equal, then you can just continue on to the next loop. So we continue on to the next loop, and then if, let's see here, if S of, oops, right plus 1, oh, sorry, minus 1 here, is equal to L, then we also continue. And before we continue, we probably, let me see here, am I forgetting something? I've never actually added 1 to L, so let me just quickly do that. Add 1 to L here, and then here, I never actually subtracted 1, so we probably want to do that before we continue, otherwise it's going to be an infinite loop. And then from there, let's see here. Now, how would this work? So let's use our A, C, B, B, A as example. if I just copy that down. Oh, it seems like I kind of got rid of my check for mismatches real quick. So when we add the mismatches, I still want to see if mismatches is greater than 1. It is, you also want to return false here. Okay. So that looks good. Okay, so now let's do a quick dry run to see if everything's working as intended.
Yeah.
Let's see here.
Okay, I think it makes sense. Let's move on to the next question because we want to make sure we get like more
Sounds good.
questions in. I'm gonna put in the next question or leave that there. We're gonna go below and I'm gonna ask you the next question.
Sounds good.
Let me.
Okay. Let's see here.
So we're gonna be given two sparse vectors.
Mm-hmm.
Compute the dot product of these two sparse vectors.
Okay, let's see here. So I haven't have the slightest idea what I'm looking at here, but I'm gonna try and
I can explain what the dot. Well, the dot product is pretty much multiply each element by like the. So index 0 here has to be multiplied by index 0 nums 2. Index 1 needs to be multiplied by index 1 of nums 2, and then you sum all those together.
Oh, so essentially you multiply the first element of both. Each index to its corresponding index.
Yeah.
And then from there, you add up everything?
Yeah. What? Like try it out on the input and see the output that you get.
Yeah. So here, I guess it would be 1 times 0, so it would be 0 plus. I guess the first 3 would be 0 because you're just multiplying 0, 0. 2 and 3 here we have 2 times 4, that would be 8. So, and then you would have 3 times 0, which would still be 0, and then you end up with 0 at the end. So it'd be equal to 3. Okay, makes sense. Okay. Honestly, this one doesn't seem too bad at all. So what I'm thinking is you just have 2 point. Sorry. Just want to confirm if the length of the two nums will always be equal.
Yep.
Okay. In that case, you would just have a pointer in the beginning of each one, and you would multiply them, add it to your current sum that you're keeping track of, and you would continue on until the for loop ends. And that's about it, really. And then you just return the sum. So this one doesn't seem too bad. Okay. So in that case, I'll get to coding out. So dot. Hopefully this name is not taken. Dot product. And then we have, let's say, I guess you're taking. Oh, you don't have to worry about types, but I guess it would be still an integer, or would it be? Float. Cancel what I said. Just forget it. I'll be honest. Just you get the two variables, two lists. So we have list 1. So let's just call it list 1, and then we would have list 2.
Sure.
And then okay, so essentially you would just have let's see here. You would just have result, which is going to be result sum, I guess I could call it. Give it initial value of 0.
Chat, what do you think
for,
so far? GMT saying he's jumping around a little bit.
What do you give him
on the first question?
Range,
out of 4.
Length of, I guess we can use any list because they're both the same, really. Length. But maybe if they were different, we'd use the minimum and then we would process the end of the second list later. But from there, I guess we have the index, we have the list, so we just want to do sum plus equal the product of. Oops, I just realized I called this result sum, and then we just do list one of index times list two of index, and so when this for loop ends, we would go through the whole array and then return result sum. So let's just do a quick run.
Yeah, let's do a dry run.
Okay, so let's say we got these inputs. Oops. One more. Oops. Okay, so let's say we got this over here. Oops. Okay, so what would happen is we first have our first variable, which is result sum, and that's going to be equal to 0 on the first run. Then we're going to have our index, which is going to also be equal to 0 on our first run. From there, we're essentially looking at, let's see here. We're looking at the first index here. Oops. So you could imagine how this would go. So we're trying to add, what's going to happen after this runs, you're basically adding 0 to 0. So you can just skip over that because the result sum won't change. And then our second iteration, conveniently can move both up at once. That's also going to be 0, so you can skip over that. And let's just skip over all the zeros here because we know 0 times anything is going to be 0. 0, 0, and then we go here. So we finally, in this loop, we're going to know that we're going to have to add 6 because 2 times 3 is going to be equal to 6, and our index here is going to change, so it's 0, 1, 2, 3, 4. So we know that this is a fourth index. And I just realized I'm kind of assuming that the code is going to work. I'm not really running through my code, so let's actually do that. So now we know index is 6, and then the length, we have our list 1. We have our result sum, which is still equal to 0, and then plus 6, because we know that our index is 4. So what that means is it's going to head over to the fourth one, and you're going to do 2 times 3, which is going to equal to 6. And then we can skip over 5 here because we know that 5 is 0 as well. So let's head over to, and let me just increment my result sum. So now that we know that result sum is 6, and we know that we're in the last element here where it's 6, and then we know that 4 times 0 also is 0. So at the end we return 6, and is that the same? It turns out our output is going to be the same. So even in the last index we're adding 0, so our output is going to be 6, which matches the correct output. Does that look good? I can't hear you for speaking, but I do see you typing, so...
Oh crap, 1 second. Sorry, I messed it up. Okay, we're going to change this up a little bit. Sorry, my bad.
Mhm.
Can you hear me now?
Yeah, I can hear you.
So what we're going to do is we're going to create this dot product class where it has a constructor. In the constructor, we're going to pass in the first list, and then we're going to have dot product, right? which is gonna take in a second list, and this list, this dot product could be called up, is gonna be called 1,000 times with different list, right? So
Okay.
how would you update this code so that we can call this dot product with different lists and compute the dot product against list one?
So sorry, you said compute the dot product against which list?
So we're gonna create a dot product, right? And we're gonna pass in list one, which is gonna be something like this, right? And then later we're gonna compute dot product like this with a bunch of different lists, right? We're gonna call it up with 1,000 different lists, and the lists are
Sounds
gonna be
good.
like different. How would you
So
update this
list
code?
one stays the same?
Yeah, list one stays the same.
Okay. So I would probably just have maybe a final variable up top with I'm not sure if final actually works this way in Python, but I'm still gonna type it out anyway. Probably should not use something I'm not familiar with in the interview.
Yeah.
But I'm just gonna say final underscore list one. That's kind of wordy, but I think it should do the job. And then set it equal to something that probably shouldn't change. Which list would we be using?
Well, okay, we're gonna instantiate dot product with list one, and then we're gonna call dot product 1,000 different times with a second with different lists, and we need to be able to output the result.
Okay, so in that case, I'll probably just say final list one. Let's see here, self, just so that we can know which list for which object, because we might have different lists for different objects. Just call this list one is going to equal to list list one. I think that should be enough for initializing anything really.
Okay.
And then for our dot product, we know that we have list two, so but we probably just can use the length of. Oh, sorry. So I just realized I didn't check in with anything. So we can still assume all the same constraints from before, right?
Yep.
Okay, sounds good. So we can use any list. So I'm just gonna use the list. Do we need to do any input validation? For example, if list two or too long or anything.
I think we can assume that the input is correct.
Okay. So in that case, even though we can use the length of list two, I would just to be on the safer end, I'm gonna use our very own list one, just so we can keep things safe. And then from here, we would just do our own self of list one. And then we're going to times it by the list two that we get. And then we can return the result sum. And yeah, I think this looks about right. And this should.
So I mentioned that the okay, what's your time and space complexity here?
I would assume everything is O of n because we're doing one path through, starting at the beginning and going to the end, and we know that addition multiplication is all just O of 1, so it doesn't really affect.
What about space?
In terms of space, here we'd have O of n for this list, and then our input would also be O of n, and then we'd have O of 1 for storage here, our result.
Yeah. Well, actually, our list 2 here is like we're not really using we're not creating any extra space when we're given the input, right? But we are creating extra space here.
Yeah. So in that case, it would just be O of n, and we can assume result sum is negligible.
Okay. I mentioned that the vector was sparse, right? So is there any way that we can optimize for space here?
Okay. Let's see here. For space. I mean, we can turn it into an ordered set if that exists. I think it was ordered dictionary, but essentially, no. But then you're not keeping track of which indexes. 1 second, let me see here. So we have a list one. If you have zeros a bunch of everywhere, and then you have ones here. Assuming um, assuming that the list would be very, very large and mappings between, let's say we have 0, 1 here.
Like pretend we just had a massive array. All of it was zeros for list one.
Mm-hmm.
And then just like one something there. Right?
Mm-hmm.
And then like, okay, then we'd create a copy of that and we're storing it in there in list
So
one, right?
what's coming to mind is we process list one first, right?
Sure.
And essentially we get rid of everything that's not 0 and we store the index it's at, right? And the current number that's actually stored. And then when we're iterating over our list 2, we can skip through everything and just focus on our our key value pairs in our dictionary.
Mm-hmm.
So in that case, let's in our initializer, I if we had more time, probably make a separate function and could just call it setup or something. But let's just do it in our initializer for now. So so this won't change our time complexity, I guess, but for our space complexity, it should help. For num in, let's see here. All right, we still have our list one. So for num in, let me see here. Let's just use index for example, because we need that as well. So for index in range length nums, we call the list one here list one. Let's see, list one, and we're gonna have to have our dictionary as well. So self dot, let's call it, I guess, dict mappings. Okay, hopefully that's not a reserved keyword. And we just have it empty for now. And essentially what we're gonna do is anytime, trying to remember self-dict mappings. So for if index is, if list one of index does not equal to 0, then what we could do is just store it into our hash map. So I'm trying to remember actually how to do that here. I think we can just say this of the key, which is going to be our index, is going to equal to our value, which is going to be equal to list one of index. List one of index. Oh, oops. So I'm also going to need self here. Okay, so index. So essentially what now we're doing is we have a dictionary that's hopefully much, much smaller than our original input.
Mm-hmm.
That only has 2 pairs. That only contains pairs between indexes and values.
Mm-hmm.
So now we can actually get rid of this list one completely because we don't even need to store it. And then for our dot product, let's see here. So we were currently, before we were iterating through the length, but now, I'm trying to remember, I think there was a function called enumerate. So we're going to do index and value and probably enumerate over our dictionary. Let's see here. Actually, Let me see. No, sorry. Completely lost the plot here. I don't know what I'm doing here, but I'm gonna do. Pretty sure. Let me see here. Self dot data mappings. So now, trying to think. I think this. Okay, we're not getting the value here, so I'm trying to remember. Was it dot values or was it enumerate? Let me see here. No. Or maybe was it dot item? There was some function, convenient function, for this to work. Well, regardless, you know what? Let's just do this.
I think that works. Yeah. Let's assume that items returns the first part is the index and the next part is the value.
I think we could also do this just so we can have something that works. So if you just go through every pair and then you just say index, comma val, and then you can just say pair. You know what? Let's just assume it works.
Yeah.
Okay. Okay. So, index and value.
Like, I mean, we're not running the code, so we're.
Okay, sounds good. So yeah, we have the index and we have the value, and we still have our list too. So what we're going to do is we're still going to multiply the index of our second list, but for our first one, we're actually going to the value stored in our hash map. So I'm just going to copy over this and paste there. So essentially, whichever value is stored with our key value pair is going to be the current number at that index, and we're going to multiply it times our list 2 of the index, and this should be a lot quicker. Hopefully have a lot less memory involved, assuming that there's a lot of zeros. So like maybe as long as the length of our dictionary times 2, if there's more zeros in there in the list that we started with then this should be a lot more space efficient. Otherwise, if our starting list is much smaller, then it wouldn't really matter.
I see. Okay. Nice.
But it'll
Cool.
still be faster in terms
Yeah.
of like.
Because now you're literally like for that big one, you're only gonna do like one operation, which is like capture the first index, or because you only have one element in the index or one element in the hash map, and then you only look in the list 2 like once. I think, right? Yeah.
Yeah, that makes sense. That makes sense.
Cool. All right. How do you think you did?
I would say depends on what the bar is. If it's definitely like Fang or anything, big tech, definitely flopped. But if it's like just a Fortune 500, I think personality hire maybe. But yeah, that's about.
All right. Yeah, definitely personality A+. I'll give you my feedback. Honestly, you almost came back from a 3-1. The first question was definitely like a no, but the second question was definitely a yes. Right? So between averaging those two, I'd still lean towards a no. But I think with enough practice, you're definitely going to be able to get a yes, and from there, able to get to a strong yes. I think that was a solid performance, especially for a second year. I'll tell you what you did good and what you did bad. Let's start with the first question. You're able to clarify the question well, like figuring out like what a palindrome is, and then walking through an approach. But the main thing you couldn't get there was the edge case of which one should I delete, either delete the left one and the right one. And then I had to give a hint there, so that's why I had to like drop it to a no, because I had to give too much of a hint. But I think even if I did get the hint, I think you'd still be able, if you were able to actually implement it based on the hint, I would have given a yes. But even the solution that you implemented after still wouldn't work. Are you able to follow my cursor here?
Let me just scroll up, I think. Okay.
Yeah,
so
like
now
here. Yeah, you're gonna either remove one or the other. But what you could do is like because you need to try both scenarios. So one way to do is like recursively, like try to delete one pointer and then recursively see if that's gonna return true, and then try it for the other one. Because here, how do you're not able to try both cases in this one, right? But I think
Yeah.
overall, really good job of able to understanding the question at a high level. I think for second year, you're really good. But yeah, able to talk to a thought process. I think how you do your interview is good. You just need more practice because you couldn't get to optimal solution. So
Sounds good.
yeah, so that was the first one. The second one you did a lot better, but I have to judge you on both of the questions. That's so I think the second question is you're able to talk to a solution. You do know Python syntax really well. You're able to get to the optimal solution. You definitely know your fundamentals of like throwing a hash map at it. You just need more practice, man. That's it. But I think how many
Sounds
questions
good.
have you done in general?
So this is I've alone without looking at any solutions like 40 to 50,
Mhm.
but I've done about 180. But just watching like Code videos when I'm bored.
Nice. Okay. No, you're good. Like for a second year, you're better than I was at a second year. I think definitely, cracking Fang, it would have been a no but for other companies, yes. But and it's not like a hard no. Like you're really close. I could see that I think you're just getting through the questions slower than we need to. You need to be a lot faster at coming up with the solution, talking through the edge case. Like there's still a lot of room for improvement.
Yeah, and hopefully I can come back in 3 months much
Yeah,
better,
let's get
and we
it.
can.
Yeah,
do
I'll
the-
message you, and then
Sounds good.
I think one more thing would just be use snake casing, because you're in Python and you're doing camel case. So I would use snake case. That's about it.
Sounds
But
good.
overall, really good job, honestly.
Man, I
Thanks for
appreciate
coming
it
up
so
with it.
much.
Yeah. How do you feel? Like, did it help the interview? And
No,
like, how do you feel about the
100%.
feedback?
Honestly, amazing because like I'm not gonna lie to you, I flopped so many interviews this year, including the most recent one being Apple. So
Wow. No.
like,
Okay, we're gonna
I've
get you
always-
right, man.
never took Code serious, but now I'm starting to think like maybe I should lock in a bit. You know what I'm saying?
Yeah.
So I'm
Honestly,
excited,
you're
you
really
know?
good. Like, you just need more practice. It looks like you have the fundamentals.
No, like I'm definitely hyped. Like, don't get me wrong. Like, I'm looking forward to this.
All right. Okay, I'll hit you up again in
Appreciate
3
it so
months.
much.
Like, I got your email. Just email me when
sure.
you're ready for when you think you could get the next ones. Like when
Sounds
you're ready.
good.
All right.
Thank you so much. I
Catch you,
appreciate
man.
it.
Have a good day. See ya.
See ya.
Yo, chat. How do you think he did? He had a job. He had an interview at Apple. It's pretty good. But he got cooked by it. But we're gonna get him right for the next one. That was good. That was good. Do you have a resume sample that would help land an interview? I have some resume examples on my look up for resume ones on my computer. Or sorry, on my YouTube. Try looking up a bit. Okay, I'm gonna take 5-minute break for the next. My boy Alpha Code in the building. We got the next. Alpha Code is next. We're gonna switch to a system design. Let me bring up his channel.
Hello and welcome to another video. So today we're going to be doing something new.
Oh god, this guy's going crazy. Yo, this is the guy we got next. Top 5K. This guy's wild. But we're going to ask him a system design question. Alright, we'll be back in 5 minutes. Everyone stay in. Take a little break. Stretch it out a bit. We're gonna this next one's gonna be a good system design question. Test, test, test. Test. Alright. Alpha, hop in the meets. Hop in the meets. Yo, hop in the Discord. Maybe I'll find Yo, Alpha, what's good?
Hey.
What's up, man? How you doing? Ready?
Yeah, sure. Yeah, I like slept not very much, but it'll be great. It'll be a system design with a headache.
What happened? You go out last night?
Yeah, I just went to sleep at like 3 a.m. So it's, see how it goes.
Yo, chat. How's the audio? Can you hear Alpha well compared to me? Like it's a good even.
All right, let me mute your stream.
All right, everyone, ask Alpha some questions real quick. You got this top 5,000 lead coder in the on the call. Ask him questions.
Okay, sure.
I'm gonna set up a good. Do you know what a CSV file is?
Yeah, I don't really use it very often. It's just like a way to store data, kind of like Excel, I guess.
Oh wait, they're asking you real stuff now. Like what got you involved to program?
I guess my mom was a programmer, so I just like yeah, I didn't really have a lot of passion for it at first. So just like people were just like, yeah, just go get a CS degree, whatever, and I was like, all right, sounds good. But then kind of like after I did stuff, it was more fun. Honestly, the leak code stuff is more fun too. So yeah, the women in tech. Yeah, I don't know. My mom has like a crazy story where she was literally like a PhD music singer in Ukraine, and then when we moved here, she couldn't really do that, so she learned to code at like 40 or something. It was pretty nuts. With like bad English. And then yeah, like all my friends are doing coding and stuff, so
Yo, Alpha, they're asking you more questions.
let's see, am I in school? No, not in school.
I'm gonna eat a quick snack, so yeah, entertain them real quick.
Yeah, I was trying to eat, but then I couldn't finish eating, so I was like, all right, I'll finish it later. Let's see. Yeah, so I'm working right now. I've been working for like 2 years. Funniest programming experience. Yeah, I don't know. Yeah, I'm not sure there. Off the bat, I guess. I don't think I had. I guess like one of the most disaster experiences I had was I had some class where I had to do some stuff. And I was SSHing into like the UCSD like CS whatever. And so I had to use Vim at home, and I didn't know how to use Vim, so I deleted like half my program, like right before I needed to turn it in, and we didn't have like Git or anything at the time. So yeah, basically just deleted like half my program, and I was like, crap. So that was kind of funny.
What text editor do you use? Do you use Vim or?
So I just use VS Code, but when I was in class, we were using so on campus we had like GVim, which was basically just like a notepad. But at home I couldn't use that, so I had to use Vim, and I didn't know how to use Vim, and I didn't do that much at home, so it was like screwed up. But yeah, now I just use VS Code. I used IntelliJ a little bit.
Okay. What's the difference between JavaScript and TypeScript?
Oh, really? Okay, yeah. So TypeScript is static, so it's basically like an add-on to JavaScript. So you can check for types before you actually have a compiler. So pretty much in like production code, coding in just JavaScript is kind of impossible because there's so many errors that you don't see. And then you run your stuff and you get an error and you're like, I have no idea what this is because it's usually some data is like the wrong type or whatever. So TypeScript makes it a lot easier to catch your errors quickly.
Is it a new language?
No, it's just like an add-on, I guess, to JavaScript.
Okay. Why should we not hire you? No, I was kidding.
And that's a good question. I mean, I like going to sleep at 3 a.m., so if you need people to be up bright and early, that's not me, you know. But yeah, well, luckily I work remote, so I can start a little bit later and end a little bit later. Definitely would have to adjust to in office, because I would have to get up at like 7 or something. So yeah.
Okay. What's Node.js?
Yeah, so Node.js is a runtime for JavaScript, so it lets you run your JavaScript code on the back end. Before you could only run it in the browser.
Okay. Explain the cap theorem.
Yeah, so there's basically like 3 parts that you can have in like a real world system: consistency, availability, and partition tolerance. And so consistency just means anytime someone makes a write, how fast can you read that data? Is it right away or do you have to wait? And then availability is like basically what's the uptime of your system.
Mm-hmm.
And then partition tolerance is like how can I split my system into a bunch of different servers. And so for like a real distributed system, you basically always have partition tolerance, so you usually have to pick between availability or consistency.
Why?
Because so if your system's available all the time, it can't. So let's say you have like 20 computers and I write to one, it needs time to replicate to all the other ones. So if you want everything to be available, I guess if you want everything to be consistent, it needs time to replicate to all the other ones, so it's not going to be available. So it's basically like if I have a bunch of different computers, then I can't have them all available and with the freshest data at the same time.
Okay. Can you explain vertically scaling versus horizontal scaling? And
Yeah,
when we
so-
would use one or the other? Actually, wait.
Yes,
I'll
actually-
ask you
yeah,
that
go ahead.
quickly after. Madi in the chat's asking, do you do random leak code problems or do you have a strategy?
So I have like a video on my channel of like how I got good at leak code, so you can watch that, I guess, or like at least to the point where you can do most stuff, and then from there you can do like contests and stuff. But yeah, I just did explore cards, learned all the topics, and did random problems. I think that's a good way to go about it. Like, pick one topic until you're solid at it, and then move on to the next one. I think doing a bunch of problems all over the place is not the best. So.
Okay, how can you focus on leak code problems for 6 hours plus?
I don't do these like 10-hour James things. That's also why I don't do live contests on the weekend. Yeah, you honestly, like if I do a problem and I can't figure out anything in like 10 minutes, I'll start reading the editorial. I used to try to do it and like just not look at stuff and then realize it's kind of pointless. And the only ones that I did that took a while was I was doing some contest key 4s and I didn't know the data structure, so it's like it used a segment tree or something and I didn't know what a segment tree is, so I took all day to learn what a segment tree was, or some other things like that.
Do you think that's the best strategy for someone like for me? What would you give advice for me? Like I'm at 600 questions. Should I just like if I can't solve in 10 minutes, try to do the next?
I would try to solve for 10 minutes. If you get absolutely nowhere, start reading the editorial. Maybe the editorial will tell you like what type of thing you need to use, like dynamic programming or whatever. And then once you read that, ask yourself like, can I figure it out now? And if you can't, just keep reading. So it's like you just essentially just keep giving yourself hints until you get unstuck. And if you have to, then read the whole solution and then try to do the whole solution.
I see.
So I wouldn't like skip it, but I would just keep giving myself hints until you get somewhere.
I see. What do you think
I
about?
can get an editorial. Yeah, I don't know about that one.
What do you think about cheating AI software?
Yeah, so I was just saying, literally as I pulled up your YouTube, I got an ad for some AI cheating thing, which is like kind of crazy on YouTube. I mean, I don't think they advertised it. I think they said as like an interview program helper. I think I had linked that some was like parakeet AI or some kind of bird, which I thought was just like insane for YouTube to allow to let people run commercials for it. Like I thought that'd be banned. But as far as the cheating, I don't know. Like the dude that cheated, that has his that like made the cheater, the Columbia guy, like he was already good at leak code, so he got asked a bunch of stuff and could answer it really quickly because he already knew it. So I mean, you can test it. Just give leak code, like give that cheater to your friend who is interviewing for the internship and see how he does. Like I think it's going to be quite noticeable that he's going to have gaps. So I think if they're already pretty good, then with the cheater it might help them a little bit. But I think it's going to be very hard to make it uh, to make sure like the other person doesn't notice that you're like reading this stuff, you know.
Yeah.
So yeah. And then I would definitely not prefer it because there's a huge obviously downside because you just get like blacklisted and whatever.
I see.
So.
What's your expected salary? What salary would you be happy with your year of experience?
I'd probably rather not share that, I guess.
Okay. They're just wondering, what's your expected salary?
Yeah, I'd probably just rather not share that.
How much money would you make before you retire?
Yeah, so that one I could probably share. So I live in California, and yeah, as you know, it's tough living in California. So the main thing is just like getting a house paid off, and then you don't really need much money. But it's kind of hard getting a house and getting a house paid off with the tax situation. Just because like you can make a lot, but then you're like 50% tax, and houses where I live is like million and a half, or whatever. So it's kind of crazy.
I see. Okay, what else? Okay, let's get back into it. What's the difference between horizontal scaling and vertical scaling? When would you use one or the other?
Yeah, so I actually had this. So I know what it is, but I can actually provide like a real world example. We actually had a database issue last week where our database was like not performing well, so it was actually had huge like CPU usage. So I actually had to go and like basically double the size of the database. So that's vertical. You're essentially just getting like if you have one computer, you just get a bigger computer or a better computer. And you can only do that so long, right? You can't like there's only so good of a computer you can have. And then horizontal scaling is just I have more computers instead of the bigger computer. And you're gonna have the partition issues with the horizontal scaling. So I think a lot of people go for horizontal scaling right away, where vertical would actually be fine. And I like if you only had to go with vertical and that solved your issue, that would probably be better, just because you avoid a lot of the partition issues. And then you can have both consistency and availability if you do that.
Okay. What's the difference between throughput and latency?
Oh man. Okay, so I think throughput is like I guess if you just think of like a pipe and things go through the pipe, throughput is like how many things are going through the pipe at once. And then latency is like, I guess, how long it takes each item to go through the pipe, something like that.
Let's see. Well, let me fix my audio quick. They said there's some echoing.
Okay. Oh, it's on my end?
I don't think so. I think it's from my end because I had it out on my speaker. How does it sound now? Is it good? Wait, let me get this mic set up. Then we'll hop into the coding interview. Okay, Alpha talk real quick. Let's get this working.
Yep, and I have a headset mic. I think I was saying this before. It's not the best quality, so I have a better mic as well if I need to change to it.
I think, yeah. Let's just see what people are saying.
Okay.
How's your day though? Okay, it's better now.
Yeah, I just have like a headache. So after this, I'm gonna like go like run or something.
Nice,
Kinda
nice.
chill.
How's the weather where you're at?
It's hot a lot. I'm in San Diego, so yeah, hot a lot.
Okay, we're gonna get into this interview question now. Thanks for entertaining the crowd. Got about 30 people here to watch you perform. Top 5,000 lead coder.
Yeah, I'm like top millions in system design though, so it's fine. I can bomb it, and I can just say I never did it. So.
Yeah. You're humble, man. Like some people like will be like think they're gonna body it every time. But let's see. Let me get you a coder pad. Hey chat, how's the audio now? I want to make sure the audio is perfect for because it's gonna be its own dedicated video as well. I'm content farming like crazy.
Yeah,
At
yeah,
least like 10 new videos.
yeah. That's all good though. Is rank? Yeah. So I mean, that's the other thing is like I solved a lot of questions. So not necessarily. Gonna start doing contests later in the year. Just haven't done it yet because I have a bunch of other stuff and don't really want to prioritize that.
Mm-hmm. Okay, I see.
But I mean, I've done a lot of hards and stuff, and I've done like problems in this channel like live and whatever. So
Yeah,
just
yeah.
make your own opinion. Not gonna try to defend my rank.
Oh, what's people saying? Someone's defending your or attacking your rank?
Oh, is rank determined by the number of questions solved? I mean, yeah, I just looked at a lot of other people's streams, I guess, and they had a rank, and I can kind of see like how they were doing compared to me, and then yeah.
I'm slightly okay. Aaron, how's it now? Okay, we're gonna get him on here. How's the audio now compared to Alpha? Alpha, I'm gonna send you an invite on our
Right.
Meets link.
Yeah, I guess I can defend my rank by saying that I've never failed a like a coding assessment. So yeah, take with that what you will, I guess.
Okay, you could access the quarter and also when you join the quarter pad, like don't put in your initials or something.
Oh, I see. Okay, where did you send it?
In the
Here.
Meets.
I see. Can you yeah, just don't share it, I guess, until I
Yeah.
oh yeah, I see. So just put in like okay, I'll just do this. Should be fine, right? Okay, yeah,
All right.
it's fine.
So you get access to our drawing board there. We'll full screen
Okay,
it.
cool. Okay, and this looks like it uses Excalidraw like
The classic,
inside or
classic,
something.
yeah.
So okay, looks like I can make a new. Okay, cool.
Okay, I'll be following you.
All right.
Okay, give me a sec. I just need to quickly brush my teeth. Like 30 seconds. Yo, chat, ask him some questions real quick.
Why system design? I guess just because I want to learn system design. I know Liquid pretty well, and system design there's a lot less like prep material, so I think doing mocks with people who are better than you is going to be pretty good. Get some feedback. Why do you have 1500 solved? You better. I mean, I just made a YouTube channel doing LeetCode questions, and I actually like solving LeetCode, so yeah. I don't know. And then I was doing some like of the mock assessments and whatever other stuff. Certain type. Where do I work? You can see that on my channel, I guess, if you want to. I mean, I don't necessarily think there's like a type, more just like the difficulty, right? So some Q4s are like really hard. Um, Median if two sorted, that one's kind of a pain. Yeah, you can just Google like this, I guess. I don't think I can put in links. But you can just Google that and then find it. Yeah, I don't know. Median if two sorted array is kind of a pain. So I could do it, but I wouldn't want to get asked, honestly. Did LeetCode help me with projects? Not really. Why don't I do contests? Because I was learning problems, so I didn't want to get like a bad rank, I guess. So I could do the problems and like not worry about my rank. But now I can like do problems, I guess, and whatever, have a good rank. Can never solve. Yeah, that one's just kind of a pain. And also just doing like committing to like 2 hours or whatever it is on like a Saturday is not the best. I haven't done Code Forces. I started it and then I was just like, I'm not trying to be a competitive programmer and I already have a job, so not really trying to go down that road. Was more just trying to learn algorithms I thought were interesting and stuff. DS helped. Um, I mean a little bit, yeah. Like it helps you find edge cases, and then you'd be surprised how many things are like really obvious from doing leak code that you can like know time complexity and then people don't in real life. So I don't want to mention like the exact stuff, but what did they ask about job? Let's see. I mean, for my job, they asked me, I guess for my job interview, they asked me like some leak code medium and then some practical stuff. I did hear this a lot, the really good at leak code but bad software engineer. I do get that feedback from a lot of people because like in real world software stuff, it's kind of high scale. And the person that's like really good at leak code is like in real world, you never have like test cases for you, and you have to think like big picture, and you have to write like reusable, maintainable code, not code that like no one can read. So yeah, there is that. Yeah, exactly. I'm at the point of like diminishing returns, so I'm kind of slowing down on that, doing other stuff. Yeah, pretty much. Like I could get better, but it's just kind of like not the best use of my time. And not trying to be a competitive programmer. I'm not like in high school or college or something. So it's just kind of, yeah.
All right.
More
I'm
trying
back.
to learn job stuff, real world stuff.
Do you hear me?
Yeah.
Awesome. Okay. I'm gonna start a video, and we're gonna get right into it.
Okay.
So I'm gonna start recording. Hey everyone. Today I got my friend Alpha back in. We're actually live right now, so he's about to do a system design interview straight on a live stream. We're gonna get feedback from everyone in here. We're gonna focus more on a product specific system design. And yeah, Alpha has his own YouTube channel as well. Go subscribe to Alpha. He's top 5,000 on lead code, so he's very knowledgeable about lead code. Almost solved 1,500 questions, has a crazy 500-day streak. So yeah, he done a lot of algorithms, but wants to do like improve his system design skills. So he's been practicing a lot on that. So let's just get straight into this. Alpha, I want you to design Google Calendar.
Okay. Definitely haven't done this one before, so definitely don't know any of the
Curveball.
features.
Oh, you don't know the features of it?
I don't use it that often, to be honest. Like,
Okay, we're just gonna design a calendar, right? Let's talk
Okay.
about walk me through how it's gonna go.
Sure. So we'll just write some stuff that I think is important. Alright, so let's say, I guess, a user should be able to view their calendar, right, with some events. Their calendar with some events.
Mm-hmm.
Okay. Then user should be able to add events to the calendar, I guess.
Mm-hmm.
Add events, or like add, delete, or something. Delete, modify events in the calendar.
Sure.
Yeah, so these are the main ones I see. There's other stuff that I see, so I kind of know how important it is. Like, if you make an event, you should be able to, and yeah, invite, like, make an event with other people.
Let's not worry about like cross people right now.
So just for yourself, okay.
For
so,
yourself,
okay,
but
so
multiple
view-
devices.
Okay, yeah, cool. Yeah, I guess maybe some. Okay, let me mute or minimize the chat. Don't want to get any hints. All right,
Yeah.
so yeah, I guess like another one would be. I mean, I don't know how important reminders. I feel like these are the main two, and then if you have any others, can you like point it out? I guess if you have anything you want to prioritize.
Take a look at Google Calendar and just start listing out, or any calendar app, and try to start listing out functional requirements. I want you to lead the conversation here.
Okay, yeah, sure.
And that's like very valid to do. Be like, oh, can I quickly look at valid calendar or calendar and see what the functionality is? And I also want to get a sense of like your product thinking. Like we're a small startup, right? We don't want to build out all the functionality of Google Calendar in one go. This is kind of our MVP.
Yeah. Okay.
So you tell me what we should and shouldn't do.
So it looks like user should be able to click on particular day and get events for that day, right? So this is just going to be like from 12 to like the whole day or whatever it is.
Hmm.
So that looks like another one. And then I guess another one I'm seeing is you can have multiple calendars.
But like we're a small startup, right? This is our MVP. Do you think we
Hmm.
should like should that be
Okay, yeah.
below
If
the line?
this is your MVP, then I would get rid of this guy.
Okay. You could create like a
Um,
below the line portion, just like yeah, because
yeah.
it's still nice to see that you're able to think of it, but I
Yeah. So
want
below
to
the
see
line
if you
would
can
be
prioritize.
multiple calendars,
Hmm.
and then obviously some kind of multiple user interaction.
Okay.
Something like that. Okay. Yeah, I think that's mostly what I'm seeing here. Is like yeah, you can like search for people and see their calendars, but that's also going to be multiple users. So I'll just link all that, like adding people to yours, seeing
I
theirs,
see.
blah blah blah.
Okay. So users should be able to view their calendars with some events. What are the different views? I mean, daily, weekly, monthly.
Okay, so let me refresh my calendar here. Okay, so I'm gonna say the way this works is kind of like, so 1 and 3 are kind of related, where you get a calendar, you click on a day, and then for that day you see the events. Maybe we can also have like a weekly view, I guess. So maybe we
Okay.
can have a weekly view and then like a yeah, and then so I guess we can add that in. So weekly versus daily in some client thing that we're gonna abstract.
Okay. Okay. Yeah. Okay.
Monthly is probably too much. Like I feel like yeah, I mean maybe you can have monthly, but I'll just say daily and weekly is probably the two big ones.
Okay. Yeah. Let's focus on daily and weekly.
Okay.
Yeah. Able edit, delete, modify events. Um, is there any other requirements you think that will be useful for MVP?
Uh, yeah, so I guess another one that I'm thinking is, so this event, like these events will have kind of like most other systems, like if we have daily and weekly, we'll have like a short summary, but user should be able to select an event and see details about it.
Okay.
And then from here, like modify, delete, etc. Stuff like
Okay.
that. So I think that's another one I'm seeing that's kind of big.
Hmm. Okay. All right. Two things I would add here would pretty much just be just reminders because that's very important. Like we don't want people missing their. Um, they want to get. We want to notify them when their event is coming up. I think
Okay,
that's
and
a
then to
core feature.
clarify this, like reminder emails or something like that,
Yeah.
or how would
Or push notifications as well.
Okay.
And
All right.
then lastly, recurring events. That's kind of a core feature as well.
Oh yeah, you're right. Sorry.
No problem. All right. Let's
Okay.
talk about the yeah. Take me to the non-functional requirements now.
Okay. Okay. So I guess trying to think of like consistency versus availability for this one. I'm thinking like yeah, I think we want to. This one's kind of close because you're viewing your own stuff. You want to see that like feedback relatively quickly. But I think we can kind of do this client side and then it'll be good. So we can say like we can prioritize availability and then we can have like optimistic client side, something like this, updates. And kind of what this will be is just like a high level. So whenever we make a change, we see it reflected on the client, but then we'll make some call. And then if that call fails, then we'll like update our client to go back to what it was. And assuming we have like, 90 plus like success in our API calls, then this will be pretty good. So the client will see the update quickly, but then realistically, it'll take some time to propagate on the server.
Mhm.
Does that make sense?
Yeah. We're gonna have we want to support multiple devices, right?
Yeah, so we want to support like I guess web plus phone, and then whatever tablet or some other stuff. Yeah, not super familiar with like anything other than web, so I'll kind of figure this out. Okay, and then let's see what else we want here. So we obviously want to be able to handle like a large amount of users, I guess. Users and yeah, just like high traffic. and then you can give me numbers here if you want. I don't think for a calendar we have things like surges. Like I'm just gonna assume kind of uniform distribution of requests, especially if we're gonna do this in multiple countries. So I'm gonna say we're not gonna have like surges for this kind of thing. Does that make sense?
Okay.
Okay.
So we
And I
have
think
availability here, right? So what if I'm
Yeah.
like looking at it on my phone versus looking at it on my computer and I'm seeing two different things for consistency? Like it's not
So
consistent.
so I think we want to have it as consistent as possible. So I'll say like we can have availability with like a couple seconds difference in consistency. Something like that ideally is what we'll go for. So it won't be like instant, but it will be pretty close.
I see.
Because and yeah, I guess maybe if you literally like pull your phone up to your browser and then like change something, you won't see it instantly, but it'll be pretty close. So that, and I don't think that's like a real like product use case of you have them up together and you're just like double checking for exact sync type thing.
Yeah, I agree.
So,
I agree.
yeah.
I agree. Okay. What else?
Let's see. Where's phone tablet? Yeah, I'm not sure if I'm seeing anything else. Maybe I missed something. Yeah, okay, I guess can I get like, yeah, is there anything else you're looking for? I think this is like the most, yeah, kind of like most of the stuff.
Yeah, so handle large
I
amount of
don't think
users
you-
and traffic. Yep. I think that's good. Yeah, I mean the reminders should definitely go like the reminders should definitely go out kind of thing. But let's just
Well, we have the
technic-
reminders up here, yeah,
Yeah.
so.
Okay. Maybe like exactly once reminders or like at least once reminders.
Oh, I
would
see.
be a
Yeah, so we can
non-functional.
mention that. So we can say like reminders are crucial, don't miss them, and make sure we don't get spammed or something. So only one email or something, or whatever. I guess that could be a product thing, right? So we can say like maybe remind them like an hour before and the day before or something, so whatever. Make sure we follow product reminder schedule or something it is. Because yeah, I guess this is also a real thing I worked on is we do a lot of like reminder email type things, and if you send multiple, then people complain. So yeah, you don't want to have like duplicate emails and things like that. You want to make sure it works correctly.
Yeah. Okay. Cool.
Okay.
What's next?
I feel like that's it. Maybe there's some more stuff, but kind of want to go on to other stuff, unless you think I'm missing something, just because I want to try to get a design working.
Yeah. Let's get it.
Alright, so let's toss this out for now, just so I can make this smaller and see everything. Yeah, I'm also noticing in this, like I don't know, the text seems just like, oh, it's maybe because
Kind of ugly, huh?
No, it's okay. I think it's just like zoomed in a lot, so it's kind of hard to fit it all. So okay, I think I'm good here.
You could
I
zoom
just, like,
out though.
Huh?
You could zoom out, like zoom.
Yeah,
in
that's
and
what I
out.
did. I just zoomed out. I don't know if you see the same. Yeah, I just made it like 50%, and then it's better.
Yeah, I can I'm updating myself, or like I can move around myself.
Okay, cool. All right, so I guess the next thing is we can worry about the like the core entities here. And so what we're gonna have here is, I guess we'll have the user, and then so we probably want to have like an event, and then I guess how do we want to store the calendar for the user? I guess maybe we'll store, just to keep it simple, I guess we can have like a, yeah, I guess calendar day or something, I don't know. And so the calendar day will have the yeah, we'll talk about exactly what's in there, but I think these three can help us tie everything we need. So user, event, and then a calendar day, and then this will all be linked together. Does that sound pretty good?
Sure.
Okay. So then we can go to the API.
Could you explain what the calendar day is gonna do?
Yeah, so the calendar day will have like an actual day, and then it'll also be tied to a user, and then events will have a user and a calendar day, so we can kind of like put it all together. maybe there's a better way to store this
Okay.
information, but just going for this for now.
Sure.
Does that make sense?
Yeah, let's continue.
Okay. So yeah, I guess for the API, we're just gonna go through the function requirements and check those. So the first thing looks like we want to be able to view a calendar with some events, weekly versus daily. Okay, so what we want to do is we want to go like get calendar, and then we want to be able to for this calendar we want to put in weekly versus daily. So we'll say like in here like time frame. This will be like weekly versus daily, and then we'll have, yeah, so the user information is going to be somewhere else, so we don't need to provide that here. And then, oh yeah, then we also need to, so I guess this will be like so actually the time frame will actually be, I guess we can provide that in the time frame. Instead of weekly versus daily, we can just provide some time frame. So we can just say like start day or whatever, end day, something like that.
Sure.
Okay, so we provide a time frame to the get, and then we're going to get what we're going to get back here is an event, or like a partial event list. So we don't need full information just looking at like Google Calendar. We basically just need like a title or something small. And then once we click on them, then we can get more information. So we're going to get this back. Then we're going to go, we want to get an actual events. So we're going to say events with an ID. And then this will, so once we click on an event, we're going to click on an event, and then we're going to see the full event information. So it's like full event info here. Okay. And then we want to be able to, add, delete, modify events here. So we're going to have these three. So we're going to have a post, events, and it'll take a body of like date, some event data. Not going to talk about that in detail. Whatever we decide our event schema is going to look like. So date, event data, we're going to already have the user because they're going to be sending the request. I think that's all we need there. And then we're going to have patch events. And then the post won't return anything, so this will just return like a 200 or something if it worked. Patch events.
Also, you have a Sigma voice. I don't know what that means, but
Sigma voice? No, I know my mic is like pretty bad. I'll try to use the other one later. Yeah, I don't know what a Sigma voice is, but like watching the videos from before, like my headset mic's pretty bad. So okay, so so this patch events ID will return an full event info. So typically when you do a patch, you get like the full update, and then the body here will be whatever the patch was. So the same kind of thing. The date we're probably never going to change, but we're going to change some event data, and then we'll also have a delete. The same thing, events ID. It'll return the full event, and then we don't need a body for this one. We just provide an ID and it's just deleted. Okay, so that takes care of 1 and 2. Also 3 is taken care of. Click on a day, so we're just going to get the event. Should be able to select an event, get more details about it, modify, delete. I think we took care of that as well. Reminders and reoccurring events. Okay, so yeah, I guess that's another thing I need to add is for all of these, we're going to have an event data, and then we're also going to have like a reoccurring, and this can be like an optional thing. So if it's reoccurring, you want to put it everywhere, and if it's not, then you don't. And actually, this is probably worth thinking about how this, I guess how this, like if we have a reoccurring event, we need it forever. So we need to make sure that like we can present it well, and we can also modify it well, and it'll show on every calendar day. So if we have an event that's on a calendar day, if it's reoccurring, I guess that's going to be maybe troublesome. So I guess maybe we'll fix that a little bit later once we get an overall design. I think right now I'll just say, actually, let's see.
Okay, where are we using this calendar day?
Yeah, so we're using the calendar day Actually, we might not even be. Yeah, we might not even need it. Yeah, I'm thinking we don't even need it. So user can just have an event, and then that event can just be. Yes, I think we can actually get rid of this guy.
Okay.
So the event can just have like the date on the event, and then we can just have these two. But
Okay.
the main concern I have is like if we do have an event that is reoccurring, like what should the user experience be there? Like what if I click like 50 years in advance? Should it show that event right away or like that kind of thing?
It should.
It should. Okay. So we need to somehow figure out like for that day or for that whatever, what events are going on.
Mhm.
Okay, I guess we'll just have some really simple for now. All we're gonna do is to get this partial event list, we're just gonna go like the brute force, take every event for the user, and then check does that occur on that day. So we can have like the initial day, and then we can see if it's reoccurring or not, and then we can just do a calculation of like does it occur on the day. So right now we're just gonna brute force, get every event for the user, and then we're gonna try to make it better if we have time. Does that make sense?
Get every event from the user.
Yeah. So
And
like
see if any are recurring.
so when we do this, when we get a time frame, right now all we're gonna do is we're just gonna get every single event that the user has, and then check if they're in this time frame.
Okay.
So we're just gonna do some brute force, like take everything,
I
and
see.
then we can probably think of a way to make this better as
Yeah.
like a deep dive or something.
Yeah, actually, okay. Let's actually reserve recurring events and also reminders for the deep dive. Let's just get into the other portions quick. Can you
Okay,
just
yeah.
quickly walk me through the APIs again?
Yeah. So the first one is just gonna be we're gonna get actually I don't think this is even gonna be calendar. I think we can even call, because we don't have the calendar, we can just call events.
Sure.
Yeah, so we're gonna get all of the events. We're gonna give a time frame that we want to get the events for, and we're gonna get a partial event list. So it's just gonna be like, yeah, list of like event names and then when they occur, so we could actually show our calendar, our daily or weekly calendar. Does that make sense?
Okay. How are we gonna make sure anything like we have to consider here when getting the calendar or the events? Like
Anything we have to
security.
consider. Oh yeah. So yeah, so as long as we have the user ID and like a JWT, as long as it's not like, which we don't have it here, I don't think we have to worry about. I think that's the main security concern is we don't want to have user info in the request, because then someone can just like find the user info and just make get requests on their behalf. I guess
Mhm.
that would be like the main one I see.
Yeah. So how do we stop? How do we make sure we get our calendar and only our calendar and no one else's calendar?
Yeah, so we can just have like when we make the get request, we can just have a JWT for the user, and then on the server we're gonna decrypt that JWT and get the user ID out of there, and then we're only gonna get the calendar for that user.
So the JWT is going to be sent to the front end and is going to have the user ID.
Oh yeah, like a JWT I think is like a hashed. It can be whatever you want it to have, just hashed.
And
So
then,
even if someone gets it, they can't use it.
and then when they send it over, so they're going to send the JWT back to the backend.
Yeah,
At
they're
least-
gonna send. Yeah, so I think the way it works is you get a JWT, you store it on the front end, and then with all your requests you send the JWT, and then the backend decrypts the JWT and gets like the user info out of that.
Okay, I see. Yeah, because the JWT is plain text. I mean, it hashes it, but you can easily look into it. It's not like encrypted. The JWT.
Yeah.
So if we have like information there, they might be able to steal it. But yeah, we could probably deep dive it in a different one too. So
Yeah.
I think you have understanding of like, okay, we need to be passing in some sort of session or JWT, so we only get
Mhm.
our stuff.
Yeah.
Could you walk me through the rest?
Yeah, so this one's pretty straightforward. We're going to take an event. So once we have these events on the front end, we're going to click on it, and then we're going to call get events ID. So this will take an event ID, and it will get the full event info for the ID. So like Google Calendar, you see your calendar, you click on an event, and then you're going to get like a modal or whatever it is with all that event info, and then you can modify from there. You can like delete and whatever. So it'll just give you more information. I think this is like pretty standard for most of these, right? You want to give partial info in a list or something, and then when they click on it, you can provide more.
Yeah, it makes sense. Okay, posting.
Yeah, so post, we just basically make it a new event. We don't really need to return it. We can just return 200, or we could return the event. I think this is like whatever. Either one should be fine. We're gonna have the date. We're gonna have the event data, whatever is in that event, and then we're gonna have a reoccurring variable. Right now, I won't really talk about the reoccurring too much.
Yeah.
We'll just say, maybe we'll even say like we have no reoccurring events for now, because those are really easy because they'll have an exact date. The reoccurring, there's a little bit more or less work, or more work that we can do a deep dive on how to make it work better.
Okay, let's get into the high level design because I want to spend at least 20 minutes on a deep dive.
Okay.
There you go.
Okay, so high level design. Yeah, so we're just gonna go through all of this. So let's say, okay, I think I need to zoom out some more. So can I get? No, I can't. Okay. Yeah, the annoying thing is like once you start typing, that little window on the left comes up. Okay, I'm trying to move it over here.
What window?
All right, this is better.
Oh, I see.
Okay, so we'll have our client, and this can be whatever web app. I'm not gonna talk about the client too much unless we need to. So if we need to start something on the client, I'll add more stuff. So let's just make sure we can get all these things. So client API gateway. Okay, and so the API gateway is going to do things like rate limiting and then sending things to the right service. Yeah, I guess maybe some other stuff, but this can just be out of the box, or you can, yeah, especially for like a startup, we can just use like an out of the box API gateway.
Mm-hmm.
I know for my company we have our own, but yeah, I guess you can use an out of the box as well.
I see.
Okay, so, and yeah, I'm just gonna draw these, or I'll just draw these arrows to indicate that information goes both ways. And then we're gonna have, so I guess what service do we need? I guess for now we'll just keep it simple. We'll just have only one service. So maybe we won't even need the API gateway, but we'll just do this. So this is going to be our like calendar service, and then we'll see if we need to add anything else. I guess we probably will, because for reminders we might need like a notification service. So okay,
I see.
so we'll have a calendar service. I guess maybe we can even write that now, a notifications service.
Okay.
Okay, so this will be connected like this. So let's just talk about, I guess, the flow of each of these.
Yeah.
So first, to get all the events. So we're going to send a request. It's going to go to our calendar service. Going to check our DB here. Say our DB is this. And then we'll just use like Postgres or something for now. I don't think there's a big, like I don't see a big one way or the other, but you can kind of use whatever DB you're good with.
Yep.
I think nowadays most DBs can do most things, so unless it's something very specific, it doesn't really matter.
Sounds good.
So yeah, so we're gonna get all these events. So now we can talk about a little bit higher level or a little bit lower level, like what are actually in these entities, these user and events. So in the user, we're gonna have a user ID. We're gonna have like a name, like last name, whatever. And then do we need anything else? I don't see anything right now, but we can add on to this if we see something. Okay, and then for the event, we're gonna have a user ID. Like I said, not gonna focus on recurring for now, so we'll just have a date of the event. We'll have metadata of the event, or whatever like data is in like event info, we'll call it. And you can have a bunch of stuff. This is just gonna be like, yeah, I'm not going to talk about that in detail because you can describe like what you want in an event later. But we'll just say we'll have some info, and then we'll have some metadata, like created at, updated at, whatever, all that stuff. So I think this is mostly what we need.
Date, event info.
Does that make sense?
Yeah. What could we just elaborate a bit more on the of these event infos? I think for this question is kind of important.
Sure. So looking at the Google Calendar. Let's say when you make an event, you just have like a paragraph of text for the event to describe it, to keep it like really simple. So you make an event, you just write a paragraph of text describing what the event is. Does that seem reasonable?
Yeah. I'm more
So
thinking
essentially
about also like
okay.
when we put something in a date, right? Usually there's also a time, like 5 to 6. That's very important. How are you capturing that?
Yeah, so this will be like I think we want both, so we want date time.
Okay.
We don't actually want a date, we want a date and a time, yeah. Because for our daily events, we need to know the time as well. We could split this up as well, we could do this too.
That will give us a start date or start time only?
Oh yeah, I see. Yeah, I actually missed that one. So yeah, so we actually need both. So we need a start date and date. And probably start time and time actually. something like this. Yeah, because actually this event, like this, maybe this event takes a year or something. I don't know.
I
Okay,
see.
so that
Okay.
makes sense.
Let's just say they can't go multi-day kind of thing for now. Just give it a easy. It's just a
Oh,
single
okay.
day between.
Yeah, single day. Okay, so we'll go date and then like this. Yeah, that makes sense. So that way when we show their daily view, if that event takes multiple hours, we can move it through.
Yep.
Okay, does that seem good?
Yep.
And then we're gonna avoid the edge cases of like starting, like 11:59 and then going to the next day, things like that. We'll just avoid that kind of stuff for now.
Mm-hmm.
Okay. So yeah, so essentially when they're gonna get their events here, they're gonna call our calendar service in our DB, and we basically need to take every event that I guess. So they're gonna provide us, I guess when they want to get all their events, they're gonna provide us either a day or multiple days. We're not gonna allow them to do like a specific time frame, because looking at like the Google Calendar, for example, you can either pick like a week or like a day. So you can't just say like I want all events from like 2 p.m. to something. So this is just going to be based on days, and then if it's based on days, we can just check the date of the event, and if the date is in that range, then we're going to get those events back to the user. Does that make sense?
Mm-hmm.
Okay, so that's how we're going to do this first one. Then for the second one, it's going to be pretty straightforward. If we have an event ID, we have a user ID, and then I guess I missed that one. So we have the event ID, which will just be the primary key of the event, and then we can just get that back. So that one's like the easiest. Post events is also going to be pretty easy. Call our calendar service, make a new event. Yeah, and then I guess also looking back here. So we want to have that start time, end time.
Okay. Let's hop into deep dives because we want to keep it under 15 minutes. So I want to spend 7.5 minutes on recurring events and another 7.5 minutes on reminder emails.
Okay.
Let's start with that. Yeah, the first one. Like, how are we gonna do recurring?
Yeah. So for recurring events, kind of tricky because their date keeps going on, and so like you said, so I can put in any date in the future, any amount in the future, right? Like 1,000,000 years in the future, and it should have that event.
Yeah.
Okay.
Technically. Yeah.
So then, I think the better way to do that is maybe store recurring events. Yeah, I think this is the way to go. Store recurring events separately, or maybe give a recurring, like give. So actually what we want to do is we want to have like a recurring or not, right? And then what we want to do is we can make another call for recurring events. So for the daily events and all that stuff, we can pull that up with getting the time. But the recurring events, we can probably pull up separately, or maybe we can cache in some way. But what it's going to look like is we're going to pull up all the recurring events for the user. And there actually can't be that many, like realistically, because in order to recur, like I guess let's talk about this. So when you say recurring, it's going to be like weekly or monthly or yearly or something like that, right?
Yeah, and the day, like weekly every Tuesday.
Right. So there's not going to actually be that many. So let's just say there might be like 200 or 300 at the most.
Mm-hmm.
And then, so we get all those, and then we just check like for that range that they put in, when do those events occur? So yeah, instead, like my strategy before I think was really bad was if you make a recurring event and you like I was trying to propagate it forward, right? So if an event recurs, I was just going to keep making more and more and more of them. And that seems really bad if you can just go 1,000,000 years in advance, and it also seems really slow for the delete. So yeah, so I think what we're going to do for the recurring events is we're going to get those in a separate query, and then we're just going to check, okay, for all these recurring events, we're not going to have a year on those events because they should be, basically recurring, like, just to keep it simple, maybe we'll only limit it to like a specific date, time in a month. Instead of supporting like every week, every other, like all that, we'll just say like we can only have X date, time, in a month. Does that make sense? And with this, we can basically just check like, okay, is their query there provided? Does our recurring event happen at that date time? So we're not going to have the year. We're just going to have the date and then the time, and then we're kind of separately get those recurring events. And because there can't be that many, it won't be that bad.
Okay.
So I feel like that's the way to go.
So-
and then we can also delete them faster.
I see. That makes sense. So the front end gets all events, and it also grabs recurring events. Some recurring events might not be applicable to a certain time range, but we'll just filter those out, and then be able to.
Yeah.
show-
So the back end will actually filter out only the relevant ones because you want to send the minimal information you can to the front end, right?
Yeah.
So the back end will filter out the irrelevant ones, and it will basically, exactly, send only relevant recurring events, and then the front end can just put those on the there.
Okay. So walk me through the process of like I click 4 years ahead, and I want to see the recurring events on like the week of
Cool.
March 9.
Yeah. So if I click 4 years ahead, I'm gonna call this get thing right at start day and end day, and then the year, and so on.
Mhm.
Because for actual events, the year does matter, right? So start day, end day, the year.
Mhm.
And then I'm gonna get all the actual events in just a normal join. Like we're gonna get all the events that happen to be in that range.
Mhm.
And I think we can like index on the date and stuff. We can index on user ID. We can index on the date to make this like reasonably fast.
Mhm.
And then we're gonna get the recurring events separately. So the recurring events won't have a year. So let's say like if I want to do like March 9th through 15th.
Mhm.
In fact, we can even store this in a separate event. Maybe that'll be cleaner. Maybe we can even have this separate like recurring events here table.
Mhm.
And then this will be kind of similar. So we get rid of this. And then something. So it'd be kind of similar. I don't know what's better, one or the other, but let's just say we do it this way. So the date won't have a year. It will only have the day and the month. So we just check like, okay, let's get all the recurring events that are in this range. So we actually don't care about we don't care about the month either. So we're only supporting date, time, in a month. So for the recurring event, we'll just check like, okay, what are all these recurring events that occur on I guess you also mentioned for the date we can only it doesn't have to span across multiple days.
Yeah.
So the date will literally just say here instead of March 9th, it'll just say like 9. And that means that it occurs every month on the 9th.
Sure.
And then so we can take that range and then we can see like, okay, what are all the recurring events that are in this range, and then we can pass it back. I'm sure that you could do some better database optimizations, but I think this is probably something like the way to go.
Okay.
And you can probably optimize this further.
Yeah.
But yeah.
I like it. Yeah. Let's go to notifications.
All right. So, I guess for notifications, do we want to have multiple notifications? So in terms of like, let's say our event happens in a day or an hour, like when do we want to notify?
We want to notify everyone 5 minutes before their event starts, and if they edit it or move it, we don't want to notify them that. Like we don't want false alarms, false positives, or false notifications.
Okay.
That makes sense.
Yeah. Cool. So, you mean like, so can you elaborate further on if they edit it?
So for example, I had I had a interview from 5 to 10, where ours was from 2 to 3. Pretend I can't make it, so I move it to the next day, 2 to 3. Pretend we don't send out that notification to them today.
Gotcha.
We instead send it tomorrow. That's like just make sure that edge case, we capture that edge case.
Okay. Yeah. Okay. So I think what we can do is we can assume that, I guess one thing I'm thinking really quickly is we can assume all our start times are going to be like, let's say we only allow them to start every we can make this a product requirement or something. Let's let them start every 10-minute intervals or something like that. Does that seem reasonable?
For
So they can start at like 10 or 20 or 30, but they can't start at like 21:58 or whatever.
Yeah, let's just say they can start every 30 minutes.
Okay, every 30 minutes, perfect. So what we can do is we can have our notifications can query the DB. If they can start every 30 minutes, we'll just query the DB at like 25 minutes. So 25 minutes and then at 55 minutes. And we can just literally say like, okay, well, what are all the events that start in 5 minutes? And then for all of those, we can send out an email. And I think that's going to be like the
Okay.
easiest.
So we're gonna have a cron job.
Oh yeah, so we can. So this can be basically like an async job that just queries the event table, uh, checks for all the events that are going to start in 5 minutes, and then sends out an email to all of those. So for the event, you're going to be able to get the user ID. User ID will have like an email, and then we're going to be able to email them like, hey, you have this event. We can send them the event info in 5 minutes. Make sure you don't miss it. I think that's the easiest.
Mm-hmm. Okay, so we have this cron job that's gonna run like 5 minutes before notifications need to go out.
I mean, we can figure out how long this takes. Like, do we need it to be sent out exactly 5 minutes before, or
Yeah,
like
we
roughly?
need to send it 5 minutes before.
Okay. So in that case, what we want to have is maybe we can have a. Hmm, yeah, I'm trying to think of like how long it takes to get all of these events, and then.
Yeah. Cause okay, could you explain the cron job quick? Like you're gonna have like one cron job that's looking in the database and figuring out who to send to, and it's gonna send these out serially. Like what it's gonna query the database, right? It's gonna get a list of all
Mhm.
the events, and it's gonna go one by one sending them out. What if the list is really long?
Right. Hmm.
Like it might be late, right? I have 100, and maybe it's slow and.
Yeah. Like if I do this, and then there's a lot, and then it's yeah. So ideally, we want to have it maybe. A better solution would be to have it ahead of time in some way, right? So to have some kind of like these are the emails I need to send. Now there is the drawback with that of if I modify, then I need to like update that guy.
Mm-hmm.
Um, so maybe instead of that, maybe we can have like a cache or something. Not really sure how like the best way to do this one actually. I mean, the alternative to doing it at this time, we can just query at like 20, 30 minutes like this or something, and then that way we'd have it. We'd already have all this when we need
Okay.
it, and then we can just send. So this might be another way to go about it simply. There's probably some other better way to do this, but this is like the fast way, I guess. Does
Mm-hmm.
that make sense?
Okay, so how would we scale it if there's a lot of? Are we gonna like make that cron job like give more throw more CPU at that one cron job?
Yeah. So we can definitely also, um, we could throw more CPU at that one cron job, or we can also just have more cron jobs, I guess, of
Mm-hmm.
like we can basically like do like a hashing to cron job or something like, where essentially we'll say like, this cron job will take some hash of the event IDs, and then this other cron job will take some other hash of the event IDs, so that way like each cron job is responsible for like a smaller piece.
I see.
Um,
Okay.
so that would be another way. I do feel like there's probably something better here, but I'm not seeing it.
Mm-hmm. Okay, so you're thinking about horizontally scaling it, and then they coordinate with each other by basically like, okay, I'll handle these specific events, and you handle those, and that way they
Exactly,
don't send it.
exactly.
Yeah.
Yeah.
Okay.
Yeah, you can basically scale this notification service to just hash on event IDs, and then we can just infinitely horizontally scale that.
I see.
Yeah.
I see. Okay. Yeah, I think the cron job would work. Like, but they would look every what like how often would they look, and just like the same thing I mentioned, it's like what if it has way too much events to send itself? Like, how are we going to scale up or scale? How do we know when to scale up or scale down?
How do we know when to scale up or scale down?
Because at some point, right, there's going to be way too much events that if it reads it in, it might be late to sending events if it has to send the events one at a time.
Well, we can scale up and scale down just by making more of these, right? So like if we have more events, we can just make more instances of this. So it'll keep reading less. Like if we just hash the event ID with like consistent hashing, we can just keep adding more and more notification servers, and then each one will be responsible for reading less and less events.
Mm-hmm.
So even though
Okay.
we have more events, we also have more servers and then more jobs, and then they're essentially getting less and less and less
I see.
each.
Okay. Yeah, I think we're at 43 minutes. So, yeah.
Okay.
How do you think you did?
Yeah, so this one, so the leak code one I have seen before. This one I've never seen before, and I don't know the product requirements. So it's definitely a tricky one, and I'm kind of glad you didn't ask me some like YouTube streaming or something ridiculous that I would have literally never like. I do feel like most of these problems are kind of similar to LeetCode, where there's like 5 or 10 patterns you need to memorize, and then everything can be kind of like brought into those. Yeah, because maybe this one isn't one I've seen before. Also, I haven't used notifications before really, and I don't do that at work. I'm not super familiar with it. Like I said, the way we have notifications is we do have emails, but we also don't have like the scale of Google Calendar or whatever, so it's not a big problem.
Yeah.
So
I see.
yeah, I think I feel like I did okay. Like
Yeah.
definitely not too bad.
Yeah.
Definitely could have like deep dove more, but I do feel like my solutions were at least like adequate for like mid-level, I want to say. Maybe not
Yeah.
for like higher.
Okay,
So-
yeah. Definitely, yeah, I would say for mid-level, yeah, that would pass, but I think for the senior level, like being able to understand the notifications would or be able to like scale the notifications would be like required. Especially notifications are pretty much in every single system. So as a senior, I think that would definitely go on. So I think okay, what I would say is yeah, for him his solution was a cron job. Um, yeah, I think you obviously have a really good flow, like walking through the functional requirements, non-functional requirements, um, core entities and stuff. I would say with the functional requirements, if you haven't seen it before, just like yeah, practicing how you do requirements gathering, especially at the senior level, we want to make sure that you're able to gather requirements. Um, so yeah, but I think overall you were able to grab it. You missed a few functional requirements, that's why. But for the intermediate, that would pass. Like being it, like I think one thing you missed was like the different views at first, and then
Right.
able to. I think reminders is a core part
Yeah,
of it. But I
reminders
guess,
and reoccurring, I guess, are like pretty crucial. So makes sense.
yeah, core entities and APIs. You're obviously really good at that because I mean, pretty product focused. I think one thing that you could look into a bit is the sessions, how the sessions work and stuff. 'Cause I feel like every time I pulled into it a little bit just to see.
Yeah, no, yeah, for sure, yeah.
Okay, let's get into the recurring events. Really good job on the recurring events though. Like this is this is the solution I would do too. Some
Have a
candidates would
separate
be
table.
some candidates would be like, okay, somebody who creates a recurring event, then we'll just like pre-create all of those events into a million years or like
Right, I was just thinking like that would be terrible because we can keep like if we had some product requirement where we can't look too far ahead or than the past, then it's fine. But otherwise, but yeah, then cleaning it up and editing it also going to be terrible.
exactly. I think your approach here for querying for events and then looking for recurring events that might land in like your range, that's pretty good. Really good optimal solution. Yeah, just the notifications part when we were getting into that, yeah, I think one way that I've seen it done is to use like some sort of priority queue that's sorted by the next reminder by timestamp, so we know what reminder to go out. So it's like as events are created, we put it on some queue where we have workers that will look for when notifications need to be sent out, but it's all sorted based on timestamp, and then we could scale those workers up and down, and then pretty much when they look at the the front of the queue, if it needs to go out, one of those workers will take it and then send out the notification kind of thing.
Yeah, I guess the tricky thing there would be like if you add more events to like the middle or something, like how to make sure. Well, yeah, actually no, a priority queue would handle that.
Yeah, so
So that
it's
that, that
priority
is actually
queue.
better. I
And
guess the
it's
downside with that would be you have to have like every event in the queue,
well
at all times.
as events are created, right? We'll push it into the queue, and then when they're
Right,
edited, we can
you're
like
gonna
pop
have
it up.
events that are like let's say you have a recurring event that's yeah, like how do you handle a recurring event in that case? You have to keep pushing in. Well, and actually I think I know how to do a recurring event. Yeah, never mind. You can just say like if the event is recurring and I sent an email, then add the next instance of the recurring event, right? That would handle it.
Yeah, there's ways to do it, but I think yeah, though a queue would be like I think it would be a better way than just keep
And
querying the
this,
database, like have a bunch of cron jobs constantly querying the database kind of thing.
yeah, I mean ideally you want to minimize the querying. Makes sense.
Because you
Yeah.
want to because then you're dealing with horizontally scaling, right? Pretend I have
Yeah.
one who has to handle a range of events, and that one goes down. Now that person can't send it for that their specific range, somebody else has to take over that range, like a different machine. But if you have a
that makes
queue, you could
sense.
just spin up and spin down, and they don't really care about a range, but they just care about who's in the front of the queue, and they fight for like that element, and one
Yeah,
person will send
it's
it out,
easier
kind
to
of thing.
scale because you don't need to like hash run anything. It's literally, yeah, that makes sense. Okay.
Yeah. Overall, yeah, really good job on like for the mid level. I think that would definitely pass. I think for the notifications though, that's like tables like that's key for like that's the key part of here that of this question. Well, not really a key, but like I definitely would have liked a good approach there on the notifications. Yeah. What do you think about that?
Yeah, I mean, I do think what I said, like, I don't feel like it's terrible, but it
Mm.
definitely could be better. So like, I feel like if I didn't have anything or something worse, then it would be bad. But I feel like it
Yeah.
was kind of like, yeah, like I said, good enough for the mid level, and then there's definitely other things I can look into. And yeah, this is one of those like I was saying, this is one of those like 10 or 12 or whatever things you need to know for system design, where once you know how to do notifications once, you can just copy that to everything else. So
Yeah. And there might even
yeah.
be a better way to do notifications. If you ever looked that up, let me know. That's just the way. Like I've got asked this before, and I said that, and it ended up passing. I never actually
Mhm.
looked it up. Like this is not a common interview question that you could just look up online and people have the whole solution for. Which is why
Yeah,
I decided to
exactly.
ask it. But yeah, I think
Mhm.
it's good though to see stuff that you never seen, and I think you did well though. Especially
Yeah.
like most of the time when you're interviewing, you should probably have seen it before if you studied hard enough.
Yeah, yeah. So that's why I'm kind of like trying to learn all the common ones, so then I don't run into a yeah. If I do interview for more stuff or whatever, I won't run into a I don't know it at all type of thing, because that definitely is like the hardest.
Yeah.
I know for
Well,
leak code, if you've never seen that like pattern, you're pretty much drawing dead.
yeah.
So, but yeah.
Yeah, I think, and then even notifications will get interesting too, of like how to send it to different devices and stuff at a high level. But
Yeah.
yeah, I think the recurring events that part was really impressive because yeah, some people like I have asked that a few times and people aren't able to get the recurring events.
Okay.
Cool. Yeah, that's pretty much it. Chat, how do you think he did?
Oh yeah,
Stop
I
the
can open the
recording.
chat again. Definitely not as good as leak code. I'll tell you that much.
Yeah, how do you feel about that? Should we do some more? Different time?
Yeah, I'm definitely down to do more. Yeah. So
Sounds good. All
yeah,
right.
I feel like if I do like 10 of these or 20 of these or something, I'll be quite solid. So
Yeah. Cool.
yeah.
So I'm gonna hop on with the next guy.
All right, dude.
Thanks
All right.
for taking the time out.
Yep. Cool. See you
Cool.
later.
All right, see ya. Yo, chat. How do you think he did? Got another person in 5 minutes. Fahim, how was that for you? Did it make sense? Yeah, I like these interviews a bit more, honestly. I'm gonna fill up my water. All right, taking 4 minute break. 4 minute break, and we got somebody else up next. Yo, how are y'all liking these interviews? Are y'all learning a lot or what? Zedin, what up? Yeah, it's facts. Oh, okay, nice. Happy you got to see a system design interview. Zedin, what do you think? You passing on that? You passing that? Are you able? You think you do good at system design? Supercrack Dev, are you next? Let's get it. Yo, let's get it. Okay, Supercrack Dev, hop on the voice chat. Google Meets. I sent you a Google Meets already. Yo, Supercrack Dev, what's up?
Not much, how are you?
I'm good. Where you based again?
Canada, McMaster.
Nice. Bro, I had like three. You're like the third Canadian on this. What year are you in again? And okay, wait. I'll ask you in the. I'll ask you when we start the interview. Let me look for some good questions for you. Actually, okay. Let's just start this up. Hey everyone. So today I have Supercrack Dev hopping on for a coding interview. Just Supercrack, introduce yourself and what you like. How many leak code questions you do? What companies you're targeting? What year are you in? Like, yeah, how many questions you've done? Let's get a sense of where your skill level is. You're Supercrack,
Right,
so yeah, go ahead.
So I'm on my year off right now doing co-ops, but I would be in my 4th year of computer engineering with a minor in stats at McMaster. I've done 295 leak code questions.
I see.
I have offers from 2 really big companies, one based in the States, and I'm just waiting to hear about work authorization. And then I also had my final round with Amazon on Wednesday, and I'm waiting to hear back from them.
Nice. How did those go?
I had Shopify. That honestly, I don't want to say really easy. I guess fair is a better word for it. Their interview process was very fair. I don't think it was anything that like was unrealistic. Pretty easy technicals. Amazon, it was just an OA with 2 questions. I would say both mediums, also very doable. And then in the final, it's only one final round actually for Amazon. It was just a few behaviorals. I got a hard graph problem, but I'd done a similar one earlier in the week, luckily. So I was able to solve it in about 15 minutes. So I'm hoping, to hear back. Good news.
You got this, man. Okay, cool. Hop into my Google Calendar, or I sent you a link in the chat. When you join, don't put in your real name though. Just put in like a fake. Put like Super Crack. Super on crack. Just kidding.
Wait, you put a link where?
Inside in the messages. In the Google Meets.
Okay.
In the Google Meets, yeah.
Okay.
So you're working right now, or you're just waiting for your...
I'm working right now, but I'm most likely switching roles for the summer.
I see. Nice. So you've done 290 questions even before you graduated. Interesting.
Yeah.
Where do you think your skill level is at? Can you solve mediums easily?
I would say, yeah, most of the time. really depends on the question. Obviously, like some concepts I'm probably a little weaker on, but
I see. Okay.
yeah, I think I'm in the waiting room for the coder pad.
Let me bring you in. Super cracked. How'd you come up with that name?
It was just it was originally my real name, and I wanted to like comment something on a video, and I was like,
Yeah.
shit, I don't want to like dox myself, so I changed it to the absolute first thing that came to mind.
That's hilarious. Okay. All right. So this is how we're gonna run this interview. We're gonna try to get through 2 questions. We're gonna go through 2 questions and around the medium difficulty. I'm gonna give you 20 to 25 minutes on each question, and then
Okay.
yeah, I'll give you full feedback on how everything went afterwards. How's that sound?
Yeah, that sounds good.
Cool. All right, I'm gonna put in the very first question. So we're gonna be given a actually no, I don't want to do that question. Let me see. Okay. This is the question. So we're basically given 2 linked lists. These, and then we need to add together these 2 linked lists and create a third linked list that comes from adding these 2. Like each linked list represents some number, and we basically just need to do elementary addition on those 2 numbers. Pretend one linked list represents 55, and the other linked list represents 55. The next linked list that we should output should be 110. Does that make sense?
Yes. Can I change it to C++?
Sure.
All right. Oh, I thought I copied it. Apparently, I didn't.
I'll put it back in.
Okay. So 2 non-empty linked lists. So I'm assuming we're given the heads of linked lists.
Yep.
Okay. Head non-empty. 2 empty linked lists representing 2 non-negative integers stored in reverse order. So if it was like 981, then it would actually be 189 for the nodes.
Mm-hmm. Wait, see, could you write out what you mean?
Yeah, so if numbers 981, then the list would be.
Yep.
Okay. Contains a single digit, and the digit is an integer.
Is a digit integer? Yep.
All right. Assume that contains zeros. Okay, so since it's in reverse, we can just start right from the head. So we're given our 2 lists. I'll go through it with an example. Let me put in an example.
Sure.
So my thought process is clear. Say 189 and 2, 3, 5. Okay, so we would go through the first one on both. We would add these. We get 3, and then we make that our head for our new list. And then we go to the next one and we do the same thing, except this time we get 11, right? So we would actually have to like mod, what is this? Mod 10 or just minus 10, get this to 1 and keep a carry going into our next one. And then this same here, we would get 14 with our carry 15. We would do the same thing again, 5. We would break our loop because we'd be at the end of both of these, and we would have this at the end. So basically, you want to iterate through the lists on each one, adding the 2 things. You check if it's over 10, say like to check if you need a carry or not for the next number, and you do that all the way through the list. Oh wait, can I assume these lists are of the same length or not?
No.
Okay, so we'll just put in a ternary operator, then assigning the digit to be 0 if it's not. So for example, if this was 1 here, when we go do this digit, we would just assign this to be 0 so that we don't get like an indexing error or like null pointer error. And then that would change this answer to 2. And then after we've iterated, we'll break, and then we'll do one last carry check at the end in case there's an extra digit. Then we would add on the carry if there was. If there wasn't, just return.
Sure.
And yeah, and that would be like O of n, O of n.
What's your time and space?
O of n time, and then if we're including the output linked list, then O of n for that as well.
Okay, sounds good. Okay, yeah, go ahead and implement.
Okay. So we want to return listen. Do you want me to make the list node struct?
Yep.
Right. So I'll have a list node which will have list node next, pointing to the next one, and then we will have our integer value. Then we'll need our constructor. So we'll just do list node in v, and then assign val to v. No, it's not. That's not supposed to be. And then that will be our thing. And then our actual function, we'll say, what should we call this? We'll say add linked list, and we'll take in 2 pointers. We can call this, I guess, L1, L2. And then what we're going to want to do is we will okay, so what we'll do is, well, L1 or L2, so this is checking that at least one of them is valid. We'll say first digit is equal to L1 val. And we'll say, actually we'll have to do the ternary operator here. So if L1, then L1 val, else 0. And we'll want to do basically the same thing for the second list. And then we will get the sum of these 2 digits. Let's call it final d, I guess. Equals d1 plus d2. Then if final d greater than or equal to 10, final d minus equals 10, and carry equal 1. Should initialize carry. So in carry should initialize. Yeah, in carry 0. Actually, here we're going to need to take into account the carry previously, so we should just do that. And carry equals 0, and then node in. This is just going to be a dummy header node. Okay, so, and then once we have our value, we can do, actually we should create another thing. List node cur equals int, and then we'll set cur.next equal to a new node. equals new listener, D, and then we'll need to cur equals paradigm. So, okay, so what we'll do here is we come in here, we create our dummy header for our return. And then we loop through until we're done. We're going to need a final our carry checkout side that we discussed. So if carry, then Grad next is going to equal new list node 1. So yeah, we'll go through, we'll check if the lists are valid. If they are, we get their value. If not, we set to 0. We get the digit by adding them and adding a carry. If this brings us to 10 or over, we take away 10 as a carry of 1, else we set carry to 0, and then we can create the next node in our answer list, and then we move to the next node to iterate, which should also do that for both lists. So if greater than that, and so next. Yep. So I think this looks good to me. I think that this would work.
Let's do a dry run.
Okay. So maybe copy down these examples I made before. Okay, they didn't copy paste for some reason. Okay, I'm gonna do a dry run here at the bottom. So let's assume we have our two inputs, 1, 8, 9, and then we'll do 2, 5, 7, 1. So what's gonna happen is L1 is gonna be 1, L2 is going to be 2, L1 equals 1, L2 equals 2, and this equals. So we get, we create our dummy node.
Sure.
So you can see and is equal to that, cur is equal to ends. Actually, we don't need tracks going. Okay, so we go into the loop. D1, it checks if L1 is valid. It is. So then D1 is going to be 1. And then same with D2 is going to be 2. Then we add 1 plus 2 plus 0. So we get 3. It's not greater than or equal to 10. So we set carry to 0. And we create our next node. So then answer would be 0, 3. And we iterate all of these to the next. So it would be 8 and 5. And we enter the loop again. We check if they're valid. They are. Then we add them, and we get 13 this time. So this time we're going to take away 10 to get 3 and set our carry equal to 1. So now our answer is 0, 3, 3. And we iterate through to next. And we check again if they're valid. They are. So we get 9 and we get 7. We add 9 and 7 and our carry to get 17. It's over 10, so we're going to minus 10 to get 7. Set our carry equal to 1 again. And then create our next node, which is the 7, and iterate to the next one. Then we're going to check if they're valid again. L1 is not valid, so it's 0. But L2 is, so it's 1, and we still have our carry equal to 1. We add them, we get 2, less than 10.
Awesome. Okay.
And then we just create our last node. So here. And then we exit the loop. And we get that there is not a carry. So we return answer.next, which would be this 3 here, giving our return value to be this list.
Okay. Sounds good. All right, good job on that. Let's move on to the next question.
All right.
So this one is, we're given a binary tree. We're given a bunch of binary tree nodes from 0 to n minus 1. And Yeah, pretty much we need to return true if and only if the nodes that we are given form exactly one valid binary tree. So the input will look something like this. I'll show you the input and output. So yeah. So each these are the each node is here. So this would be node 0, node 1, node 2, node 3. This would be node zero's left child and its right child. -1 means it doesn't have a left or right child. So return me a Boolean value if the input is a valid binary tree.
Okay.
Is exactly one valid binary tree.
Okay. When you say the left child for 0 is 1, does this mean like index 1, so the -1, or does this mean the left child has a value of 1?
Its left child is node 1.
Okay. So its left child would be node 1.
Yep.
And then that child 1 is a leaf because it has -1 for both of them.
Sure. Yeah.
All right. So return only true if there's only one valid binary tree. If node I has no left child, the left child will come to for the right child. Note that these nodes have no values. Oh, okay. We only use node numbers in this problem. Okay. So we would obviously start from 0 each time, I'm assuming, as the root. And then it has the left and the right child. And then exactly one binary tree. So what would make it invalid? I'm guessing if there's a cycle, because I would like make it into a graph. Like if we went to 1 and then one of 1's children was 0, that obviously would not be valid. The exactly 1 though, let's see, how could there be more than one possible valid tree? 0 given a binary tree. Does 0 necessarily have to be the root?
No.
Okay, so that's how there could be more than one valid binary tree, I'm guessing. And are all the nodes necessarily like one connected component?
No.
Okay. And for when you say only if all the nodes form exactly one, does that mean they all have to be like valid in the tree?
Yeah, the input is exactly one tree.
Sure, only one valid tree invalid if there's a cycle or if not all nodes in tree more than one. So the if one would be root. Okay, so let's say we just assume 0 is the root and we start from there, and then it ends up being a valid tree. Is it possible for there to be a second valid tree? I don't think so. I think that if we like assumed an index was the root and then we checked and it came back to be true, I don't think it would be possible for another tree to also do it, because if all the nodes have to be in the tree, they all have to be connected, and there's like no cycles, because to make it a valid binary tree, I don't see how there could be more than one possibility of a root. So I'm thinking maybe we just check, like iterate over and check if each index is a possibility.
What do you mean by possibility?
So we would like we would start at 0 and check if it could possibly be a root. So we would go 0, and then we check its left and its right children. And then we basically just make sure that we visit every node, so 0, 1, 2, and 3, without there being any cycle, and then that's a valid tree, I believe. Okay, so if we have 0,
Yeah.
and then its left child is 1, and its right child is 2, and then we go to 1 and 2, and 1 would be a leaf, and 2 has 3. This is poorly spaced out by me, but okay, so we have 0, and we have 1, 2, 3. So if we start at 0 and we go do this check and we realize, yep, we can reach every node without like, any repeat visits, which means like there's no cycles, then that means that we can just return true in general, because when we go to do our checks for the other nodes, for example, like if we try and check if 1 could be a possible root, that obviously won't be true given this tree because we have no way to get to 0. Same with 2 and same with 3. So I believe as soon as we find the first possibility, we can just return true. I don't think it would be possible for there to be more than one possible root.
If there could be more than one possible root?
I don't think there could be, because for it to be a valid binary tree, there has to be no cycles and have all the nodes in the tree, correct?
Yeah, exactly.
Yeah, so I think we can just like basically go through and check, is this one a correct possibility? And if it is, then we return true, and if it's not, we continue through and check. And then if we go through all of them and none of them fit, then we return false.
So for each one, what do you mean by possibility? How do we check right away that if it's a possibility? And what do we mean exactly by that?
We're basically kind of like DFS. Like we could do 0 and then go to DFS. 1, and then we try to go to 1's left child, it's null. We try to go to 1's right child, it's null. So then we go back up to 0 and we go to 2. And we try to go to 2's left child, it's 3. Then we go to 3's left child, it's null. We go to 3's right child, it's null. So go back up to 2, go to 2's right child, it's null. And then we end up back at 0, and we visited everything, and there was no cycle. So it's a valid tree.
Okay. So, let's see. Okay, so your algorithm is you're going to do a depth first search on 0?
I think so. Let me think about this for one more second. Go to 0. And then we do 3. Should I think? I want to do a BFS, but yeah.
Does it matter?
No, it doesn't matter. I just want to code a BFS instead of DFS.
Okay, how are you gonna run the BFS on the 0th node again? I think like the questions.
Yeah, what I'm thinking is like we have like our initial function, and then in the initial function we loop like for I to n or whatever, and we call BFS on I, and then we basically do like if BFS I return true, and then but if it's not, then we just keep going and trying. And when I do BFS I, BFS would be like this. It would be like in root, like we do BFS starting from that root basically.
Wait. Okay, what's your time? Okay, if we, and then what does the BFS do? Could you explain that?
Yeah, so let's say our root is 0, then we obviously push 0, we visit 0, and we go to 0 and we check its adjacents, so 1 and 2. So then we have
What's the return
Q.
signature? Like, what is it going to return? True or false? You mentioned.
Boolean.
Okay. When is it going to return true and when is it going to return false?
True if once we've exited the like BFS loop. If visited, if visit equals 0, we'll initialize, we'll init visited equal to n, and then as we visit nodes, we'll decrement it, and if it's 0 by the end and we didn't have a cycle, then we will return true.
Okay, so if we visit every node and we didn't get a cycle, we return true?
Yes.
From the TFS? Okay. What's your time complexity?
So BFS will obviously be O of n, like where n is the number of nodes, and then but we are potentially doing this with, each index as the root. So I guess technically n squared.
Okay. Let's come up with a more efficient solution.
So how do we check if there's a cycle and if all nodes are in the tree? Do I just do top sort? Can I do that?
Top sort?
Like topological sort.
What okay, how would you, what would you do with the top sort? Like being able to figure out, like what's your goal of doing the top sort?
Just check that the in degree of each node is 1 and the in degree of the, except for one node, which would be the root, which should have 0. I guess we won't need to do this. What if we iterate? Okay, we iterate over the list, like left child. We iterate over this, and yeah, we iterate over this. Iterate over child list, check the frequency of elements all equal 1, except 1 that equals 0, which is the root. Do you understand what I'm saying with this approach?
Yep, you're iterating all the child and checking the frequency of all elements. Like what you're trying to do here is just find the root or any root.
Yeah, so basically we'd iterate over like left child. We'd make the count of like 1, 1. We'd skip over anything that's -1. We'd make the count of 3, 1. Skip over -1. Then we'd go over the right child list, doing the same. And then obviously this would make 2 to 1. And then in the end, we would do a final iteration over this list, and we would make sure that one of them is 0 and that the rest of them are 1, and then return true or false based on that. And that would be O of n.
Okay.
Or, yeah, O of n.
Sure. Let's try that.
Okay. So we will return a rule. And let's just, what should we call this? Check, yeah.
And for coding, we have about 10 minutes left. Like 7
All right,
minutes.
let's do check tree, and then we get int n, and we get 2 lists. Vector int left child, vector int right child, and then we'll do an order. No, we don't need a map. Vector int frequency. We'll get n0 and 4 and frequency at n plus plus. So we'll just do that, and then we'll do the exact same thing for everything in right child. But actually, if okay, that. And then we'll do for int 0 equals 0. And then we want to iterate over the frequency array. So for in f in frequency, if f equals 0, I'm going to change this to a bool. False. Okay, so if the frequency is 0, if we've already seen a 0, return false, else we will just set 0 equal to true. And then else if f equal 1, then we don't need to do anything, so we won't check that actually. But if it doesn't equal 1, then we'll also return false. And then if we get through all of this, we will return 0. And I think that should be the O-event solution.
Okay, walk me through it. Let's work through a case, like the initial case. Yeah.
Okay, we'll do the one from here. Let me paste this down. So we go in, we initialize our frequency thing. So let's do this 0, 0, 0, 0. And then we go through our left child list. So the first one is 1, so we increment it. And then the next one is 3. Yeah, 3.
Wait, what's the frequency? These are the frequencies that of like each
that
node.
we see in the child list. Yeah, okay. For each node. Okay. And we skip negative 1s. And for 2, we increment that to 1, and we skip negative 1s.
But and for 0, how come we didn't increment? Okay, I see. You did, yeah. Okay.
Yeah. And then we get to our loop here with the bool 0 equals false. So then we go through the loop. Our first frequency will be this 0 here. So we'll set 0 equals to true. And we go to the next element. And then we're at this 1. And it's not equal to 0. And it is equal to 1. So we do nothing. Same with this element. And then same with this element. So we break out of the loop. And we make sure that we have seen a 0. So that it's a tree. And then that's it.
So, okay, we're returning 3 because it's exactly 1, 0.
We're returning true because it's 1,
okay.
0.
What if we have a cycle though? What if this is pointing back to 0? What's gonna happen there?
Then there's 1s, and then we return false.
Okay. What if this is pointing to 2?
Then this would be 2, and we would also return false.
Where?
Here. If you see where line 102.
Okay. So we're able to catch cycles.
And then
What if there was a bunch of fours, like all of them had -1?
Then, so let's say we had 2 zeros like this. So on the first 0 in this loop, we set our bool 0 equal to true, right? And then on the second 0, so on index 1 in the frequency array, when we enter this loop, it will say if f is equal to 0, and so it'll enter here, and it'll say if 0, so we have already seen 0, and we return false.
Or the okay, let's see. I think it would work. I don't know if I catch an edge case. I'm seeing any edge cases here. Let me see. Because no one is doing it this way though on the solutions. I didn't do it this way. Let me think. If there's an edge case.
Is there another O of n way?
Let's see. LeetCode Hard, this question is 1361. Let me throw this into GPT. Let me just make sure it actually works. I haven't seen this. Okay, let's actually work through it though.
I feel like there's an edge case with not all the nodes being connected, but I can't think of
all the nodes
an example that disproves it.
Yeah. Like we walked through the. Okay, can you walk me through all the different cases and let's verify each one? Like.
Okay, so we've gone through cycles. It can definitely catch cycles. It can also definitely catch 1, 2 of them or 0. Okay, what's the edge case it would be with components? So, what if there were 2 separate trees? Like 0 went to 1, 2 went to 3. Then they would both be 0, so it would return false. So what if okay, what if there was there's one entering and then one is the node.
Okay, wait, let's see. Like, what if we... Yeah, let's have like a 2 forest. Let me think this. Like we have a...
I'm trying to think. If there's 2 separate trees, it would also still work because 2 of them would have in degree of 0, and then it would fail. Like it would return false.
Oh no. What if we have 3 pointing to 4 kind of thing? Here, do you see my thing right here?
Where are you on the coder pad?
Go into the drawing. I think I found the edge case.
How do I do that? I don't see drawing. Oh, sorry, on the left side. Okay. 3 to 4. Okay, so 0. Yeah, 0 goes to 1. So 1 is a count of 1. 3 has a count of 1. 4 is a count of 1. Yeah. Okay, this is the edge case.
Mm-hmm. That's gonna capture it, yeah. Like I was looking, I was like, there must be an edge case. Like, never seen this solution for it, but I think it's definitely an edge case.
So
that was creative solution. Can't lie though.
Well, what is the optimal solution? Is it O of n?
Yeah, well, like I think you were getting it close because we're out of time. So what I would say is like the optimal solution is find a route that could be any route by finding anybody with an in degree of 0, and then just doing a BFS on that one.
Okay, so it was a combination of the two different solutions I came up
Yeah,
with.
exactly. You were figuring out how to find the route, then you found it, and then you almost had it, but then it was just like, okay, find any route and then just BFS on it.
That's interesting. This is a good question.
Yeah, like it helps you think of graph theory a bit.
Mm-hmm.
I just came out of, I got asked this once, so I was like, oh. I flopped it too. It was a new grad interview. And I almost thought of, my same problem was like, I couldn't figure out what the route was. Or like, which route to BFS on, kind of thing.
Yeah, because you can solve it with the BFS, but it's like the n squared.
Yeah, like where I failed
Yeah,
was
and
like,
then-
okay, I assumed 0 was the route as well. Then I was like, okay, how do I find the route? And I kind of flopped that. But, okay.
Yeah, I knew at the in degrees you could find the root, but I wasn't sure how to connect that back. Oh, I should have connected the solution. Yeah, that's a good question.
Cool. How do you think you did?
I mean, like on a scale of 1 to 10.
Out of 4, would you pass yourself?
I guess it depends how the other candidates looked, but if it was a straight up, maybe like a 2. To be honest, wasn't very happy with my performance on the second question.
Mm-hmm. I think you did really good on the first question. I mean, everyone in the chat was like, "This guy's cracked. This guy's cracked." That's why I had to step it up on the second one. I think the 2nd one was like definitely. I don't think it would actually fail a lot of candidates. I would probably give you like a lean higher. I would like with your case, I'd be like, okay, maybe I just asked him an edge case question, because you were pretty good on the first one. It's like, what if I can ask him I would do like a follow up interview just to make sure that we don't accidentally miss on you. But okay, what you did well, yeah, it needs more signal essentially, because I think that definitely needs more signal, but it's definitely close to passing, and I wouldn't just fail you right away because you did really good on the first question.
What does needs more signal mean?
Like I can't make a hiring decision because it's like,
okay.
we don't know if I accidentally gave you a bad question that you might not solve, or you actually lacked some problem solving skills. Like I couldn't really get that signal, right? Because this one's a bit of an edge case question. You were like problem solving it to some way, but then you got locked into that one solution, and I don't think, like, I think if I gave you more time, you might have been able to lock out of that solution. But I think it would have been hard for you to find that edge case I found, kind of thing. So it just needs.
I knew there was an edge case similar to that. I couldn't think of it though.
Okay, let's see the feedback. I think you clarified the input and output well for the first question. You discussed the working approaches. You coded the optimal solution. The code that you wrote reflected your approach, and you had really good autonomy in the first one. I literally didn't say a word, which is good. So I actually give you a strong yes on the first question. Second question, you clarified well too, right? You figured out the input and output. You figured out the cycles. You figured out that the root is not necessarily going to be 0. Yo, coding with Minmer, thank you. You guys donated. But sorry, what I was saying, you clarified that the root is not 0, which is good. And then the main thing why I would give a no on the second question is because you couldn't get to optimal solution, but you did show you had problem solving skills, right? So I think, just seeing more questions. Like, I think you've already seen a lot of questions. This is probably one that you didn't see before, but I think overall, like, strong yes on the first one and a no on the second one would even out to like a yes. But I would still want to do like one more interview, kind of thing.
Yeah, that's fair.
Yeah, but that's kind of my feedback. What do you think?
Yeah, I think it's fair. So you don't think there's anything specific I need to do better? It was just if I'd been able to get to the optimal solution more so, but the problem solving, like the clarifications and stuff, were all fine.
Yeah, like really good problem solving skills as well. Like, okay, how do we figure out a route? Oh, you figured out like how we're trying to do a route. You figured out the BFS. I think overall, like, generally, I just wouldn't be able to pass you because you didn't solve the question. I
Yeah,
didn't see
sir.
any issues with anything else. Your pacing was good. You walked through examples. Your dry runs were good. I think run your interviews exactly like that every time, and you should always like pass. I feel it's just more make sure that you get the answer, optimal solution, and that just comes with more practice.
Mhm. All right, perfect. Thank you so
All right,
much.
man. All right, I'll catch you.
I got you. See
See
you.
ya. Coding with Minmer in the building. Congrats on 1,000 subs. Congrats on 1,000 subs. Super cracked. Yo, Paul, is this live? Oh, okay.
I don't know, man. Might be AI.
What's up? What's up? How you doing?
Doing all right. I didn't sleep last night because I messed up my sleep schedule, so I had to fix it.
What happened?
I was doing homework on Friday night, and I just I wanted to finish it, so I just stayed up until like 9 a.m. and slept.
Nice. Okay, wait, what's up? Someone. How's that last question? What do you think about that last question?
I've done that question before. I think it's
I
cool.
see. Yeah, it's interesting. How's school, man? Like, when do you graduate?
Like next year, I think.
Yeah.
Next year in either May or probably August. Actually, I think I will need like one more summer class after next May.
I see. What course are you taking right now?
I'm taking networks and robotics AI.
Yeah. Bro, what's that? Is that a fire alarm in the background? What's that?
Me?
Buzzing. Yeah.
It's probably just my mic being crap.
Nice.
I can try to fix it.
Okay. Chat's gonna roast you if it's a fire alarm or something.
One sec. I can probably fix it, I think.
Yeah. It's like a little.
Is it only when I talk or is it just in general?
Let's see. I don't even know. Wait.
Well, I'm
It
just
just
gonna
comes
search
randomly.
back.
Yeah. I'm gonna find you some good questions. Do you do C++ too or Python?
I've coded in C++ in like 2 or 3 years.
Okay. Yeah, I remember. Yeah. How do you think about the people so far? Who you giving the highest rating to?
One sec. Is my mic up?
Yeah, it's better. It's better.
Okay. I don't know. I think that the Waterloo kid, he's pretty correct.
Yeah. What about
You
Russian
guys
guy?
definitely. A Russian guy, I thought he was okay, but I didn't you gave him easy questions. To be fair,
Did I?
I thought they were easy. Maybe just because I don't know. Maybe just some questions are easier to other people.
Yeah. Okay. How many questions have you? Okay, well I'll ask you this when we start the video.
Yeah.
Now I'm gonna find some
I don't
good.
even have the link open. Let me open that up.
Yeah, don't put in your real name or something like a really short name.
Yeah.
Swag demon. Alright, I'm gonna start this up.
I'm tempted to do Vim Vines, but
I mean, you could add it in if you want, but
no, I'm not going to. I don't want to embarrass myself on the stream.
alright, I'm gonna start up this video. Hey everyone, got OG Paul in the building. We're gonna run through some coding questions. We're gonna do it meta style. Probably like we're gonna try to do 2 questions in the span of probably 20 to 25 minutes each question. Could you just give a background of maybe how many leak code questions you were at? Like, yeah, you're in a master's degree program and stuff, right? And maybe talk about that and then like what companies are you aiming for?
Yeah, I'm doing my master's right now. It's like online, so I'm working as well. But I don't know. Right now, probably like remote companies, so like Stripe, although they're kind of going away from the remote. So like Affirm is a company I'd want to work at. places like that, or like Coinbase as well, but Coinbase probably wouldn't hire me realistically at the moment.
Why not?
I don't think my resume would pass like ATS because I've only been working I'm working in a fintech company now, but it's only been for like 3 months
I see.
or 2 months really.
So what are your where are your leak coding skills at, you think?
I think I haven't leak coded a lot, but I'm good at like knowing what algorithm to use. I got 150 solves
Nice.
and probably like 50 or 100 in the past year.
I see. Okay. Okay. I like it. All right. What we're going to do here is I'm going to post in the first question. I'll give you around 20-25 minutes to solve it. Around the 20-25 minutes, we'll just move on to the next part. And yeah, we'll
Alright.
have the criteria at the end. So the first question is you're given a n by n matrix rotated by 90 degrees. So if this is the output,
Okay, so we're just rotating it. We're just rotating the image clockwise by 90 degrees, right?
exactly. So you could look at this input
Okay.
and just explain to me why the output should be that.
Yeah, so effectively for this, we're just rotating 90 degrees. So if you're like familiar with, say, a tire, I'm just gonna draw another example down below that's probably easier to just, let me just move these numbers so it's easier to keep track of. So say you want to rotate this tire. This is like a circular shape. Are you able to see this, right? The
Yeah.
comment?
Yep.
Say you want to rotate this 90 degrees clockwise.
Sure.
You're going to rotate this 1 to here.
Okay.
And this is going to be what was here before. So it's going to be 3, and then 4, and then 2. So everything's going to be shifted 90 degrees that way. So in a matrix, effectively 90 degrees is switching from one corner to the opposite corner, or switching from, say, one wall to another wall. So effectively it's just moving. So see, this 2 here is going from the top middle, it's going to the right middle, and then this is going from the top left to this one's going from the top left to the top right during the rotate.
Sure.
So the implementation for, I guess, like for numbers, just what you need to do to actually achieve this, at least the easiest way in my opinion, is to first just do a vertical reversal, or a rotation rather. So effectively just rotate it over just over the center, a vertical line in the center, right? So say we're going to have the input matrix, and then we're going to have matrix middle, in this case, would equal 3, 2, 1, 6, 5, 4.
Okay.
And then 9, 8, 7. And the reason we want to do this is so we can then afterwards do a simple transpose. And what a transpose is effectively switching the rows and the columns, and since it's n by n, we don't really have to worry about reallocating memory for a different size matrix or anything like that, since it's always going to be a square matrix.
Sure.
So basically we're able to do this in place because it's a square matrix. So we're just going to switch from column, right here we have column 0, 0. We're going to switch that to effectively column, we're going to switch, sorry, we're going to switch column 0, 0 with the opposite one. So effectively rotating it over a diagonal line, if that makes sense.
Mm-hmm.
Um,
You're gonna rotate it
Or
over
I
a
guess-
diagonal line here.
yes. One second.
Okay.
Let me just give me a second. No, okay. Sorry. I misspoke. Are you able to still hear me? I think my
Yeah,
headset might
I can
cut
hear
out.
you.
Okay. I think I made a mistake here. So we actually don't want to do it we don't want to do it over the vertical center. We want to do it over a horizontal. Since we're going clockwise rather than counterclockwise. So here, after we do the reversal, what we're gonna have is we're going to switch this row to the top, and this row from the top is going to be here, so it's going to be like this, and then we're going to do the transpose I was talking about. So we're going to rotate it effectively over this diagonal line, like 7, 5, 3 is the diagonal line, right? And we're going to rotate everything over that line. So 8 and 4 are going to swap. As you see here, they swapped in the final output. 9 and 1 are going to swap. So here. And then 3, since it's on the diagonal that we're rotating over, is not going to be swapped. And 2 and 6 are going to swap. Does that solution make sense?
Okay. Wait, walk me through it one more time. Just need to make sure it's gonna actually work. Let's go back to 741. Okay, walk me through it one last time. Here.
Okay. Yeah. So effectively, we're taking the input matrix, and we're going to rotate over the middle row. So we're just basically going to take this middle row, and we're going to swap everything in relation to that. Just doing like a rotation. So basically swapping this top row is going to go to the bottom row, since it was at the top before. Now it's going to be at the bottom, and the bottom row is now going to be at the top.
Okay.
So this is the first thing we're going to do, and effectively what this is doing is it's allowing us to do a transpose on the matrix, and that will, like, a transpose over the diagonal line. Like, a transpose is basically just rotating over this diagonal. There's like a little bit more mathematical nuance into that, but I don't think that's like relevant.
Yeah, how are we gonna do this transpose though? Like 2 pointers?
Yeah, so effectively what we're going to do is we're just going to go through the rows and columns of the arrays, and we're going to set, and since we're doing this in Python, we're going to do like matrix of row, column, and then matrix of column, row equal, and then we're just going to swap them.
Okay. Okay.
Yeah, and that should work.
So this one, could you walk me through like for so this?
Yeah, sure. So this is the matrix after we've rotated it over, right? So effectively we have 0, 0 right here. So matrix of 0, 0. Matrix of 0, 0.
Okay. Yeah, so it doesn't change
And it's not changing since you're swapping with itself.
Okay.
So that's why these diagonal lines 1, 1, 2, 2, they're always going to stay the same in this format.
Sure.
So here we have 0, 1, right? So effectively we're going to do 0, 1, matrix 1, 0.
Okay.
And we're going to swap those.
Okay.
1, 0, 0, 1. So right here we have 8 and 4, and this is going to be your 1, 0, and these two are going to swap, and that's where you get this final output right here.
output right there. Okay, yeah, go ahead and code that up.
Yeah, for sure. Do you want me to make a class or just write the function?
Just write the function. So
Okay.
Functions.
Yeah, okay, so we're just gonna name this rotate. We're just gonna assume it's in a class, just cause, you know. And the matrix should be in the form of a list of lists. And these are integers, right? Are we allowed to assume that the input matrix is your integers?
Yeah, we can assume that it's correct, and is like valid n by n.
Okay. So effectively, we're just gonna say n equals len matrix. So that's just so we can have the variable for n. Don't have to keep typing len matrix out. Okay, and the way we're gonna flip this so that we don't like double rotate is we're just going to have 2 pointers. This is the easiest way, in my experience, to just switch arrays like this so that you don't end up double flipping anything like that when you're rotating over a center line. So we're going to use a while loop. And the reason top is less than bottom is because top obviously starts at 0 since matrices go downwards in their, at least in the visualization of them. Also, I typed that wrong. Yeah, so what we're going to do is we're going to say for column in range n. And the reason we're saying for column is because the while loop is taking care of our rows. So we're only iterating through each column at this point. So what we're going to do is we're just going to say matrix of top column. I'm going to rename this to call just so it's easier to type. Matrix of bottom call equals matrix of bottom call matrix top call. Does this line make sense to you, like what I'm doing here? So effectively I'm just swapping the top and the bottom. So at this point we have top right here. This is top. Well, I'm just going to go back up to the initial input matrix.
So we're just flipping all the rows, right?
Yeah, basically.
Or like reversing the list.
Yeah, effectively we're reversing the outer list. So in this we have top, and then here's our bottom row. So we're effectively just iterating through this row and swapping these.
Okay.
So that we can just rotate it over the center, the horizontal center line.
Is there a faster way to do that without looking through all the elements?
Yes, potentially, but we have to do it in place. So like it specifically says that we have to do it in place, and we're not allowed to use any extra memory. So we can't really do any swapping of the entire row without using extra space.
Oh, okay. I was thinking we just like call reverse on that initial matrix. If that's what you're trying to
Well,
do.
yeah, I mean that's gonna do the same thing though. Okay. The reverse is just gonna do the same thing.
I see.
Okay, so yeah, we're just gonna increment top here, and then we're going to decrement bottom so that we're going up, and then here top and bottom are going to equal the same, so it's going to exit out of this loop now.
Okay, cool. So that's reversing the rows.
Yeah, so then we're going to go through each element in the array, and this is where we're going to do that transpose operation I was telling you about. So we're going to do matrix of row call, matrix of call row equals matrix of call row, matrix of row call. Yeah, and what this is doing is, like I explained earlier, it's the same thing. It's just rotating over this diagonal line, which is effectively what a transpose is doing on a matrix.
Mm-hmm.
And then we're just going to return the matrix since we've modified it to where it will have the 90-degree rotate. And we can go through this test case here.
Let's go through a bigger one.
Okay.
Test case, yeah. I'll put it in the.
Okay.
I'll drop it in here. Yeah, just walk me through it. Let's just prove correctness real quick. We have about like 5 minutes left on this question, so let's see your dry running skills.
Yeah, for sure. All right. Sorry, I'm just making these words easier to see.
Yeah, for sure.
Okay, so matrix M. This is the middle matrix. So after this, and effectively, I'm just going to like write it as it's being generated, if that makes sense. So the first thing is going to equal this, and then we're going to have top here. So top equals 0. And then bottom is this one, since we're starting obviously at n-1, 3, so right here. So what we're going to do is we're going to go through each column right here. So, and then we're going to say matrix top of call, matrix bottom of call, and then we're going to swap them. So we're going to go 15 goes to 5, and then 5 goes to 15. Well, 1 will go to 14, 14 will go to 1. 12, 9, and 9, 12.
Okay.
And this one will go to 16, and this one will go to 11.
Okay.
And then after that is done, we're going to do top plus 1, bottom minus 1. So now top is here.
Okay. Then,
Bottom is here.
Mm-hmm.
And now what we're going to do is we're going to do the same thing. We're going to go through each column, and we're going to reverse. We're going to like effectively move this list to here, and this list to here. I might have messed up some of the commas, but I think you understand what I'm saying.
Yep.
And then we're going to increment top and bottom again, and then top will be here and bottom will be here. And now since top is greater than bottom, well, greater than or equal to is the exit condition, but it's greater than in this case, we're going to exit out of this loop, and we're going to go to this next part, which is the transpose part.
Sure.
So we're going to go through each element, and we're effectively just going to, I think now that I'm visiting this, I think we're going to run into some duplicate issues here. So what we need to do here is we need to only go from, I mean, we can do this 2 ways. We can do it from 0 to row plus 1, or we can go to row plus 1 to n. Row plus 1 to n is more, just makes more sense to me. So that's what we're going to do. We're going to start from the row that we're at, and we're going to go through the columns past that row, if that makes sense. So just for example,
like basically what you're saying is you flip it, but eventually you're gonna flip it back, and it's gonna be back.
Yeah, because it's gonna go through each element twice, and it's gonna do like effectively it's gonna flip it and flip it back exactly.
Mm-hmm.
Yeah. So what we want to do is we just want to just avoid that. So we're just going to only do it from row plus 1 to n in the column vector. That way we're not double looping and flipping it back over and just doing nothing to the array. So basically 0, 0. So for row, or 0, 0 doesn't even get run. That's also another reason, is so we're avoiding the extra processing time of like running through these and doing nothing. So it's another good reason to only do row plus 1 to n. So we have for row and range 0, so we have row equals 0. I'm just going to write this up here. Row equals 0, call equal 1, because that's where we're starting, right? So now we have this one, 0, wait, sorry, no, this one, 0, comma 1. And what we're going to do here is we're going to say matrix 0, 1, and matrix 1, 0, and we're going to swap these, right? So we're swapping these, and then we're going to go to this next one here, this next column, and we're going to say, okay, we're at 0, comma 2, and we're going to switch it with 2, comma 0. So this is going to be 2, this is going to be 12. Okay, I'm like modifying the wrong matrix here. But yeah, I think you get what I'm saying.
Okay. How would you adjust your code here? Do that row plus. Okay, because you're doing row plus 1, so 0.
Yeah, so we don't ever do 0, 0. We don't ever do effectively. We don't process this or this or this or this.
Okay.
And the reason we don't do that is just because if we do any of these and these, we're double processing. So we're like doing nothing to the array. We're switching it back and forth. And if we're processing these diagonal values, there's no point in doing that because we're not swapping them anyway. Like we're not supposed to swap them. So you're just like wasting CPU time.
I see. Okay. Cool. Let's get into the next question.
Yeah.
I think that code works. Makes sense to me.
Oh man. I just dropped my mic. Did you hear that?
Yeah. Well, I thought you were saying, oh man, because of this question.
Oh no, I just dropped my mic on my keyboard and it like changed colors and stuff.
Okay, so now we're getting to second question. We have about 20 minutes for this one. So we're given an array of positive integers, and this array is strictly increasing, right? And we're given a k. Return the kth positive integer that is missing from this array.
Okay. So, I mean, there's like, so we have positive integers strictly increasing order and integer k. So, like, obviously the brute force solution is we could just iterate through it linearly, and we could just grab. Yeah, so the kth positive integer is missing from this array. Okay, I see. So we want 9 because 1, 5, 6, and 8 are missing, and then 9 is the 5th.
Yeah.
And we're using 0 indexing, so k equals 0, it's going to be like 1 here. Is that right?
Mm-hmm.
Or is it 1 like?
We start
k
at 1.
0 or okay, we start at 1. Okay.
So look at the line 75. It has a better explanation. So 1 is missing, 5 is missing, 6 is missing.
Yeah, so it's 1, 2, 3, 4, 5. Okay, yeah, got it. Yes, and my the initial thought is we could create a set out of the numbers, and then we could just go through the we could just go through the integers and then just say if the integer is not in the set, then just mark that as missing, and then we could just count those. So effectively we could go through and we could say, okay, so say we have an array of length 9, right? And k equals 3. So the maximum number that this can possibly be And we're not including 0 as positive, are we? 0 is 1 and only. 1 above, 1 and above. Is that correct?
Yes, 1 and above.
Okay. I know people disagree on that. Just want to make sure. So what we want to do is we can effectively just say 1 through 9. This is like the best possible scenario in terms of getting the highest number possible. So then k equals 1 would be 10, 11, and then 12. So 12 is the largest possible number.
Sure.
So we could go for the integers in the range of 1 to k plus n, where n is the size of the array. I'm going to write 2, that way it doesn't look like a minus. We could just go through those integers and just count how many are missing until we get to the kth one, and then just say, okay, we've got it. And then that would be a linear runtime.
Okay.
But I think we can get a logarithmic runtime if we do something where we effectively just keep 2 pointers. So we keep a left and a right pointer. And then we just go through them and we just perform a binary search.
Mhm.
And basically, I believe if we do something like, so we obviously have mid equals left plus right
Sure.
over 2. And then it would be something like if array of mid, I think it would be something like this. And then we would want to get the off by 1 error, since arrays are 0 indexed and this is going to be 1 indexed. So we want to subtract that 1, and we do less than k. So this is effectively saying if the array value at the middle minus the number that it should be is less than k, then we want to go to the right, because that means that we don't have k integers missing on the left side of the array. Does that make sense? Because if there were k or more integers missing on the left side of the array, then this difference would be greater than or equal to k.
Okay.
So what we would do here is we would just say left equals mid plus 1. And then else we would just, I think we want to still, I mean, there's a couple different ways we could do this, but I think just to keep it simple, what I'll do is just say right equals mid. We could do like right equals mid minus 1 and then do like a less than or equal here, but I like the less than just because it makes it cleaner to dry run and just makes sense
Okay.
more.
Let's dry run it on example 1 here.
Okay. Yeah, so we have 2, I'm just going to copy
Walk
this
me
down
through
here.
everything you're thinking through. Yeah, when you run it through.
Yeah, so effectively this is going to be left. Okay, I'm just going to name it
Yeah,
L
just
for...
put an L there.
Yeah, and this is going to be right. So what we want to do here is we're going to say mid equals left plus right. So this is going to be our mid. This 4 right here, right? So we're going to say 4. So we have if 4 minus, and the index is 2. So if 4 minus 2 minus 1 is less than k, and what is k in this case? K is 5 in example 1? Yeah, 5. Then we would go to the left. So 4 minus 2 minus 1, or sorry, we would go to the right. So 4 minus 2 minus 1 is 1. So obviously 1 less than 5. So what that means is that there's only one, basically this is the, like this difference here is the number of integers missing on the left side of the array. So if we just take a look here, that makes sense because the only integer missing so far is 1. So this
Okay.
k equals, like this number, this difference here equals 1, and that's the number of integers missing on the left side of the array.
Okay.
So yeah, so basically, since there's only one integer missing, the fifth integer missing is not going to be on the left side of the array, so we're going to go to the right side of the array. So now we have L equals mid plus 1. So now we have L equals this one. I'm just going to put this over here so it's easier to read. So does this make sense so far, what I'm doing here?
Yeah.
Okay. Yeah, so what we're going to do now is we're going to say mid equals left plus right, floor divided by 2. So it's going to be 3 plus 4, so 7 divided by 2, which is 3. So this is going to be our mid. So L and M are the same here. Okay,
Sure.
I'm kind of struggling with the spacing here.
We'll just drop this in this.
Yeah. Okay. So now we have L and M are both on 3, and they're
Sure.
both looking at this 7. So now we have if array of mid. So array of mid minus 1. So 7 minus 3 minus 1, which is 3. And 3 again is the number of integers missing on the left side of this value.
Yeah.
So it'd be 6, 5, and 1. That's 3 integers missing thus far.
Okay.
So now we have now we have 3 missing, but it's still less than 5, which is what we want. So we have to go to the right side of the array again.
Yep.
So now we have left and right both are at 11, and mid is obviously going to get set at 11. Well, sorry, the indexes are at 4, but the value that it's looking at is 11. So now we have the difference that we're tracking is 11 minus 4 minus 1, and this difference is going to be 6. So now 6 is actually not less than 5, right?
Yeah. Like there's 6 missing there. Or wait,
yeah, there's 6.
Yeah.
So there's 6 missing before the 11. So it's going to be 1, 5, 6, 8, 9, 10. So since we only want the 5th one, right? We're going to hit this else clause, and we're going to say right equals mid. No, this is right. Okay. Yeah. So effectively, what this is going to do now is, well, I don't have it coded out yet, but we're going to be in a while loop in this entire situation here. So it's going to be like while left less than right. And then, yeah, so now we're at a point where left and right are the same. Okay, so we break out of this loop. And then at the end here, so we have right. So right is 4. And K is going to be the difference in the index that we're at and K. Well, sorry, the index that we're at plus K is going to be the kth missing integer. And the reason it works that way is because we found the index where it's basically at the precipice where if you go before it, there are less than 5. So if you go before here, if you go before this 7, there are less numbers missing than 5. But if you go between these, there are more numbers missing than 5.
Yeah.
So what you need to do is you need to go to this index here, 4, and you just need to add K to it. And
K to it. Okay.
Yeah, so here I believe it'll always be right, because 4 plus 5 equals 9, and 9 is your kth missing integer. Yeah. And sorry, just 1 second. Okay. Yeah. So effectively, what we need to do
I
is
mean,
we
let's
need
just code it up. I think you're getting close, but we only have 5 minutes left.
okay, yeah, we can just
Just
get this
code it
out
up.
real quick.
Just code it up and then dry run me through the code, and hopefully you can catch it there. I think your binary search approach is making sense.
Yeah, so I'm just gonna def.
And just talk to your process. I'm grabbing water quick. Keep going.
Search array. So we're just gonna search this array. We need k as well. So what we're gonna do here is we're just gonna say while left less than right, mid equal left plus right over 2, if array of mid minus 1 less than k. Oh, it's right here. Left equal mid plus 1, else right equal mid. And then we're going to return right plus k.
Right plus k.
Yeah, and this right plus k, it's similar to a lot of other binary search issues where you want to just return the right index after you exit your loop. But the reason you want to add k is just so you offset that kth element, if that makes sense. Because that index is going to effectively be the difference between the kth missing element and k. So this right index is always going to be that when you exit that loop.
Okay, let's dry run it. 1, 2, 4. We're looking for the first missing element.
Okay. Yeah, so obviously output 3, just so we can have a standard. So left equals 0. R equals 2. And then we're going to say while left and right mid equals 1. So if array of mid, so 2 minus 1 minus 1 less than k. Okay, that's true. So we're going to do left equals mid plus 1. So now left equals 2. And now we're out of this loop. So now we're going to return right plus k. And right plus k is going to equal 2 plus 1, so 3.
Two plus 1 equals 3. Okay.
Yeah.
Let's see. What if we had 3, 5?
Are we still looking for
Yeah,
the
we're
first?
looking for the first.
Yeah, so we're looking for 1 here. So L again equals 0 and 2, mid equal 1. So we go to mid equals this, if array of mid, so if 3 minus 1 minus 1 less than 1, we'll go to the right. Obviously, it's not true. 1, because 1 is not less than 1. So we go to right equals mid. So now we have right equals 1. And then we calculate mid equal to 0. And then we will say if mid, or if array of 0, which is 2 minus 0 minus 1 less than k. Again, 1 is not less than 1. So we're going to do again right equals mid. So right equals 0. Yeah, so right equals 0, so we return 0 plus 1 because k equals 1.
Wait, right
because that's
equals
always
0. But right is at right is at the 0th index.
yeah. So we're returning the right, like the index. We're not returning the value at the right plus
I
1.
see.
We're returning the index plus 1 because that index is basically the difference between k and the kth missing integer.
But like, what if we? Okay, I think it might work. I'm trying to see if there's an edge case.
I think this should work. Like,
Cause what if the
I
numbers
think
are
this-
like yeah. Let's see. Cause okay. Trying to see if there's an edge case. Give me a sec. So if, because I'm wondering if k here is always the right way to do it. Like, what if we're
I think it should be because, like, whenever you exit this loop, you're at the point where you're like at the balance point, right? Where you're at the best index you can possibly be, and you have this, say this index is 0, and you know that you know that you have 1 missing before 0. So the first missing before the 0th index, if it's before the 0th index, it's always going to be 1 if this is 1.
okay,
right?
Alpha had a good idea. We're throwing this into the leak code real quick. So, submit. Nice, it works.
Yeah, I thought.
Okay,
I figured it would.
nice. How do you feel about your performance? Oh wait, let's see.
I think I don't explain things well. I think that's something I need to work on. I think like I mean these are really easy questions, but
Really easy questions. Interesting.
I mean I'm pretty that last question had to have been an easy. Like I put money that was an easy.
Okay. What about the first question?
The first
Okay,
question, I
wait,
mean, I know it's considered a medium, but it's like a
Yeah.
graph, so it's like
I see.
fake medium.
Okay. So you think, yeah, just better explaining.
Yeah, I mean, I think like my algorithms made sense. I
Yeah.
don't think many people would come up with the log-in solution to the second problem.
Exactly.
I think O of n is like really easy. I think log-in is like kind of hard to think of on the spot, especially like to think of that right plus k. I don't think many people would think of that,
Nice.
but I could be wrong.
Yeah.
But
I mean,
I also don't. I also think it's hard to explain just because, like the way I think about it is like a math perspective, and if I try to explain that to any coder, they're just gonna be like dumb, like just no clue what I'm saying. So
yeah.
it's hard to explain it.
Yeah.
I need to like actually figure out how to explain stuff to people whenever I think about it like that.
Yeah.
I just need to think of like the coding way to explain it.
Yeah. No, overall, really good job. Definitely a yes. I'm trying to just think it would be a strong yes. I think definitely a pass, but on the first question, you took about like 20 something minutes. A strong yes would probably be like 10 to 15 minutes to solve that question.
Yeah, I mean, I could have coded that in like probably 45 seconds. It's like hard for me, like I said, it's like hard for me to explain that.
Yeah.
Because
I think,
explaining transposing matrices in like a dumbed down way is hard for me to do. I don't know. Like to explain just, we're just rotating over this diagonal array, but it's not exactly what it's doing, but it's like what it's doing in a visual perspective.
Yeah. Okay, let me bring up my marking sheet and see if you hit everything, and then I think it was like borderline strong yes. And not just saying that because I like you. You actually was able to hit the good answers. I mean, honestly, that's not a hard. I mean, that's getting log in. If you just look at the discussions, people are so mad about that. Like, it's hard to find log in for that one.
Yeah,
I could see
that. I could see why if you're not super.
Yeah.
I don't know.
I would say for the rotate, you took a few, like you tried a few things, but you noticed why. But I think you tried like 2 or 3 things, and you caught yourself a few times. Like
honestly, it's because I'm pretty sure the leak code question is rotate counterclockwise. So I was thinking about rotating counterclockwise.
Okay.
So I reversed it for a second.
Yeah, But I think even the part where you like went through the whole list and you would like flip it back, but you eventually caught that. I think you were dry running it, and you're like, oh, we flip it once, and we will flip it back.
Yeah, I mean, in my head, I knew that I shouldn't run it. That I just wasn't like thinking whenever I was coding. But
Yeah.
like whenever I started running it, I was like, oh, I don't know why I did that.
Like even for 53 here, you could probably have just like reversed like this, right?
I mean,
like,
yeah, you could just like matrix out reverse if you really wanted.
or just not even like per element too, but just like flip the top and the bottom.
Yeah,
Like
yeah,
that.
you could
That would
do
speed
that.
it up a little bit. Like not really in runtime complexity, but okay.
I mean,
You asked the right questions. You discussed the multiple working approaches. Yes. You pretty much coded up what you discussed, but you had to change things up while you're coding a little bit. That's the one thing. Where you said one thing and then on the fly you would catch yourself. So if I were to give a strong yes, I would like want you to catch all those up front, all the edge cases. But that would be like the main thing. And then your dry running was really good. And yeah, overall like that's a pass.
Yeah, like I said, I think I don't think the code. I feel like these are easy questions to be honest, but I think like the coding part, I think is not hard for me. I think it's just the explaining part.
No, good job. How do you feel about that performance? Are you giving yourself a strong no yes or a strong yes? Do you think my feedback was valid there?
Nah, I think your feedback was super valid. I just need to practice more, like do more mocks explaining, because like I can do leak codes, but if I'm not explaining them, I'm not really practicing what I struggle with.
Yeah, I think it's super good though. Like you caught all the edge cases, like even by just modified binary search, like you're capturing. One thing is like 126 in Python it doesn't overflow, but sometimes better do left plus right minus left divided by 2. I don't know.
Oh yeah. Yeah, that makes sense.
I think also 124 here, your length of array you should -1, so that would have thrown a syntax error, like little small nits like that.
I don't think I should do that there though.
Which?
I don't think I should do. I think I should be doing length of array.
Oh, okay. You're thinking okay, yeah, because it won't.
Yeah,
Well, I mean,
I'm
your code
forming
did
it.
work. Yeah, actually, what am I saying? Yeah, you're good there.
Yeah, because like it'll never be trying to access array of right.
Yeah,
It's not. That's just for the binary search. It's not actually accessing
nice. No, yeah, definitely. If this was meta, you're moving on to the next one. They're gonna do 3 more rounds just like this. But good job, Paul. I'll see you around on the streams. Gonna grab the next person on there. Strong.
Right.
Coding with Minmer says you're a strong hire too. So nice. Sleep good tonight, man. Sleep good. I'll talk to you later.
Thanks, man.
I see you.
See ya.
Yeah, if Minmer says you're in, you're in. Okay, we got somebody else coming on. Stay in the chat. We got one of my friends from college. So you're gonna see how how good people in my college are, which is gonna be interesting. Wait, I'll be right back. Give me a sec. Give me a break. I'm gonna take a quick break. Yo, Alpha, if somebody doesn't show 6 to 7, you want to do another system design? 6 to 7? If I get a no-show? Farzan, I just make them up sometimes. Or I honestly I ask a lot of ones. I ask ones that I get asked. Like I've been asked the Google Calendar one before. As a new grad. Okay, I'm getting my next person on. One of my friends from college. Y'all get to see what University of Calgary students is like. He wants to remain anon though. Saji. Just trying to figure out how to send. You want me to do the mock? Let me see. Bro, I'm kind of fried right now. Wait, let me send him a message. I'm out every night and ain't nothing. Wait. Can you send me 1 sec? Trying to get this guy on. Okay, wait. I'm getting hungry. I haven't ate all day. Yo, chat. Get him. He's coming on. He's about to pull up. Yo. My audio working? Yo, college friend, what's up?
Yo, what's up? How's it going?
Pretty good. Everyone could hear him, right? Wait, let me fix up my guy taking a nice sip of water.
Yep.
Feeling nervous?
Nope. We'll see how it goes.
Wait, let me check.
It's got to get in the same mindset as a real interview.
Bro, I'm starving. Wait, let me just checking the... Let me just do some verifications on the... Alright, it's peaking right now, 32 users.
Okay.
Let's get it.
Yep.
How's your day going?
Good, good. Nothing much, nothing too crazy. How's your day going? How's
Lead
stream?
coding on Sunday?
Not yet, not yet. So I might be a little cold.
Come on, don't make excuses right now. Just kidding. You seen the other guys go?
I was watching a couple here and there.
Nice.
Popping in and out when I got the chance.
Cool.
Everyone's been pretty good, so we'll see if I'm the first new hire of the day.
Let me look for. Everyone's like, watch. This is like everyone thinks it's a quant dev just hopped on.
No.
Okay.
Just a college friend.
Let's see. We'll see what the chat thinks. Let's see. I'm gonna send you a coder pad.
Okay, sounds good.
I like this coder pad style. I'm gonna have to pay for
Yeah,
this.
no, it's like a real interview style. I like it.
Okay, I'm gonna send you an invite in the chat.
Okay.
When you join, don't put in your real name. Put an alias.
Sounds good. Yeah.
Put like quant dev or something. Just kidding.
I'll put college friend. Okay, I think I'm in.
Okay, let me find two good questions. Let's see. I'm gonna go hard on you. No, I was kidding.
Do whatever.
Find two good questions. Oh, this guy said do whatever. All right.
Yeah, do whatever
Coffee.
questions.
This guy said do whatever is crazy. Okay. And like some of the questions might be vague as you noticed.
Mm-hmm.
So it's important to clarify the requirements, right?
Yeah.
You already know this stuff. Just let me find a couple good questions.
Yeah, no worries. Take your time.
Check. No, start the video. After I find two good questions.
Okay.
I'm saying ask. LFU cache. Wait. Trying to find a good one.
Okay.
Just look at my list real quick. Okay, we're gonna start off with this. Okay, I'm gonna start up this video.
Sounds good.
Wait a second. I'm just putting on the light. Yeah, Farzan, don't worry. I got some good ones. Okay, 3, 2, 1. Wait, how's audio, everyone? How's audio? College friends, you can hear me good, right? On
Yeah,
your
I can
end?
hear you. Yeah, I can hear you.
Audio's good. All right. Let me bring out this good question. Okay. I'm gonna start this up. Wait, can you say something real quick?
Yeah, hello? Yeah.
Okay, I might have to put your volume up a little bit. Hey everyone, so today I got one of my college friends. I'm gonna be putting him through a meta-style interview where I'm gonna be asking him 2 medium to hard level questions in the span of 45 minutes and have him solve those questions. Yeah, pretty much. Yeah, around 20 minutes each question. If you don't get to the solution, we're just gonna move on to the next one. And yeah, let's get to the optimal solution. How's that sound?
Yeah, that sounds good with me. 20 minutes
Okay,
a
cool.
question. Might as
Sounds
well.
good. And I'll like provide feedback on everything as well. We're gonna start off with a medium question. Feel free to start reading it. I'll mention it actually. Okay, so we're gonna be given an array, right? An array has some empty spaces, some are zero. Pretty much the empty spaces are zeros, and the other ones are ones, right? Ones basically we have walls and spaces, and basically we start with a ball in a random area in the matrix, and we could start rolling that ball left, up, down, left, or right. But when you start rolling it, it will keep rolling until it hit a wall, right? So basically what we want to do is if we're given a start and a destination, find out the shortest way that we can get to the destination. If we can't get to the destination, return a 1, right? Does that make sense? And feel free to clarify.
Yeah, let me just give it a read. So there's a ball in a maze with empty spaces, and walls represented as 1. And it could go up, down, left, or right, and it won't stop rolling until hitting a wall. When the ball stops, it could choose the next direction. Given an m by n maze, the ball start position and the destination where start is equal to start row and start column and destination. Let me copy this out. Return the shortest distance for the ball to stop at the destination. If the ball cannot stop at destination, return -1. The distance is the number of empty spaces traveled by the ball from the start position excluded to the destination included. Okay, and you may assume that the borders of the maze are all walls. See examples. So to clarify, I guess the input is going to be maze. Is it going to be a 2D matrix? Is that right? With 1s and 0s?
2D matrix, yeah, 1s and 0s.
Okay. So it could be like borders. Okay, so let's see. Let's make up an example here. So if we have actually, let's just make it all empty. If it's all empty, then it's if we have start is equal to 0, 0, end is equal to 2, 2. So in this case, an example path might be, let's say, since we're starting here, 2, 3, 4, 4, right? Because one would be exclusive and then inclusive of the last element. Is that right?
Inclusive of the last element?
Yeah, the destination inclusive.
Okay. If everything's a 0 here, though, right?
Yeah. Oh, I see what you mean. Oh, so the actual path would be, be this, because you can't, yeah. So it'd go down, hit the wall, and then go to the right to get to the destination. So it'd be 4. Is that correct?
Yep. It traveled 1, 2, 3. Yep, it traveled 4.
Okay. And then I guess you could only change directions when you hit a wall. So we're only allowed to change the direction when we hit the wall. And then when the ball stops, you could choose the next direction. Let me see. And then walls are. And then to clarify, can we assume that the start and destination aren't like within a wall, like it's like a valid
Yep.
configuration?
You could assume it's valid. And you could assume that it doesn't start at the destination.
Okay. So listing out the assumptions here. Is there anything else that I should? And I guess we could also assume that start and are in the grid. Like for example, start row and start column is less than the m by n maze size. Is that a valid assumption? Okay.
That you're just trying to clarify if they're actually the start and destination are within the array.
Yeah, exactly. Like for example, if for this maze, like we're not going to get like a start of 100, 100,
Yeah.
or a destination of okay, cool. And I guess all elements are either 0 or 1. Is that right?
All
In the
elements
matrix?
are- yeah.
Okay, sounds good. So I guess I think this makes sense. So I think the brute force solution here would be basically doing a breadth first search for every possible direction slash position within the matrix. So for example here, let's take this maze and paste it in here. I'll change it back to 0. So in this maze, we're able to, since we're at the starting position, we're able to go either up, left, or up, down, left, or right. If we go left, it's basically gonna bounce back, and then you could go to the right, but you could go to the right directly anyways. So there's no point in doing that. So let's say mark it with let's say A for like the first move. So A, and then we get to like another. We hit a wall, so we're basically allowed to change directions. So in this case, since it's pretty simple, we'll just go down. But in the breadth first search, we'll just check every single direction plus every single direction plus every single, let's see, every single direction plus position. So if we're going to go down, in this position, we'll go, we'll traverse all of them, but let's say we go left, we'll basically get back to the same position, and then all the other directions will have already been traversed in like the breadth first search. So we'll stop the exploration there, but we'll also traverse downwards where we'll go like A, and then we'll get to the destination. So that'll be like one possible solution. So like this is like 4. But because we're doing a breadth first search, we still need to see what other paths are available, or the other paths are also going to be explored, I should say. So another one would be like B, and then we'll get here. So that's like one possible solution with breadth first search. If we're trying to find the, let me see, the if we're trying to find like the shortest path, I could see like this is an easy example because there's no walls, but maybe we could use Dijkstra's where you'd add, let me see, you'd add the like you'd basically be traversing the minimum current path with based on like where the ball is able to roll to. So if we start at start, could check any direction. We go all the way to the right. We'd all go all the way to the right, and then that would be like 1, 2. It'd be 2. We'd go all the way to the bottom, which would be 2 as well. So
Wait, are you writing
that
anything on? Like it's not-
no. I'm just highlighting them in the maze. So I'm thinking, yeah, I'll note this down. So or BFS the direction slash position. And then also the current one is extras for basically popping the minimum current path, and if it gets to basically a cycle, by cycle I mean so if you get to a cycle, then cycle, meaning you've been in that same direction. Don't continue. Otherwise, if you reach, let's see the destination.
So what are you storing in this priority queue if you're using Dextrose?
So the distance, so it'd be like distance, row, column, direction. So I actually don't think you need to store. Do we need to store the direction? I don't think we actually need to store the direction, because if we only stored in the queue. So we store the distance, the row and column, and then we don't need store direction if we only. Yeah.
We have about like less than 10 on this, so let's just code it up. I think you're
Sure.
getting to the right approach.
Sure. Let me see. So it's a ball with a maze. See shortest. And then, so I guess shortest maze or shortest distance maze, which is a list of integers. Yeah. And then we have, what else do we have? Start, which is a list of integers. Destination, integers, and then we'll return integers. So yeah, we'll return -1. So, well, let's see. So we start at the maze of 0. Okay, let's see. So, and then we'll initialize it to start at 0, start 1, 0. So we'll go, let me see, do we need to keep track of visited? Yeah, we'll keep track of visited. Set, so while queue, if, so we'll dist row call pop queue queue.
Cook. Got 5 more minutes.
5 more minutes? Okay. Equal to column, return dist. Okay, so if this row is equal to in visited, continue visited add or it's roll call actually. So now we'll go. So now we're in a position where we're able to pivot essentially, like go in each direction. So we'll try that. So if we assume that we're able to pivot into a different direction, we'll go up, down, left, right. So up, down, left, right. So if
I know you mentioned this before, but what's it called? It should be able to roll until it hits a wall.
Yeah. So we'll go, can pivot into a different direction. So we'll go up. So while, let's see, doing this save temporary parameters. So new. While maze row, so while row or new row, let me see, while new row is greater than or equal to 0, and maze new row call, let's see, new row column -1. So if we go up once, and then we basically need to continue until it's gets out of bounds. So while new rows greater than or equal to 0, and maze call equals to 0, we'll go new row minus equal to 1. And then we just need to go up. So this will go in until it either reaches 1 or out of bounds. So we'll just increment it once here. And then if new row not equal to row, we'll go heap dot heap push pq, and we'll go dist plus row minus new row, or yeah, that's correct. So because row is going to be bigger, and then new row column, because column will remain the same, and then we'll basically just do the same thing for, why is this having a problem? No. Okay, and then we'll basically be doing the same thing for the other ones. So we'll go down.
Yo, chat, you can hear me, right? How's the audio? How do y'all think he's doing?
1, while new row is less than or strictly less than length of maze, and maze new row column is equal to 0. We'll increment this one, and then we need to remove one here. So new row not equal to row. We'll go row. New row is going to be bigger, so we'll go new row minus row, new row column. So we'll do left which is new call is equal to column -1.
Yo, chat, how's my audio? Audio's
Well,
good?
new column is greater than equal to 0, and row, this will remain in a new call. We'll keep going right. New call minus equal to 1. And then new call plus equal to 1. Let's do the same thing. Left call not equal to call. Let's see, distance plus call minus new call, row call. Then do the same thing here. So +1 less than of len maze at 0, new call, plus equal to 1, minus equal to 1. New call, let's see, minus row. So this is going to be for changing, or for each of the directions. And I think this should get us the answer that we're looking for. And we could quickly walk through an example.
Can we make it more concise a bit?
Let's
it's a bit hard
see.
to follow.
Yeah. Let's see. If we go... Let's see. If we go direction is equal to, let's say, can you do that? Yeah, sure. So we go -1, 0. This is not, doesn't have the formatting I'm used to, but let's say -1, 0. So this is like, if it's row, yeah. 1, 0. Say 0, -1, 0, 1. So for, let's say column move, row move, or actually we'll do row column. Row move, column move in direction. We'll go let me see what conditions we add. We'll do while new row. Let's see, I'll copy this. Yeah. So while new row is greater, new row equals to row plus row move. New call is equal to call plus call move. New row is greater than equal to 0. See, new row plus equal to row move. New call plus equal to call move. So new row is greater than equal to 0. And row is less than length of maze. New row, new call, So this is for the first, for row, then we'll just do the same thing, and new call greater than or equals 0, and new row less than len of a 0. So while we're
Oh, okay, we'll switch to another question. Let me
Yeah.
get it. But keep going. I'm grabbing it.
Yep. Dist, new row, let's see. If new row not equal to row, or new call not equal to call, we'll go add this, and then we'll add absolute of new row minus row plus absolute value of new call minus call, new row, and then new column, and then that we could erase all this. So
Nice.
just, yeah. So this should get to the solution that we're looking for.
Okay. Give me a sec. Cool. I'm gonna post. We're gonna go to the next question.
Mm-hmm.
Let me. One sec. Trying to find a good one. So I know all the questions you've done.
We'll see.
Okay, we're gonna get into question 2.
Okay.
So
okay, let me read this.
Yeah,
or
go ahead.
do you want to read the question?
Yeah, we're essentially we're given a binary tree, and we want to figure out the maximum path between 2 nodes in the tree. So and yeah, a path is pretty much any like from one node to the other, and the maximum path doesn't have to go through the root, essentially.
Okay, so let me see. So a path in a binary tree is a sequence of nodes where each pair of adjacent nodes. Okay. Okay. Assumptions. I guess the tree will have negative values because otherwise you'll just return like. Yeah, I guess the tree can have negative values. Is that right?
Yep.
Negative values. It can appear in a sequence at most once. Okay. Let's see. Path does not. I'll just copy this from here. Path does not. Given the root of the binary tree, return the maximum path sum. And does the path need to start at a leaf, or can it start at any node?
It could be any node.
Okay. At any node, not the leaf. Okay, so it could start at any node. So let me draw out an example here. So let's say we have 1. So that'd be the root, and then we have left, right, oops, right.
Yo, chat, what are we giving him on the last one?
Left, right. And then we have, let's say, -1, or let's say -3, 10, negative, or yeah. And then we have, say, let's say -5, or actually let's do -1. So in this case, the maximum, and then can the maximum path be itself, just like one node?
Yep.
Okay. So example 1. So in this case, let's see, what are we returning? Pass sum, so output would be 10 in this case. Is that correct?
Yep.
Okay, and then we'll just write another quick example. So let's say that's like when a single node is the optimal solution. If we say 5, then this would be output would be 16. Is that right?
Yep.
Okay, and then I guess we'll do one more example to further clarify things. Let's see. Output is, let's say this is 10, or is it distinct?
No, could be anything.
No. Yeah, it could be anything, yeah. So in this case, this would be 21 because we could only pick like one of these paths, right? Or actually it'd be 25, right?
Yeah.
So 25 because you could go 10, 10 plus 5.
Yeah.
Okay, interesting. Okay.
Yeah.
So
You captured the cases. What are you thinking?
So I'm thinking that, so at each node, I guess we're going to need to do some traversal and then make some decision there. So for example, in this case, what we wanted, so at each node, make some decision. So at node 10, we had pass some, let me see, we need to pass some left. Pass some. So a node can join two paths that create substitution 3. It might be
Sorry for the sirens in the back. I live in the Tenderloin.
2, or actually this is EX1, and then might be some point within the path EX2. Okay, so let's say if we're going to do this, if this is the case, then we get add the max path for the left and max path for the, or actually for the right, and current node val. So join to current node val. This one, check gains some global value. Might be some point within the path. Return the max pass sum. So return the max pass sum, meaning you either return current node val if both left and right are negative. Otherwise, return
Okay.
max.
How are you gonna
left.
know the max path to left and right at each node?
That's the last case right here. So return the max path sum, meaning you return the current node val if both in left are negative. Otherwise, you could actually just do this. So it's like current dot val plus left dot val, or left, yeah, I guess left sum, or current dot val plus right sum. So this is basically saying take whichever one is the greatest. So current dot val, left sum. So this is like if the left subtree plus the current is higher, you use that, or if the right subtree plus the current val is higher, then you use that, which is going to result in the, I guess, the maximum sum. And then, for example, all this could be negative, so that's why when we're traversing it, we actually check like the first node or the current node val, or sorry, that's the itself. So this one right here, check against some global value. Basically, if itself is like a maximal value, then it's just going to set it as itself.
Okay, let's get to coding then.
Sure. So we could do, what is this called? Max path sum. Sure, we'll do max path sum of I guess what could we just use like the typical definition of like a tree node?
Yeah, exactly.
So we could just do
What would
like
that be?
val left, right.
Yeah, and we could assume that we're given the root, and we could assume that it's a valid binary tree.
Okay. Sounds good. So we'll go root. We'll just keep it as that, and then we'll return. We see the max path sum to be an integer. Let's see. So we'll go. Let's see, what do we need to return? We need to return we need to return the max and then the path. Okay, sure.
We're just returning one number, which is the max.
Yeah, I know, but I'm just creating traverse node, and this will return two integers. And then, so we'll go. Let's see, one will be return max and also max path. Minus one, and then so the max will be 0 is equal to traverse for the root return, and then we'll go. So let's see. So if not node, return 0. Return 0, 0. So the max is 0. If not node, return 0. So we'll go left. Let's see. L max, L path is equal to traverse node dot left, r max, r path is equal to traverse, node dot right. So what information do we have now, and what do we need to return? So let's go through each of these cases. So it can join two paths that create an optimal solution. So it could either be like, if it's joining, it could be like,
For time, we only have a few minutes left.
okay, so we'll do this, or this. Okay, so we'll do right, left, right. Okay. So we'll do so max join path is, let me see, max, I think this should be simplified, but for now I'll just do it this way. Node dot val, actually I'll do, node dot val plus L path plus R path, and then we'll do node dot val plus L path, node dot val plus R path. So this is for the first case. It might be an optimal example. So yeah, we'll also just do this. Node dot val, and then might be some point within the path. Let's see, do we catch this? So this is the max that in the current path. And then we just need to do if it's the max itself. Okay, so we'll go max current.val. Let's see. Actually, we just need to do this. Max, because. So one other way to do this is either set it as a global variable or an instance variable, so that we just don't need to return two values, but just for the sake of this, we'll just return two values instead. And then we'll go max cur dot or node dot val, node dot val, L path, node dot val, R path. So this should get the, basically what this is doing is getting the maximum sum of either itself or with one of the branches, so that when the parent basically tries to use it, it's going to actually get a path instead of getting like it won't be a tree, it'll rather just be a path, or like basically a linked list there.
I see. Okay, can you walk me through it?
Yeah. So let's say we start at the example. Let's just run one of these examples. So let's say we start at root 1. We're gonna, if not node, return its valid value. So we'll go left path. So traverse node dot left. So we'll go -3. -3. Let's see, -3, and then we'll go left. So left is 0, 0, right is 0, 0. So max join path is going to be 0 in this case because it's a negative value. So node dot val plus, I guess one case that this would break for is if everything, let me see, if every node in the tree is negative, because I guess what this is basically saying is that you could pick nothing, but let's see in the question if we need to pick something.
You gotta pick something.
Okay, if we need to pick something, let me see how we would change this. So if we need to pick something, we basically do max joint path is equal to node.val. And then we go if node.left if node.left max, let's see, path, let's see, max path is equal to, let's just say this, sure. If node.left, this, erase this. So yeah, we'll erase that. And we'll go node.val, max path is equal to if node.left, val path, max, set max join path is equal to max join path. Oh, that's annoying.
Okay, you're basically trying to catch the.
Yeah,
like,
yeah.
Don't traverse into nuns.
Yeah, exactly. Yep.
Okay. All right, we had
Okay.
I think you're good, heading to the right solution. So, but we have to. We're gonna move on to the next one. How do you
Sounds
think you
good.
did?
Me?
Yeah.
If I was rating this candidate,
Yeah.
probably let me see. Let's see the previous solution.
What are you giving them? What's the rating out of strong no, yes, or strong yes?
Probably leaning no, border. Yeah, probably leaning no.
Leaning no.
That's tricky to say because I guess let me just think. If I was an interviewer, like what my thought process would be here is let me see. Let me think if so for the shortest distance, I guess I would need to know what the optimal solution is. If it's extras and they're on the right track for that, then that's a positive signal. But if there's like obviously if they miss the optimal solution, but Dexter's still is a valid solution,
Mhm.
then that's that might be like a weak higher or leaning no. And then for the second question, just ran out of time, but on the right track, so that's why it's like probably leaning no. But since the direction was good, and then also the I guess this would be up to you to say like whether it's good or not, like walking through the examples, stating
Yeah.
assumptions, going through the dry run was okay, so it'd probably end up resulting in it needs more signal or re-interview or depend on other interview results.
I see. Okay. I think I would actually give you a lean higher. Because I basically gave you two hard questions. I mean, everyone in the chat said the first one is kind of a hard medium. So I would, yeah, and then the other one is just straight up hard, but it's easier hard. So given the circumstance of two hards, and you're able to make good progress with minimal hints, yeah, I'll give it a lean higher or just a higher. But I think where you could have improved was probably like the first one would be the explanation could have been faster and more concise. Like I was getting lost a bit. I think you were explaining it for like 20 minutes and then coded it up within 5. I mean, it's a good ratio, but yeah, it was like a long-winded explanation. Because I think at some point you could have just like, yeah, it could have been more
Covered it up.
concise kind of thing.
Yeah.
And then you mentioned Dijkstra's, but not explained exactly why Dijkstra's would work and not just a regular BFS.
Right. I guess that's true.
But yeah, I think overall clarified everything really well and talked through this solution. People really liked the way you clarified and talked through the solution. But it was just, yeah, I think it would just be more about pacing. Like in the meta interview, you have 40 minutes to solve both these questions. You would have ran out of time essentially.
Yeah. Are these both tagged for Meta?
Yeah, they'll ask you this.
I see.
So it's more just about getting faster at it. I mean, I don't know if they'll ask you two hard questions. I think they'll ask one easier and one harder. So that's why
Yeah, because
I
if
like
this
to
is
give
both
more.
in 40 minutes, that'd be tough to
Yeah,
do.
I agree.
But yeah, definitely see what you're saying though.
Yeah. Okay. Overall, good job, man. Catch you later.
Thanks,
Grab the
man.
next
All right, I'll
person.
catch you later.
All right, see ya.
All right, see ya.
Yo, chat, what are we giving him? Higher? No higher? Strong higher? I'm giving him a higher. I'll give him a pass on this. Give him a pass on this. Yeah, I'm giving him a lean higher, not like a super strong higher on that one. But like I did give him harder questions. I think that would have folded some candidates. Yeah, Max Patsum is a hard. Okay. Alpha, you ready? Yo. Yeah, I'll give you normal stuff. Alpha, I sent you a link on Google Drive. Hop in. Yo, Pablo, I'll slot you in for 7 to 8. Yeah, we can do C++. We could do C++. Yo, message me. I see. Yo, Alpha, what's up?
Okay. Hey, can you hear me?
Yeah, I can hear you. Yo, chat, how does he sound? We're gonna get Alpha. Can you talk again, quick?
Yeah.
All right.
Yeah, I don't know how I sound.
Yeah, I think you're good. I think overall good.
Okay.
Or just let me know how he sounds compared to, like, volume-wise compared to me.
Voice rating.
I ask you normal stuff, man. Don't worry. I'm gonna treat it like a
Yeah,
real
dude, I'm
interview. I'm
freaking
not gonna
fried.
be like some random one.
No, yeah, I'm fried from the system. That first one you asked that other dude, honestly, was pretty tough. Like,
Yeah.
I don't think that in 20 minutes seems pretty ridiculous. And the thing is, like, like I just did the problem with no talking, and it took like 10 or 15 minutes. But like
Yeah.
talking about it and all the other stuff just adds so much time that it's like really hard to.
Mhm. Okay, I'm gonna get you in.
All right.
Let me find this. The maze. Holy crap! How long has this stream been? I need to. As soon as it hit this 10 hour, I'm gonna cut.
Yeah, I don't know. It seems insane. Like I wouldn't be able to interview people for this long. I would just stop paying attention after like 2 hours.
Let's see.
Yeah, content farm.
There's like 10 videos. I won't have to make videos till I can go on a nice vacation.
Yeah. Yeah, I should have recorded the first one. I'll record this one.
I'll send it to you if you want it.
Oh, actually, yeah, that's a good idea. Yeah, if you're
that's
recording
okay.
them all, I guess you can just
Yeah.
record and send me both.
Yeah.
Okay, that works. Nice. Then I don't need to do it. Okay, cool. Yeah, I can content farm as well.
But it's gonna show my face. Like it's gonna show the same from my angle as well.
It doesn't matter.
I'm gonna send this to you.
All right.
Yeah, change up your name and stuff. Like
Yeah.
Oh yeah, let's get this. I think this already been like 7.5 hours.
All right.
See, hold up.
Okay.
So I'm just quickly checking. Okay. Let me find 2 good questions. You can hear me, right?
Yeah, I can hear you.
Let me find 2 good questions. Alright, I'll start recording this. Alpha, you here?
Yep.
Okay, sounds good. Wait, let me start a recording. Hey everyone, so today I have my friend Alpha here again, and Alpha is in the top 5,000. Show this every time. Alpha is the top 5,000. He's done 1,400 plus questions. Has a crazy streak going. But let's just hop straight into the interview. I have him on Paul's manager. I have him on my coder pad right here. And yeah, let's get this first question in. So the first question, I'm going to ask 3 questions here. And the first one is I'm just going to get you to reverse a linked list. This has
nice, dude.
Messed up a bunch of people, and this has like ruined a lot of people's 6-figure dreams.
Yeah, I heard this used to be the Google question back in 2018, and then they stepped it up since.
There's been some inflation.
There's been, now you got sophomores solving hards, and it's just like, now you got to design React in like 30 minutes or something.
Yeah. All right. First question. Reverse this linked list.
All right. So I guess can we assume that we're given like a linked list? Like, can we just say we have like a list node class or something, right? Like the normal one. Like let's say we got this kind of thing where it has stuff. Yeah, I don't remember. Whatever. So val none or something 0 left. None right, none. kind of hard to type this stuff in. But this is fine. So can we just assume basically like that it's gonna be something like this, like all the normal stuff?
Yeah, we could assume we have a list node with a left and right child and a value.
Actually, I don't know why I have a left child. Next equals right like this. Okay, there we go. I don't know why we have a left and right child in a list node. Perfect.
Yeah, exactly.
All right, like this, right?
Yeah.
Okay. Yeah. So assuming we have that, so just go through this first example. Yeah, so basically what you need here real quickly is just you need to store whatever nodes you're at, next node somewhere, and then you need your current node to point to the one before, and then you need to move everything up. So what would happen here is like we'd have a previous node. Yeah, I don't know how to do it. I guess, can I use a drawing? That would be a lot easier.
Sure.
What do you want me to do? Okay.
Open up the drawing.
So let's say we have this some nodes essentially. Let me zoom out a lot. Okay. So I'm not even gonna put in values. I'm just gonna say we have like just some nodes like this, and then they're connected. Okay. So what we need is we need a previous node. So that will be like this color, let's say. We need a current node, and that's it. And so at every step, all we basically do is just make a next node, which is going to be the next of the current. So the current will start off being the head, and then we're going to make the current next point to the previous. So this arrow is going to turn around. And then we just move everything up. So this will go away, this will move here, this will move here. Actually, is that right? Yeah, I think so. Okay, then we just basically keep repeating this. So we make another next node, we flip this to go here, and then we do the same thing. So we move both of these up.
What's orange and green and red?
Yeah, so let me write it. Green, previous node, whatever this pink, current node, and the brown next node. Okay, so I can kind of demonstrate it in this next part.
I see.
Yeah, so let's say these are here. I'll kind of go step by step, I guess. So first we make the next node equal to the next node of the current node, which is going to go over here. Then we make our current node point to the previous node. So I'll go over here.
You can draw too with 7.
I can draw what, sorry?
Or with 7 you can draw. That helps.
Oh yeah, I see. Okay, yeah, I guess that works. And then basically I just move them up. So I say current node equals the next node. Or actually it would be the other way. It would be previous node equals current node, and then current node equals over here. And then this gets removed. So we keep doing this, and then we have one more of those. So we'll set this equal here. I guess if we do 7, that will go this way.
Yeah.
And then we move them up again. So this will go up here, and this will go up here. Okay. And then we do that one more time. So, yeah, I think this is the last one. Okay, and then we say this points to this. And then we move them up again. So this will go here, this will go here. And then when our current node is out of bounds, the previous will point to the head of the new linked list, so we just return the previous.
Okay.
So I think actually the drawing in the pseudocode is like more than what's the code. I think the code's like 4 lines.
Okay. Go ahead and implement.
All right, let me close this drawing. Okay, cool. So go def reverse list, and we'll just say it takes a head. All right, so we can just say previous equals none, and current equals the head. Say while the current is good. So you can do this all in like one line, but I'll just make it simpler. So we'll just say like next node equals cur next equals previous, previous equals cur equals cur equals next node. All right, and then yeah, I believe that's it, and then we just return previous here.
Okay.
And that should basically be it.
Can you dry run me on like a very small example with the code?
Sure. So yeah, so here, previous will be none. Cur will be 1. Okay, so we're going to say next node is going to be 2. So then we're going to say current, or yeah, current points to previous. So previous is none, so current is actually
Shabbat,
gonna
real
point
one.
this
I
way.
appreciate you.
Then we're going to say previous equals cur. So previous will be 1, and then cur will be 2. And yeah, so then we do it again. So next node is cur next, which is 3. Cur point to previous, so it'll go this way. Yeah, and then previous equals cur, so that'll be 2. This will be 3. And then one last one, so next node here is null. Yeah, and then cur next is previous over here. And then previous equals cur, so 3, and then this is none. So now previous will be 3, and then we just return 3, and that'll be the reverse list.
Can you do this recursively?
Yeah. So I guess let's think about how we could do it recursively. Let's go back. Normally this is one of the ones that I would basically never do recursively because it doesn't really seem optimal, I guess, but let's see if we did.
Why wouldn't it be?
Because recursion takes up space, so it takes up space on the stack. So like if this list is 100 items, we're just gonna have like unnecessary stack space. Where with this solution, we just have like one extra variable.
I see.
So normally, if you could do iterative zero space, then you just wouldn't do recursive.
Yeah. Makes sense.
But yeah.
What's
Okay,
the time and space complexity of your last solution?
Yeah. So this is time linear because we have to go through all the nodes, and space will be O of 1 because we just have that extra variable. But recursive would be O of n space if we did recursive. Yeah, so I guess let me think about how I would do recursive. So I guess ideally we'd want to like pass in some shorter version of a list every time, I guess. So basically we would say like, okay, so we have this list.
Yeah.
So maybe we can like reverse this list and then get the end of that list and then have that list point to this node, and that would be the answer or something like that. Thinking something like that. Let's see. Yeah, so we basically have to break it up in some way that makes it work like that. So yeah, I guess if we can return a bunch of things in Python. So I guess for a recursive call, we can return like the last node in the list and then the first node in the list or something like that. So what we can do is we can say like, okay, while we have a node, let's just take this node, let's reverse the other list, let's return the head and the tail of that list, and then let's just add this node to the tail. So it would look something like that. And then finally at the end we would return the head and tail like here, and then the answer would just be the tail value, or sorry, the head value here. So something like that.
Okay.
Does that kind of make sense?
Yeah, go ahead and code it up.
Alright, so we can say like, if not head, then we have an empty list, so the tail and the head will be none, so we can return like none and none. And let's just say we're going to be returning here like head, comma, tail or something. Okay. And if we wanted this thing to return like only one value, we can just basically write a helper in here, call the helper, and then that would return, like we can get the one value, but I'm just going to have this thing return both. Okay, so this is the case. Otherwise, we basically need to take our list, separate it from the next one, and then, yeah, so we need to say like cur equals head, and then we need to say like the rest of the list is going to be, so I guess we can say like next node equals cur next. Yeah. And I'm trying to think, what if this is like the last node in the list? What would we return? Yeah, I guess if this node doesn't have like a next node, we can just return that node twice again. So we can say if not head.next, return. So the head will be the node, and then the tail will also be the node. Okay. So now we can basically say cur's head, this is next, and then we could say like head or like new head or something. New tail equals reverse list reverse list of next node, but we also want to unknown. None is not iterable. Yeah, okay, so hold on. So next node is current next. So we have to actually break it as well. So we have to say current next equals none. Yeah, I'm not sure what this problem is. I don't know if you're like familiar with it. It says it's returning. I guess I'm
Where?
returning tuple unknown. Oh, it's probably because I'm just not returning anything here or something like that. Yeah. So head unknown. Okay. Anyway, so
But don't
yeah, so
feel, yeah,
basically,
don't have to run it. Maybe I'll just run it in leak code.
okay, yeah,
case.
whatever. So then what we have to do is we have to say new tail dot next equals cur, and we just return the new head here. So it'd be something like this, and then this would need to be a helper function in the actual reverse list function, because or actually, let me think. We need to actually no, we need to return both. Yeah, so we need to return both. So it'd be like return new head, and then I guess new tail would be cur, something like that. And then you would need to call this in the actual like. So this is gonna return the new head and the new tail. So you're just gonna want like the first value there. So I actually don't think it'll run just like this in leak code.
Okay. How would it run?
Yeah.
How would you make it run?
Okay, so if we want it to run in the actual leak code, we can make.
I want to test your code.
Okay, yeah. So we can have like a helper, def helper. It'll take a head. Then we could do all this in the helper. Okay. And so we will say, so we could say like new head, new tail, equals reverse list head, and then we return the new head. Now I do want to see why this is failing. Do you have it like highlighted or something, or what's going on here?
See, I'm gonna run your code. Okay, nice. Yeah, your code works in GitHub. So we're gonna move to, or sorry, in leak code.
Okay.
So we're gonna move on to the next.
I think it actually needs to be like this. So, but yeah. Okay. Okay. Yeah, let's move on.
We're gonna move on to question 2. Good job on that. Doing it iteratively and recursively. Recursively is actually not that trivial compared to the...
Yeah, I will say for a lot of these, one solution is easier and better. And so like if one, like for example, for binary search, I know you can do binary search recursively, but it seems really silly for me to do that. So when I read it, like it's actually hard for me to understand because I would never do it like that.
Mm-hmm.
So this is the same kind of thing, I guess.
That makes sense. Okay. Moving on to the second question.
Mm-hmm.
So pretty much we're going to be given an array of positive integers where each integer describes the weight of that index, right?
Okay, yeah.
Then we need to implement a method that randomly picks an element in that array, and we want to pick that element based, like the probability has to be based on the weight inside of that array essentially. So I mean, it's better example. Pretend I do 1 5 1 4 5 here, right? So since the total weight of the array is like 10, right? The first element should be picked 1 out of 10 times if we ran this 10 times on average.
I see, yeah. Like
probability 1 to 10 that we choose this 0, 4 out of 10, and then 5 out of 10 for the second or third or second index, third element.
Yeah, I think I get it. Yeah. So in this case, yeah, 1 out of 10, 4 out of 10, 5 out of 10. Yeah, gotcha.
Yeah.
So when we so this pick index gives an. Okay, so what is it? Can you write like what the function signature here looks like?
Pardon?
we're yeah, for this pick index, we're is this a class or something? I guess we have like a class and a pick
What are you
index?
thinking? What are you thinking? I mean, we should probably initialize. We probably have like some constructor. Or
right, I'm thinking class.
Yeah. You lead it. Like, what do you think? It's how? Like, what makes sense here?
So we're gonna have a class. It'll have some constructor. We save the array. And then we'll have a pick index method that will take in nothing and just return. So does it return an index or the number?
Index.
Okay, so return random index based on weight. So I think this is what I'm thinking. We want something like this. Okay. And so, yes, I think the way to do this is going to be, so we can basically just say like let's say here, yeah, so we can generate a random number. I'm trying to think. Like, yeah, okay. So we want to generate a random number with like random randint or whatever. I can look that up. In the range of, I guess, like, what would this be? So this is, so like in this case, we can basically say like for this array, if we pick a 1, we'll get this. If we pick 2, 3, 4, 5, we'll get this. And then if we get the top 5, we'll get this. So I think we want in the range of 1 to sum of array. And then we can basically figure out like what does that number correspond to. And so the brute force, I guess, would be, like, let's say we pick 7. We can just keep going up this array and add up numbers until we get the range we want. So if we get 7, we'll say like, okay, so our sum here is 1, so we didn't get the 7 yet. Now our sum is 5, we still didn't get the 7. Now our sum is 10, so we got the 7 while adding this number. So we return this. And if we get like 2, for example, it wouldn't be this, but then when we add this, we'll get 5. So does that kind of make sense? Like we just go down our array, add up numbers until we get to the one we got, and then that's the index we return.
Okay. What's the time and space complexity of that solution?
Right, so that is going to be, so this pick index specifically, the constructor will save the array, so that's O in space, but the pick index, that would be linear time, and space would be O1. But I think we can do better. Yeah, and the way we can do better is we can, so here we basically have to like manually scan.
Yep.
But instead we can do like a sums, so like a prefix sums. So we can say like, instead of storing that array this way, we'll store prefix sums. And it'll look like this. So just basic prefix sums where it's just like the sum of the array up until that point. And now, in this format, we can binary search for our solution. So we're going to look for the first number that is greater than or equal to our random number. And now this is just a binary search.
Mm-hmm.
Because this is going to be increased in order, all that. So like here, if we pick 7, we'll just look for the first number that's bigger. It'll be 10. We just return that index. If we pick 4, it's going to be this guy, and so on. And assuming we only pick from 1 to the sum, like the last number will be the sum, the first number will be whatever, we're always going to like hit something here. So I think that's going to be the way to go, is we do prefix sums, and then we just binary search through our prefix sums and just generate a random number from 1 through the total. Does that make sense?
Yep. Makes sense. Go ahead and code that up.
All right. So we'll have a, honestly don't remember how to make the class. I feel like it's like, do you do class in Python? I don't remember. Okay, so I guess class, let's see, what would we call this? Like random number or something? I think it's like this, right?
Yeah.
All right, so we're going to take in some array, and we're going to say, so what we want to do is for this array, we want to generate prefix sums, and we want to get a total. Can we assume the array will have numbers, and they'll all be like positive, I guess? It wouldn't really make much sense otherwise.
Yep.
Okay. So we can just say like this, and then for self prefix sums 0. All right, and then we'll just go for, I mean, there's a bunch of ways to write this, but it's fine. Okay, so for this, self prefix sums I equals total, and then we just do that. All right, so now we have our prefix sums, and then we're gonna do the random number. So index self. Yeah, I don't remember the syntax for the random number, so we'll just say like r equals rand. I think it's like a random.randint or something.
Yeah, import random randint. And it's like inclusive
random,
like 0, and that will give you like 0 and 10.
Randint, right?
Yeah.
So we want to, let's see, in the range including both endpoints. Okay, so we want to go like this to self prefix sums. This is going to be our last one. So I think this is right now. Okay, so we have this random number. Now we are going to, yeah, basically just run a binary search. So 0 length prefix sums. All right. And we're gonna store. So yeah, I guess this is like personal preference for how you do binary search. Let's say, so we want. I guess what do we want here? We want the smallest number that's bigger than. I mean, we're always gonna get that, but I'm trying to think like what would store it. Honestly, I'm pretty sure we can just do this, and it would still work. Okay. So we can say this. Okay, pivot value, and then yeah, you can do that. This guy instead, but you can just do this in Python because you don't get overflow. This is what I'm used to doing. It's another language you can worry about it. So we can basically say like if prefix sums of the pivot is greater than or equal to our random number, then this is a possible result. So we'll store that index. And then we want to check numbers that are smaller, so we'll go with this. Otherwise, we can go the other way, where, yeah, honestly, I think you can store this as like, I don't think it matters. Yeah, I guess we want the small, so we'll just go like, okay. So, yeah, so if we want the other way, if this is too small, then we'll go this way. And we just return, the result should be the index. Okay, I feel like that's it. We can like do a dry run if you
give
want.
me a dry run on 1.5 and like the
that guy.
Yeah, this guy right here.
All right. So our prefix sums here will be, so we're essentially just keep adding the number, and then yeah. So this will just be like 1, 5, 10. So let's say we go to pick index and we pick like 6. So pick index and we get the random number 6. So here, left and right will be 0 and 2. So the first pivot value we're going to pick is 1. And then, oh yeah, and the result will be 2. So the first pivot value we're going to pick is 1. And we're going to check what's the value compared to the right. So here it is smaller. So because it is smaller, we're going to move our left to pivot plus 1. So left will be 2. And then we're going to get another pivot value. So now it's 2 and 2. So pivot will be 2. And we're going to get this 10. And now this 10 is bigger. So we're going to hit this case. And we're going to set the result equal to that. So 2. And then we're going to say right is pivot minus 1. So pivot will be 1. And now this will no longer be true. So we're going to break out of here. So we're going to return 2 because that's going to be this value here. Yeah, that's correct.
Okay. Let me put this in leak code. Okay. I think what you said makes sense. Yeah, damn, you destroyed this interview. 26 minutes, 2 questions already. I gave you an easy one for the last one, so I need to give you one more question.
Yeah, that's fine. Yeah, just don't give me some 80 lines of code one.
Let's see. Chat, what are you thinking? Oh, I got it.
And it is kind of crazy also, I will point out, if you're used to doing something in one way, and then people ask you to do something even basic in like another way, it takes so long, like it's crazy. Because you're like, I use this template for like all my problems, now I'm going to try this thing, and it definitely is a lot slower.
Yeah. People are trying to make me ramp it up, but you already did. It's already late for you. I'm gonna ask you this question.
Alright. Okay, so given an array of strings, names of size n, create n folders such that the ith minute you'll create a folder. So names I. Since two files cannot, if you enter a folder that was previously used, system will have a suffix. Oh, I see. Oh, okay. You create folders in your file system such that the ith minute. Okay. So they can't have the same name. The system will have suffix. Okay. Return an array of strings length n where answers I is the actual name system will assign. Alright, so I guess let's look at this example. So PS, okay, and they just go like in order. Yeah, so you'll make one every minute or something. Okay. So PS is not taken, FIFA is not taken, GTA is not taken, the other one's not taken, so you just write them as is. Okay. I see, so this one is taken. Okay. And then One Piece, something. One Piece 1, One Piece 2, One Piece 3. So this should be One Piece 4. Okay. Yes, I feel like this is like the tricky, like this is basically the whole problem of like how to deal with this case with the same folder names. Like if it's not, it's all super easy. Like if they were all different names, you're just done.
Okay.
So the tricky thing here is like how do I store
keep
these?
explaining. I'm grabbing my food quick. Just keep explaining it like you would explain it in like a video or something.
Yeah, I'd have to think about it, but yeah. So the tricky thing is here, I guess, like how do you store these in some data structure where you can quickly check like what's the next available one? One Piece. Wonder if, yeah, this is the only, and yeah, I guess like if there's One Piece 2 or something, then you would do, yeah, so no matter what, you can't escape the problem of turful, so some previously used. Yeah, you can never avoid this issue either, which is kind of annoying. Like if you get, let's see, One Piece 2, One Piece 3, One Piece 3, One Piece 2. Yeah, so if we get like One Piece 1, then we have to get like One Piece 1 or something, I think. Is that right? Let's see. Previously used. Yeah, no, it is. Yeah, okay. Returns unique. GTA 1, GTA. Okay, now, okay, I see. So where to get it, maybe? So for One Piece, what would it be? For One Piece, we'd store like the first available index is 1, I guess. And we already have One Piece in here.
This guy's
And so we
interviewing
basically have
himself
to break
now.
off the end and then see what we have. So this is like One Piece with a 1. Maybe not though. Yeah. Okay, you back?
Yeah, I'm back. Which part were you thinking?
Yeah, I was thinking this kind of does get confusing because I was gonna say like maybe we can change this to like One Piece 0 or something and change it back. But if we have this case, then this would need to turn into like One Piece 1 or something, right?
Exactly.
Which is like the tricky part. So we can't just like manually put in a 0 and then like have a hacky fix to
This
that.
would be like this. 1. Good job catching that case.
Right. And that's what makes it kind of difficult. Yeah, so if this was One Piece 1, this would be like One Piece 1, then this would stay One Piece 3, and then this would actually be One Piece 2. Okay. So I do think we do need to store some way, like some kind of hash map where we have a like the string name and then like the smallest possible number. And if we haven't seen it, we can just do nothing. But if we have seen it, then we can like add on stuff to it, something like that. So maybe let's kind of walk through with this. Like this is kind of like the tricky one. So let's say we just have a hash map. And so let's say like one piece we've never seen before. So one piece we can just write out as is, and maybe we'll store it in here. So yeah, like one piece we haven't seen before. So we can store this as like one piece. And now the first available number for it will be like a 1. So if we see it again, we're going to put in a 1. Now we get to this one piece 1, and we haven't seen it either. But we have to somehow mark that for one piece it's not available. Because like you can't do that. So that's the tricky part. So maybe for like a number, if it's available, yeah. If it's available, then we have to somehow figure out how to mark that like it's not available for the one before. And I guess if it's available, then yeah, okay. So I'm thinking if it's available, then the one before has to be that number. Because like let's say for this one piece, if the smallest available one is like 5 and we're on here, then we definitely can't do it. So I think if it's available, we can just mark the one before to do this. And then, so we'll write one piece 1. Now we get to one piece 1, and then we check, is that available? And the way we're going to do that is we're going to remove the number, or actually, are we going to remove the number, or we're just going to check the number? So we're going to check, no, I think what we're going to do is we're going to check for one piece, is 1 available? And for this, it says the smallest available is 2. So then we'd say this wouldn't be available. And because it's not available, we're going to add a 1. So we're going to say actually one piece 1. Now the smallest number available is 1 here. Actually, so when we're adding a number, is the smallest number we're adding 1 or 0?
1 or 0?
Again. Yeah, we're adding 1, right?
Yeah, we're adding 1.
Okay, is the smallest positive? Okay.
Yeah.
Okay, so yeah, so we're gonna add a 1. And then we're going to say that the smallest positive available here is 2. Yeah. And then one piece 3. So we're going to check. Okay, we have a 3. What's the smallest available? Yeah, it also might be tricky if you have like one piece 3, but then you have like more one pieces or something. So if you had this case, if you had like one piece 3, how do we even do that? I'm not sure.
Yeah.
And then we had like more one piece here, like one piece or something.
Mm-hmm.
I wonder if we could just like do some sort, and then that would kind of take care of all our problems. No, we can't because we have to maintain the original order. So that
exactly.
Yeah. Yeah, I feel like it's kind of tricky. Yeah. So for like one piece 3, we could say that this is actually not available. Okay, maybe when we try to add the. Okay. Okay. Yeah, maybe we can kind of go the other way. Maybe we can try to add the number we're at, like whatever number we're at, and then just check like have we used this already. Maybe that's the better way to go about it. So let me see if I can figure that out. So if we go back here, we can basically say like, okay, well, we have one piece. So is just one piece straight up available? Yes. Okay, so we'll write it in. And then we're going to say, okay, so for one piece, the next available number is 1. Then for one piece 1, we're going to say, okay, is one piece 1 available? Like, have we added that in? And what we can do is we can just have a set of everything we've already used. So this will be like in a set. So we could say like one piece 1, is this available? Yes. So then for one piece 1, the next number we have to add in is 1. And then for the next one piece 1, we're going to say, is this available? And it's already like in our set, so it's not. So we can basically probably just increase this to the next one, and then check is that available, and we keep doing that. And then that won't be like that bad runtime. because worst case, yeah, I think that runtime will be fine. So I think something like that seems like the way to go. So we're gonna have a set of all the things we've already used, and then we're also gonna have a hash map of like all our numbers and what's the next available number, and we're just gonna manually like increase the number and keep checking have we used that, have we used that. I think that's the way to do it. Does that make sense?
Makes sense. Go ahead and implement. We have about 7 minutes left.
Okay. Okay, so what's this thing called? Let's see. Okay, we'll call it like folders or something. All right. Okay, so we're gonna have like a visited, and we're gonna have a yeah, basically a like, what's another one? Counts or something, whatever. Okay. Import default dict. Okay, something like this. Okay, so we're gonna say we're gonna have a result array as well. So for string in R. Okay, so first we're gonna check if it's not in counts, we can just add it in right away. Or if it's not in visited, we can add it in right away as is. So if string not in visited, then we're gonna add it. And we're gonna say the next available number, string +1. And we're gonna add it to the result. And we'll just like continue or something here. Okay, so if we have seen it already, then we have to figure out like what's the next available thing. And to check that, we're basically gonna take what's yeah, and I guess I didn't ask, but I can assume like these strings are pretty short, so even though we're like making new strings, it's not gonna be that bad.
Sure.
Okay, so yeah, so I guess here we'll say like while, or we basically have to take the count of the, we have to take the count, so we have to take counts equals counts of the string, and we have to basically keep trying to see if this is available. So while string plus, I guess we have to make a string here, right? So while, yeah, so I guess we'll make the string. So we'll say like new string equals string plus whatever plus what was the other thing? The count. Yeah, you can definitely do this cleaner, but okay. So while new string in visited count plus equals 1, and then we like rebuild the string. And when we finally figure out like, okay, this is the one we're using, this is the one we're going to put into the result. So we're going to say visited, add new string. And then we're also going to say that this is the count we used. So we probably need like the next one. So we'll say like counts string equals, this is the one we use. So it'll be like count plus 1 or something. Yeah, I feel like that's it. Could be wrong, but I feel like, yeah, this looks pretty good. Maybe we can go through your example. Definitely not as confident. This one maybe it's a edge case, maybe it's too slow. But yeah, I feel like this is okay.
Try running it.
Definitely a lot harder when you can't just run it and leak codes.
Try do a dry run.
Okay. So let's go through this example 3. Okay, so we're gonna hit one piece. So one piece is not in visited, so we're gonna say visited is here. Counts is an empty hash map. Result equals an array. Okay, so yeah, so one piece is not in here, so we can just add it directly. Yeah, and then the count here will be 1, and we'll add it to visited. So one piece. Okay, now we're gonna get to one piece 1, and we're gonna check is one piece 1 in visited? No. So we're gonna add one piece 1 to visited. We're gonna say the counts of one piece 1 is 1, and yeah, and then we're gonna add one piece 1. Okay. then we're gonna say we have one piece one again. So this isn't visited, so we're gonna go through the next thing. So we're gonna say, okay, well, one piece one is in here. So the next string we can make is one piece one like this. One piece one one. We're gonna check, is it in visited? It's not. So this is the one we're gonna put in. We're gonna add it to visited. And we're gonna say this now has a count of 1. Okay, now we get to one piece 3. So is one piece 3 visited? No, so we can just add one piece 3 directly. 3. Okay, and then this will go in here and in here. All right, and then one piece 2 is also not in here, so we're going to add one piece 2 at the end. So one piece 2 will go here. This will have a count of 1. And then we'll add it to visited. Yeah, so something like this. Like I said, this might be too slow. I think it will always work, but my concern is it might be too slow and I might have missed an edge case.
Okay.
Yeah.
So okay, walk me through line by line again. You don't have to dry run it, but I just want to verify.
Okay, yeah. So, of the code?
Yeah.
You mean?
Yeah.
Yeah, okay. So we're gonna have a visited set, which is just like everything we have in our result. And then we're gonna have counts of like counts will tell us like the next available number we can use. And then we're gonna have a result. So for every string, if it's not in visited, we can put it in as is, because like if it's not in, if we haven't put it in already, we can just put it in as is. And we're gonna say the count of this string is 1. Honestly, we can probably use visited. Yeah, I feel like we can get like to clean this up, we can probably get rid of visited, but let's just keep it for now. Because counts and visited are basically doing the same thing. So we're gonna say, the count of the string is 1. We're gonna add it to our result as is, and then we're done. So the other case is if the string is in there, then we're going to say, okay, what's the next number we need to add? And we're going to start with 1.
So is this an else statement then? Like
No, because we continue. So it kind of is an else, but I just put a continue. So it'll do this and then continue if it's this case.
Okay.
Like it would be the same as writing else and then like all of this would be an else block.
Oh, I see.
Yeah, so if it's already visited, then we're going to check like what's the next available thing. We're going to build up the new string. And we're gonna check, is it in visited already? Like, can we put this in? And if we can't, then we're gonna try the next one. And so we basically keep increasing the count from what we had until we get a new one that's viable.
Yeah.
Yeah. And then we're gonna store like that. So whatever we put in, then we'll put in like the next count.
I see.
Definitely, like I said, definitely easy to make mistakes on. Without running in leak code, so I wouldn't be surprised if I made some, but yeah.
Yeah, there's like there's a small issue. I think like for us this case right here, it breaks on this case right here. I ran in leak code for you.
Oh, okay.
You're outputting this. This is your output. And the expected is like you're missing a value.
I'm only outputting 3.
Exactly.
Oh yeah, okay. So you're right. So I need to actually add this to the result, right? So it will be like, I did miss that.
I see.
If that's the case. So that's so try that. I was thinking I'd miss something bigger. Hopefully it's just that.
It's running.
Might get TLE or something.
Honestly, this was my solution too. I don't know. I couldn't think of anything faster.
Mm-hmm.
It gave a wrong answer on this one. I'll show you. This is the input.
Mm-hmm.
This is your output. And this is the expected. Like you just jumped to 3 essentially.
Okay, so let's figure this out then, I guess. Okay, so output. Okay, so this makes sense. This makes sense. That makes sense. Kaido 1-1. So yeah, that makes sense. So it jumped here to 3.
Oh, I see. I see. I see.
Okay, I see. So it wants to do Kaido 2-1, but it did Kaido 2-3. Interesting. So what would be
Yeah.
in this case? So in this case, it would just look like yeah, I guess let's walk through the code. So these would all be in here, and then Kaido I think would be on, yeah. Let's see. Yeah, it definitely is hard without like logging stuff at all. So and for what it's worth, I think for like these types of problems, if you're not allowed to run anything, and you do have like some small cases, I think it's like expected because it's kind of hard to get it like perfect off the bat. But yeah, let's take a look. Okay, so I guess we can dry run through this one. So Kaido wouldn't be in here, so let's have the same thing. So we'll have the visited, the counts, and the result. Okay. So in the beginning, Kaido wouldn't be in here, so we're just gonna put that. Counts will be Kaido with a 1. Result will be that. Okay, Kaido 1, not in visited, so we're gonna put that in just as is. This will be 1. This will be this. Okay. So then the regular Kaido. So we're gonna say, is 1 available? No, it's not. So then we're gonna try 2. Is 2 available? And it should be. So we're gonna put in 2. And now we should, let's see, count string append. See how I did this? Count plus 1. Yeah, okay. So count, yeah. So then I think in here this should store 2 now. Actually, should it store 2 or should it store 3? No, yeah, it should store 3. Oh, actually, no, this is wrong. So this will be 2. This will be 3. Yeah, because it'll, okay, so it'll be like this. Then it'll put this in here. And it will be visited. Okay, so now we go to Kaido 1. So Kaido 1, the first available number, it says it's 2. So what we're going to put in is Kaido 1, 2. And, or actually no, Kaido 1, actually I think this stays like this. Yeah, this stays like this because we never added another one. Okay, so Kaido 1 would have this, and we check is this available, Kaido 1, 1, and it is. So now this will be 2. Yeah. And we're going to put in Kaido 1, 1.
Connor, I don't watch
And we're
him
gonna
too
store
much,
that in
but for,
visited.
like most of the time, I just see the candidates like getting
And then
roasted kind of
this
thing.
will
I
be
never
1.
seen the
Okay, so now we're
actual
gonna check
advice question.
Kaido 2, 3. Or Kaido 2, 1 actually. Or sorry, Kaido 1, 1. Okay, so Kaido 1, 1. Actually, sorry, no, we're gonna check this one. We're gonna check Kaido 2. So Kaido 2 is in here. Yeah, it is. So, or this, actually, this should be like this: Kaido 1, Kaido 2. This was Kaido 2, right? Okay, so this was Kaido 2. And then yeah, like, well, actually, once we stored this, then what would happen? Let's see. Count string, count plus 1, res append, visited. Count string, count plus 1. Oh, okay, I think I see the problem. I think if it's a new string, we don't want to do counts plus 1. Yeah, I think the problem is right here. So if it's a new string, we don't want to do counts plus 1. We want to make sure, like if it's completely new, we just want to do 1 here. And I think that's the problem. So for this should actually be 1. And yeah, okay, so that's the problem. So how do I fix this? So what I can check is, actually, so this should be basically counts new string, I think should just be 1 in that case. And that's what I need to fix. So this is, or it could actually be, let me think. So if I have this 1, 1. Yeah, I mean, I want to say it's just like this.
Sorry, I meant to. I think overall the solution makes sense.
Yeah, and then I
Yeah.
think I need one more thing here. So I think I need to say count plus equals 1, and I need to add it. I need to do count string plus equals 1. Yeah, something like that. I think I'm missing like literally like one line of code, and then it'll fix it. Yeah, I think this might work. I'm not sure.
I see. Okay, let's try.
Okay.
Yeah, this one's a
And then,
bit
yeah,
tricky.
If it doesn't work, then I was just gonna give up. Yeah.
Yeah.
Yeah, I mean, if I could like debug in console log and stuff, then I'd find it. But it's kind of hard to just do it all off of like the code, I guess.
Yeah. Let's see. Yeah, how do you think you did on this time around?
Yeah, so definitely the recursive one I don't know super well, but I would be kind of
Nice. Okay, your
shocked if I
solution
could
worked.
answer.
Yeah.
Okay, yeah, I would say like without actually logging, it's super hard to figure out what's going on. So yeah, I'd say the recursive one I could have done a little bit better, but not too bad. I do know I'd be slow with it, but I also feel like it's more complicated.
Yeah.
But overall, fine, I think. This one I was pretty happy with. I can get it pretty quickly. And then yeah, this third one, honestly, I feel like I don't know, like maybe I'm just bad at some problems or something. Yeah, I feel like it wasn't super obvious, and the thing that tripped me up was like I wasn't super sure if it would be too slow, because it seems kind of like a brute force where you're literally just trying numbers.
Yeah.
But then thinking about it, like it's actually not that bad, because worst case scenario, you're not going through that many numbers. So definitely could be improved on this one, but I feel like
Yeah.
if I had to like rate per problem, I mean the first one I guess probably never get asked, so don't count. So I think for this one I'd probably get like a strong higher for the pick index.
Yeah.
And then for the second one, like I said, I feel like if you don't get to run the code, you're not expected to get it like all perfect with no mistakes. So I'd probably say like lean higher for that one or something like that.
Yeah. No, I think
Pretty
yeah, I
much,
think
yes.
you did good. My favorite part is that you could interview yourself. So I could step away and you're literally starting to
Yeah.
So people in the chat were saying they could, what did this guy say? Something funny.
Yeah, I think that's usually feedback I got from interviewing, because I make so many videos and talk a lot. People are like, "Oh yeah, your communications are really good. You,
Yeah.
you never really like not talk."
Yeah,
So.
someone's like Alpha is both the interviewer and interviewee, because as soon as
Yeah.
I did, I was like, Alpha, just run it yourself. I need to eat. And you just asking yourself questions and then answering it, and then because that's how you do when you're doing a YouTube video, right? You're asking yourself some questions, then you answer it.
Yeah, pretty much. Yeah, it's like a mock interview with myself.
Yeah, and you always you mock interview yourself like crazy, even with the other stuff.
Yeah.
Can
No,
you?
I mean definitely the system design stuff. I gotta get a lot more
Yeah.
feedback because I don't know it as well. But this stuff, yeah.
Can you ask him if it would be great practice to make those videos of blind 75? I tried to make a video for 2 and did okay. What do you think about making videos? Does that help you get better?
Yeah. So I think making videos is really good because, so like, let's say you can't do a problem. You can look up the solution, you can code it yourself, and then the next step is like, can I actually explain it to someone else? And if you can explain it to someone else, then that's really good. And then also what you can do for all the problems that people really don't do is you can just just start writing down time and space complexity for every problem you do, and then like that will give you like 200 problems of practice, and then you'll be really good at that.
I see.
Yeah, like basically.
Okay. Thanks, Alpha. We'll
Yep.
do some more system design. Let's shoot another system design video maybe next week or actually
Yeah,
the week
next
after
week's
because I'm
good.
in Chicago.
Yeah, it's totally fine. Okay,
Okay.
cool. Catch you
Sounds
later.
good. Catch you. How long has the stream been now? How long has this stream been? Chat. Almost 9 hours? Okay, we got one more interview in. Pablo, you're in the chat, right? Holy crap. That's it? Okay. No, you don't have to send me your leak code account. How many questions have you done, Pablo? Or we'll talk about it in your. You DM me. DM me. Okay, I'm gonna get you. Pablo, did you get the invite? Pablo, did you get the invite? Wait, hold on. Give me a sec. Give me a sec.
Test.
Yo, Pablo, what's good?
Test. Can you hear me?
Yeah, I can hear you. What's up?
Nothing. What's up? Do I sound good on your stream, or I don't know?
Yes, sir.
I don't know
You
if
look
my
good. You
mic
look
is
good.
like good quality.
You sound good.
Okay, good. All right.
Okay.
Are you ready to begin?
Yeah, let me set up the coder pad. Then I'm gonna ask you just basic stuff like your school, if you don't mind sharing. Also, how many leak code questions you've done, what companies you're targeting, and stuff like that.
Okay, yeah, sure. I can answer you those
Yeah.
questions.
I'm just gonna quickly send you a coder pad.
All right.
Yeah, and like hop off the stream. It might feedback, and also don't get distracted by the chat. Gotta take this serious.
All right. All right. Oh wait, I might need to. Oh, can you do a C++?
Yeah,
Or
we
language?
can do C++. Find you some good questions.
Do you ask me the questions like school and stuff after or before?
Before, it's like an introduction kind of stuff.
Okay, sounds good.
This is like regular type. All right, one sec. Let me take a quick break. Just go on mute for a sec. Let me take like 5 minute break.
All right, sounds good.
Yeah. Or 2 minutes. 2 minutes. I just need to brush my teeth real quick. I was just eating. A sec. Wait, you have access to the coder pad? Did I send you the link? You in? Okay. So.
I do, but it's in Python.
Okay. Yeah, we can switch. C++?
Yeah.
Sick.
I know Python a bit. It was the first language I learned on, but yeah, basically since like around September or August, it's all I've been using.
I see. Okay.
And most of my projects are in C++.
Okay, let me brush my teeth quick. I'll be right back in like 30 seconds. We can run this.
Yeah, take your time.
Like, I'll give you a quick warm up and just code it up while, just to warm you up. How good are you at how many LeetCode questions have you solved?
Like around 200 something.
Okay, I'm gonna ask you like a classic one. And just code it up to entertain the chat. Just explain your thought process and stuff. You know this question?
Oh. Yeah, I know this one.
Okay, yeah, code it up, warm it up real quick.
Okay, so let me just organize my thoughts.
Damn, where you at?
So, I'm in Iowa.
Oh, nice.
Yeah. Okay, so basically for this problem, what you have to do is you have to make sure, like, so all of these like connected ones, are land, and then the zeros is water, and basically we have to return the number of islands. And so in order to do that, so in this case where the output is just one, I think it's like this. Yeah, okay. You basically have to check like all four directions, like the left, the right, the up and the down, and then you have to make sure that there is no like water, or no land, basically. So how you do this is you have to model it as like a graph, basically. And you have to also, I think another important part too is like, yeah, write it like this. So you also cannot be in any of these like borders too. So I don't know how to explain it actually, the island part. An island is surrounded by water. Is the form. Oh yeah, so okay, so like if there was two ones right here, I believe, then it would be like two islands, because these are all just a bunch of connected ones that are bordering water, and then these would be the other like connecting ones. So because these are zeros, this is obviously not an island, and then this will return one because there's just one of these. So so you need like a function like this, and then I think the input is something like this. Yeah, I think this is just all you have in the problem. And what we have to make sure of. Like the main condition I think we care about is like is equal to a 1. And then if we know that, then we're basically chilling. So what you could do is you could do two traversal. You could do BFS or DFS. I don't know if there's any other way to do it. Maybe some special like union finder kind of way, but all I know is DFS and BFS for this one. And I think DFS is the best way to solve it, because I just think the code is a bit more elegant. But I think also too, because there's like another more graph reason. And I think it's like if you're checking like vertically, maybe like the connected points of the land. Like if you did BFS, like you would go here and then you would check everything. But I think like you could break out basically when like you could return nothing. So I think that's another thing we need. If we don't reach an island, or if we don't reach anything, we can just return. So I think it's another thing we need.
Okay, sounds good.
But
okay.
I'll try and write the DFS.
I mean, this all makes sense. Let's get into the actual questions that I want to ask you.
Oh, okay. Okay.
This is just a warm up, but yeah, just wanted to kind of get a sense of where you're at there. Okay, cool. Since this is gonna be a dedicated video, I'm gonna start it off by just asking the questions that I mentioned. So.
Okay. Yeah.
Cool. Hey everyone. So today I have my friend who is going to be doing a coding interview. So yeah, you want to quickly introduce yourself? You don't have to say your name. I guess just introduce like maybe what school you go to, what companies you're targeting, and maybe also like how many LeetCode questions you solve.
Okay, yeah. So I went to the University of Iowa.
Nice.
I started LeetCoding in around like September or August, and basically like after graduating, and I've got so far I've got an online assessment with Amazon, and I was not ready. I solved the first question, but the second I was not ready for. And then I had online like a code signal with Uber, and I had very easy online assessment with Google as well, and I passed it. And now I have the Onsite, but I've been pushing it back to prepare. So I'm just trying to get as much practice as I can before I do my Onsite with that. So that's basically the companies I'm targeting.
So which companies you have a Google interview coming up?
Yeah.
Nice. On-site? New grad?
Yeah, well, it's online, so it's like 3 technical rounds and then 1 behavioral round in one day. Yeah.
Okay, when is that?
I told my my recruiter recommended this to me. Like they said, if you're not confident and you're not prepared, instead of waiting for failing the interview and waiting for 1 year, just push it back, and then I'll message her when I'm like fully ready. So I had someone else who said I should solve like 500 before, and I solved like 280 maybe. Okay. Yeah, I solved like 280. So, but it's like when you're first starting out, like it's just so hard to even solve like the first 50 or first 100. Like I remember it was not even too long ago where I would struggle with like 2-sum or something like that. Yeah. So I'm like now I think I'm at the point where I'm really learning a lot from each problem, but it's still very, very hard.
Okay. I'll ask you Google Tag then. That's your target company.
Okay. I don't think they do tagged, but yeah.
I think that the tagged ones are pretty accurate, like the ones that are there.
Oh, okay.
Like people report what they get asked.
Yeah, I guess I guess like what they told me is that like they just have their own question bank and like
Yeah.
but I think what they do is they probably just take it from LeetCode and they change the words.
Yeah. There's like ones that are very close.
Yeah.
Okay. Let me figure out a couple ones. Um, okay. I'm gonna ask you. We're gonna ask two questions, and then pretty much by the end of it, yeah, two questions. We're gonna spend about 20 to 25 minutes each, probably like 20. Um, when we get near the end, we'll just move on to the next question if you're not there, and then I'll just give you feedback at the very end on like what I think, how I think you did. How does it sound?
Okay. Yeah.
Cool.
Okay, sounds good.
I'm gonna drop this. So we're pretty much gonna be given two arrays, nums1 and nums2 like this, right?
Yeah.
And then we need to return nums1. We need to basically merge the two arrays, and then, but we need to put it into nums1 eventually, and return it.
Okay.
So nums1 should eventually look like this. That's why we give it enough 0 padding, and then we return nums1.
Yeah. Okay, I see.
Does that make sense? And it should be in sorted order.
Yeah.
Okay, go ahead. You have 17 minutes.
Okay, so so like the input on LeetCode, what it looks like something like um, like merge array or something. Nums1. So something like this, right? Is what the input looks like on LeetCode, right?
Yeah.
Okay, so my first idea is so I can make some like array where I'll store my answer and so so first what I'll do, so is it always guaranteed that nums1 will be greater than nums2, right?
Yeah, exactly.
Yeah, so what I'll do is actually before I even do that, I'll say int n is the size of nums1. And then I'll make my answer basically that size.
Sure.
And then what I could do, I think, is like something like this. I think this will work. And then just return the answer. Does this work? Do you know? Like,
okay, can you walk me
try,
through? Walk me through, like do a dry run?
Yeah, so basically, in this test case, like I'll just do -1 or something. 1, 2, 3. So I'll have this basically. Wait. 1, 2, 2, 3, 5. Oh, and then I would have to sort it, I think, actually. So something like this.
Okay.
So
small example right here.
Yeah, so So first, basically, my answer will be like initialized to just nothing, like all placeholder. 1, 2. So we have this, and then we're gonna push back all the elements in nums1 first. So there's that, and then push back the elements in nums2, and then we could sort it.
Okay. What's your runtime complexity here?
I think it's oh yeah, so it's n log n, right, for sort, because I have to sort, and then it's on in space as well.
Okay.
For yeah, space on, and then and then I think that's it so far.
Okay. Can you? I think we want more efficient algorithm than this.
Yeah,
Prefer more
so
efficient algorithm.
yeah, so I'd have to try and think, but I think we could probably do an O of n with O of 1 space, actually. I think there's probably a way to do this in place. So you like a 2-pointer kind of solution. Well, or maybe even 3, because maybe we you, and then we could just keep basically swap, because the problem is with my previous solution is yes, well, I think if you focus first on fixing the runtime, the space will kind of naturally fix itself, because we won't need to be creating another vector to do all of this stuff. So I think there's probably a way, because yeah, like you mentioned that there will always be these zeros, right?
Yeah.
So I think we could use that to I think yeah. Well, I was trying to say like maybe we could like sort this in reverse, but that wouldn't really help us. But like I think maybe we could start from the back somehow and add this 6. So let me just see if I could even do this logically first. So yeah, like, it would be nice if I could add this 6 here from nums2. And I need to probably do some like comparison, like check if the really quick for I'll remove this code. Like what would be something useful is something like that. So I think I'll need these at some point. So I could check if so like yeah, I'm just trying to think like if there's some way I could put this 6 here, it would be very nice for me. And then I know that this end will always be a 0. So oh wait, nums. So n will be nums1 dot size, and then also I don't know, I'll just call this full second end, or maybe j. Maybe j will be fine. This will be the end of nums2. And so I think I can compare these, and then yeah, well, I do need to compare them for the code, but I think at the same time you know already, like, oh, this will go in, and then yeah, like if you iterate backwards, and then this will go here, and this will go here. But then, oh wait, this is a 2. But then the problem, I guess, is that this part isn't sorted. So I would have to find some way also. I guess I could just keep going backwards and swapping them until the array's sorted. So there's a lot of stuff I would need to do, I think. But
So, what if there's a bunch of zeros here? Or sorry, like ones.
And then this is zeros.
So, like, then we'll fill this up by 1, 1, 1. Then, like, how do we get this into sorted order? Or pretend this is like 5, 10. Then there's like 2, 6, 11. Or here, let me give you a better case. So how would you merge these two arrays?
Well, isn't this case basically the same? Because like I would just say I'd want to do this thing, right?
Okay. And then what do you do next?
But then, yeah, so this would be greater than this. So I'd want to swap it. I think the key maybe is just I'll need some pointers to like compare, and then I just need to keep swapping until everything from the right side gets to the left. I think that's the best way. Yeah.
Okay. So what happens here? Nums1 has those values. What are you gonna do? Can you explain that again?
Yeah. So this would be 0, 0, 0, right?
Okay.
So then I think I would compare. So this would be J. So and then 0, 1, 2. Yeah. Okay, so this would be J, and then this would be, oh wait, sorry, not 5, 0. So this would be 0. So I basically check if J is less than, or it's greater than N. And then if it is, then basically I could say, I think I could do this, something like this maybe. So then I would put 11 there, doing that. And then, oh yeah, I'm kind of stuck now. Is then, well, I guess I'd loop backwards of this one too. So then I'd say, check if J plus 1, because this would be, or J minus 1. So check nums1 if it's less greater than. So this one is not greater than N. Right, so then this would be a 0. Or wait, nums2 of 1. So it's greater. Oh, well, then I would need to loop back from this one too. So it would be N minus 1. Or N plus 1. Because I would, I guess, keep going like backwards on this. Or wait, no, it is -1 because this is 5, and then this is back 1. So I check this, and then I would say so yeah, this is 6. So this would be
Okay, I see.
yeah.
Okay,
So,
let's move on to the next question.
Okay.
Just so we can get through multiple questions. Let me.
Yeah, it's tricky to do this one in constant space.
Yeah, we would want constant space and
Yeah.
and O of n time. Okay, I'm gonna add something below. Or this is Q2.
Okay.
So what we want to do is we're gonna be given the root of a binary search tree, and then a target value. We need to return the value in the binary search tree that is closest to the target. If there are multiple answers, print the smallest one.
Given the root of binary search tree and a target value. Like, what do you mean closest to the target? So if like the target is like 7 or something,
Yeah.
and
okay. Go ahead.
yeah, like can you give an example maybe of it? Like I was gonna say, like say you have maybe I'll draw one. Yeah, so I'll need to get fast at this for Google Interview because they make you do stuff like this. Oh my god.
Okay. Is that a valid binary search tree?
No, not yet. I think this works. This works, right?
Is that a valid binary search tree?
I think so, yeah, because all the values of like the left children are like smaller than the values of the right.
Okay. Could you quickly just write out what the definition of a binary search tree is, and then let's like verify if this is a binary search tree. Just want to make sure we're on the same
Yeah.
have the same definitions.
Yeah, so I don't know how to hit. So yeah, I just basically say like the left children have to be smaller, the right children have to be greater. So like, greater, than the nodes and the and this I don't know how to explain it in the subtree. Like this has to be smaller than this, but and then like okay, yeah, if you had like this would be invalid, this would be invalid because the one like in the left always has to be smaller than the one on the right.
Okay, so the definition is the left children have. Okay, I'll write out the definition here. This is close, but not exactly. So for every node, the left, all nodes in left subtree is smaller than node.
Okay.
All nodes in right subtree is greater than the node. Apply this definition recursively to every node.
Yeah.
right? That makes sense.
Yeah, makes
So,
sense.
is this a valid binary search tree?
So, so maybe I need to do like maybe a bigger root.
Why? Or where does
Like,
it break? Like, leave it in that normal case. Why is it not a valid binary search tree? Or I'll just tell you right now, it's not a valid binary search tree.
yeah.
Why isn't it?
This is because like this is greater, like 4 is greater than. Can I like say like this maybe? This would fix this left subtree, right? Or no, well wait. Um, something like this.
Okay, why did that fix it?
Because this is in the left subtree, it's smaller than node. This is in the left subtree, it's smaller than node.
Okay, but 5 is greater than 1.
Oh yeah, so then I would need like 0.8 here.
Okay,
This fixes that, right?
Okay, yeah, so we have 1. All the elements to its left are smaller than it. All the elements to the right are smaller than it. Okay, now it has the proper definition. Okay, pretend we just now we have a target value. Return me the smallest, like the closest element to it.
So like
pretend we
like
do
if
0.9.
Yeah, so then it would return 0.8. It would return this.
Okay. What if we did 0.71?
Then it would return this.
What if we did 0.75?
It would still return this.
Why?
Or no, never mind. Oh, so well, yeah, well, I think I don't know how I would determine like because basically the difference between this is because it's the smallest basically is why.
Okay.
Is my answer. Yeah.
Okay. All right. Yeah. Okay. Seems like you understand it. What would be your solution? What are you thinking?
Well, so I think this kind of reminds me of I don't know why, but this kind of reminds me of twosome. But I don't know if this is it. This is the case, but and multiply answers pretty small. So I obviously will need to do some kind of traversing of the tree.
How come it reminds you of twosome? Like, what are you thinking there?
Well, like, if you ask me instead, like, if closest to the target that are equal to the target, then what I could do is like I could basically like do some traversal where I store these values, and then I could just basically keep recursively checking if those values add up to whatever the target is. So, like, yeah, like say like you said equal to target, right? And the target was
Okay, let me just change this a bit. Let's say, yeah, first equal to target, and then let's say closest to the target after.
okay. So
So pretend we have a target of literally 6. Like return me like just a Boolean value if it's in this binary search tree or not.
okay, so I think just correct me if I'm wrong on this because I don't want to because I know we're limited on time. I could use any kind of traversal. Like I could do pre-order, in order, or post-order for this to work, right?
Yeah. I mean, okay, how would that work if you did a pre-order, post-order? But I
Well,
think just remember we have a binary search tree here.
yeah. So, like, I would maybe think in order could be good. Um, because if we're doing in order, the values will be like in sorted order, and then we could like we could basically just check like uh if like they add up like to the target easier, if that makes sense. Um, so what I'll do though is I'll just so oh shoot, this is hard too because yeah. So do you want me to write like the class for the tree as well?
Pardon?
Do you want me to write like the class for the tree as well?
Class for a tree? No, we could assume that we have like a tree node class with like left child and a right child,
Yeah. Okay.
and the left child is a tree node, the right child is a tree node as well,
Yeah. Yeah.
right? So we're gonna be given this int. Let's just write a function that takes in a tree node. So we have a function called
Like root or something.
I'll send you the function definition.
Okay. Well, I still think I'll need this. So,
So literally the function definition is like this. We're given a root and we're given a target. Let's just say return true if that target is in this binary search tree, false otherwise.
yeah. Okay.
Okay.
So I think so I could say like if there's nothing, then if the root's null, then we return nothing, and then I'll need to like check the target. So I'll need like I think I could do this. I think this is how this is done, and then I think I would pass this in here too. I'm pretty sure, and then also before I do this, okay, I'll try this one. I think, and then and then
So we're gonna be doing a DFS. I think. Okay, we're doing a DFS here. But like we're not using the property of the binary search tree at all. Like
yeah, I see.
if I were to tell you just find me a node, this node in there, that would make sense in a regular tree. But this is a binary search tree, it has a specific property.
Yeah, I see. So, like, I have to do like the kind of thing where if it's less than the target, yeah, I would actually. I think I would have to spend more time to think of it, but basically, like if it's less than the target, then we could. I don't know. It's tricky to come up with this because I know I need to just like practice it more. Yeah, like okay, so what I know for sure is everything will be so like if I wanted to find 6, for example, I know like I could check this, right? And then
Yeah,
like instantly
pretend we're looking for 6, right?
yeah, so if I check this, I basically can eliminate all of this because this is like less than 6, and like I would have to go to the right because I know all of these values will be smaller than 6, and then I'll go here, and then this will be greater,
Okay.
like because
For-
right side. Wait,
let's
is this part valid?
pardon?
Is this part valid? Yeah.
That's or this is not really valid. It had to be like something like this.
Yeah.
But let's say here, right? We're looking at this node and our target is 6. So we know all the elements to the left of this node in the subtree are less than 1. And we know all the ones to the right subtree are greater than 1. Right? How can we reduce the amount of search space? Or like where do we need to look and not look here?
Well, yeah, like that's what I was saying. Like we don't have to look in the left because it's all going to be less than like the target. But then we could look anywhere in the right.
Okay.
So
you're saying
yeah.
we hop into here?
Yeah, exactly.
Okay. And then what do we do here? Pretend this is we're looking for 6.
Well, so yeah, so 6 isn't so now that we're here, well, yeah, so it can't be here. So then we would have to check here. Like, so 6 could be here, right? If this was a 6 instead of an 8, we would look here, basically.
Mm-hmm. Okay. And then what happens when we get to here?
Then we would return true.
Okay. What about if this wasn't here? What happened?
Then we would return false because it's not in the tree.
But would we look in the right or left at all?
Well, I think we would still check in the right still, and then I think we would check like the null, like the nulls, right? Of this.
Okay.
We would check like these.
What would be the runtime complexity of this algorithm?
Isn't it just O of n?
O of n for.
Or I guess would it be like log n because we don't have to search this? We wouldn't be checking the whole tree, so.
Yeah. I mean, worst case is still O of n.
Oh, yeah, okay.
I mean, if it was perfectly balanced like this, it's log n, right?
But worst case, it's O n.
Like worst case, it's like pretend you have 1, 2, 3, 4, 5. You're searching for 6.
Yeah.
Right. Cool. Try to implement this one where we search for like just the value.
Yeah, just the value. And like return a Boolean.
Yeah.
So basically I would have to do the thing I was saying where I have to check if the values in like the left subtree, like I would have to do if this or I'd say less than for this one, I think. Or maybe let me just restart on this one.
Okay, we're actually at time pretty much. So, yeah, how do you think you did on the interview? What's your assessment of yeah?
I mean, so for the first one, I think I came up with a solution that worked, but coming up, I think like unless you've studied the optimal solution for it, it's very tricky to come up with like on the fly to just like think about it. Like I think if I had more time to think about it, I'd be able to do it. But in an interview, you just don't have the time. So I think like just like I need to figure out a way to come up with like my solutions faster. That's one thing for sure. And then for the second one, I think I just need to, because like when I solve tree problems, I don't actually think I think in depth is in I don't think I think as in depth as I should be of like all the properties because in a way like if you just think BST, it kind of gives you a huge hint
Yeah.
versus just like a tree. And like I kind of was looking at it just like, oh, it's just a tree, if that makes sense. And like, you just like kind of mindlessly think you could like DFS everything or just you could just do some kind of template to the problem, but if you didn't study like the actual meaning of a BST, which I like, I vaguely know it, but I don't know it in depth enough. So I
Yeah.
think that's some issues I made.
Yeah.
Yeah.
I agree. Yeah. I think overall, like, just need more practice for sure. I think with the first question, let's see. Some of the notes were, yeah, I think the first one you did it, you kind of did it with extra space and then you didn't do it in place.
Wait, sorry,
And
what do you
then,
say?
or like for the first question, the first way you solved it was just like by not using extra space. Or sorry, by using extra space.
Not using extra space. Yeah,
And
yeah,
then
yeah.
you tried like adding it into nums one and then sorting it. Like you tried solutions that they're all valid solutions. But I think yeah, definitely being able to iterate towards the answer faster. And the best way to do that is just of course with a lot of practice. But I think you've already done almost 300 questions. So I think you you probably need to maybe push yourself harder on the training as well. Maybe do questions that like how many of them were easy questions versus medium versus large or hard.
Let me see. I think too it's like I need to maybe spend more time on problems and go more in depth, like in like how I would interview. Like basically like kind of
Yeah.
making a video or something. And like also solving all solutions. Cause I think I solved the merge sorted one a long time ago. And I think I just did that, like I just did that solution. I'm like, oh I solved it and moved on. Okay, yeah, so 153 easy, 130 medium, 7 hard.
Wait, say it again.
153 easy, 130 medium, and 7 hard. And recently I just finished well I didn't completely finish, but I'm almost done with like the blind 75.
I see.
I did 65 out of 75.
Yeah, because honestly, you did a that's already like 300 questions. I feel like that's a good amount. So I'm just trying to figure out like how we could like get the studying harder then,
I think it,
because like yeah, because 300 is already a ton.
well I think it's cuz I did a lot of easy ones, I
Yeah,
think. And like cuz I don't have much experience coding. So
I
those
see.
like I did like really easy ones too, like
Okay.
I don't know if you know this one, like convert the temperature or something like this.
Yeah, I think what people are saying in the chat is like how long do you take on a problem before you look at the solution?
Um So basically, like now since I've been doing like so I've been changing just like this past like week, I've been changing out my training a bit. I've been spending like maybe around 30 minutes on a problem,
Yeah,
but before it would be much less. I would just like sometimes I would just look at the solution right away.
I see.
Um and like try and like just see if I could understand it. But now like what I've been doing is cuz so in the contest, in the leak code contest, I usually could solve the first question.
Yeah,
The second question is tricky. It's like I've only one time I came up with the and kind of today, I maybe twice I came up with the solution on my own for the second question.
mm-hmm.
Um, but I could very rarely come up with a solution on my own for the second question. So I've been thinking like if I just keep spending more time, like I'll eventually get it. But it's just very frustrating because like I feel
Yeah,
like I get so close on the question and then I just miss like I make a little mistake or I miss an edge case or I didn't like understand the question
I
properly.
see.
Like
Yeah. Did you just dive straight into questions, or did you study like some of the foundational stuff, like the different patterns, the different underlying data structures?
um mostly I think mostly dive into questions. I think I did. I have done like read some books and stuff and like looked through that stuff, but I don't think I did it like very sophisticated, like where I took notes on hand. Like
Yeah.
I would just sometimes read for like just read the reference, like read the algorithm, like that book Corman algorithms or whatever.
I see. Have you
Like I was
did you take a DSA class in school too? Of
yeah.
course.
So
Okay.
I took algorithms recently, and it was super hard. It was super hard because all like proofs and like math, and I feel like that stuff. I think it could help with leak code, but I just don't know how to. I don't know how to like apply the logic that you would learn in proofs, like a proof class, than you would learn in
Yeah. Okay. Yeah,
Did
I
you
think.
study?
No,
For,
yeah, I did the same thing. I think the main thing, I think you should maybe spend some time learning some of the underlying data structures and algorithms as well. Like, study the Leak Code Explorer cards and get a deeper
Yeah.
understanding on those fundamentals. Because then
Yeah,
it'll, and like study the different patterns. Like, once you start thinking in terms of like 2 pointers, 3 pointers, I think you'll come up with a solution for Q1 faster. And then if you really had like a deeper understanding of binary search trees, you'd be able to come up with a Q2 solution as well. So it's more not about seeing more problems because you've already seen like 300 questions. More, I think, working on the fundamentals again and just making sure you iron those out.
Like, was my thought like what's the like? Yeah, so I guess like what's the issue? Is it my thought process or is it? Because I feel like I kind of, I think I understood the questions, but
It's more like you couldn't get to the optimal solution, um, and like you weren't making progress towards it. I would say, right? Like for the for Q2, I think you because it's if you're making progress towards it, I think that'd be different. But I think like especially for Q2, you weren't thinking about the binary search structure at all. That's what I mean. You weren't making progress because like some candidates might look at it with the DFS and they'll realize that it's a binary search tree, and then they'll move towards like they'll slowly make progress towards the solution. But I think you got stuck on Q1 and Q2.
So you had to point me to the direct. Yeah, I see.
Exactly. So I think more understanding fundamentals, and like studying the different patterns like 2 pointers, sliding window. Like try to do solutions in different all the different categories, and then try to look back at these questions, and then do like 5 different binary search tree questions. I think that will definitely help you. Because honestly, I was like that too. I did like 200, 300 questions. But when you're like just solving them, and you don't have like the patterns, and you don't understand like the total I mean, you understand the patterns, but like if you haven't studied the patterns or the data structures in depth, you're kind of solving each question kind of randomly.
Yeah.
So I would
So, like,
yeah.
yeah, that's how I've been. So, do you know what like the zero track leak code problem rating thing is?
Yeah.
Yeah, so because like I'm trying to get better at the contest, so I could solve the question two. Like what I've been doing is just doing all the question twos, like the easiest question twos, and just spending like 30 minutes on them and trying my best to solve it. And like that's completely random topics, if that makes sense. But
Yeah, focus
they
more
just
on like
was
direct topics and then move on to next. Focus on heaps for a few days, then to DP, then to 2 pointer, and do a bunch of questions in 2 pointer, then go to like monotonic stacks. Like spend a time on each one. That's kind of how I'll do it.
so basically just concisely to put it, more topic wise and more like fundamentals.
Exactly. Yeah.
Should I watch like videos too? Do you think that's helpful, or is it best to just like do it on your own and think to yourself?
I do both. Like whatever I'm feeling. Sometimes I'm feeling like reading. Sometimes I'm feeling like videos. Depends on what's the best topic. What's the best way for me to consume it right now. But yeah. All right. Thanks for taking the time out. I have to hop to the next guy. But yeah.
See you.
We could do it again. Like, let me know when your Google one is. Message me again. Email me or
Yeah,
message me on Discord, and we'll do another one. Like, I can help you get better at it too. I think you have. You're in the right step, but like, just more fundamental stuff.
Yeah, I mean, I could push it back. Basically, as long as my recruiter said, just literally just email me when you're ready, and
I see. Okay.
I still think I need some more practice. Oh yeah, thanks. See,
Okay,
I'll
cool.
let you get to that.
All right. Yeah. Okay. Bye. Shabaj coming through. Yo, Shabaj, what's good?
Oh, what's up?
What's up, man? How you doing?
Chilling, dude. I was brushing my teeth just like you.
What would you eat? Or you
I
just brush for fun?
Oh, no. So I had my dinner at 6:30. I was cooking beef.
Nice. You cook your own food?
It's really random. Sometimes I get Chipotle when I'm at work, or
Yeah.
like sometimes I just cook myself. It's been getting very expensive, like eating out. Very expensive.
Alpha
All right,
quote told me James is raising the hiring bar pretty soon. Be too hard. Okay, I'll introduce you quickly. I'll
Okay,
shout
so
out your
you-
YouTube
you
channel.
know-
I gotta shout out your YouTube channel.
Oh no! Okay, sure. Dude, I do not know how YouTube works. I need to learn. Like when I do like live streaming, I leave no context, no links, no nothing. It's so hard to follow. So I should like do more in-depth videos. Like I've been like coding on my app, and I'll just do like a recap video of like how I built it. Hopefully, I like publish it on the Play Store, App Store this month.
Yeah, that's great. What's your plug your YouTube real quick? What's it?
Oh yeah, you're not gonna be able to find it. Yeah, it's like hold up. I'll leave it in the Google Meet chat. Yeah, it's really dude. Like I saw you like just keep you're just posting videos every day, and I saw another person I went to school with. She started posting on Instagram Reels and TikTok, and like
Nice.
she's also doing very well. I
Yeah.
was like, well, wait a second. Like let me take a shot. Let me try.
Yeah. No, you got this, man. You got this.
You just gotta be like you just gotta be trolled, like
Yeah. We're gonna give you a good shout out on this one. I'll post this as its own video and tag your
Oh
channel.
my god. Okay, what's the title gonna be? Trolled as lead code.
I'll say Sabaj as lead code. Let me look for your. Let me get you on the coder pad.
Oh no, yeah. Do like something like clickbait title. Comedian troll does internet troll does a code challenge or something. I don't know.
All right. Okay.
All
Okay,
right.
I'm gonna send you an invite
Where are you gonna send it to me?
right here. Are you on the stream? Because that's where my camera's
No,
on.
I turned the stream off. I'm not gonna look at the chat. I'm gonna get cooked in the chat.
Yeah, sorry I don't have my camera on the right side because I'm streaming on the left side. Trips up. It like causes the thing to tweak.
That's fine. All right, Google. Let's fucking do it.
Okay.
Put me in, coach. Let's go, coach.
All right. Hey everyone, I have my friend Sabaz here. This guy's been inviting me to a pool plunge party. I had no idea what a pool plunge party is, but
Come on, dude.
apparently
Come
you
on.
just hop in a bathtub with a bunch of strangers. But I said let's just do this interview instead. Sabaj, introduce yourself.
If I pass this interview, will he come to the plunge party?
Yeah, if you get all these questions, I'll come to a plunge party.
Okay. Fuck. Okay, the pressure is high. Okay, I'm Kabaj. I work at AWS. I graduated college in 2023. I studied computer science, and I just like to do coding for fun. Like I just build all my apps and just have fun.
Yeah, it looks like you have your own YouTube channel. Like, what got you into starting your own YouTube?
I'm just trying to have fun. I just coded my own stuff in my free time, so I was like, let me just like live stream it. So that's the only difference. This is usually what I do if I'm not streaming, just like working on my own goofy ideas.
Yeah.
So I thought it would be just experiment, just see what happens.
What kind of stuff are you working on?
Right now I'm working on just like trying to make consumer mobile apps that like integrate like maybe LLMs. So the app that I'm currently working on, it helps you become better at cold approaching people. Like when you're at a bar, like you have the nerves, and you just want to practice, calm yourself before you approach someone. So started working on that. I shared it with a lot of my guy friends. They've been loving it. I should send it to you as well, James.
I'm down. Send it.
Oh yeah, I'll send it to you on Discord.
And do you like to use like Windsurf and other AI tools?
I have both Cursor and Windsurf. I think both are same. I personally have had a better experience using Windsurf, but I think both are same.
I see. So how do you calm yourself down before you go for a cold approach?
A cold plunge?
Cold approach, you said.
Oh, cold approach.
That's what your app does, right?
Yeah, I feel like it's more of like a placebo effect. Like once you do a lot, like it's the same as doing a lot of mock interviews. Like I've done a lot of mock interviews, and so now it just feels like second nature to like just do like a lead code question on the spot
Yeah.
and be perfectly fine if it doesn't go my way. Like, so I used to like use this website to do a lot of like mock interviews, and like that helped a lot. I did this during college.
I see. No, I said cold approach. You said you have an app for cold approaching.
Cold approaching, yes. It's not published yet, but I will publish it.
Yeah, but what is your strategy? How do you do the cold approach
Oh,
and calm your nerves down?
Honestly, okay. So you can practice on the app, like practice a different scenario, like because usually you approach someone and they just like outright reject you. So like how do you deal with that?
How do you deal with it?
You're just like, hey, all right, cool, man, have a nice day, and just walk away. On to the next one.
Okay. How do you calm your nerves before you go approach and actually go
Oh,
approach?
I see. Honestly, calm your nerves. You just gotta like if you have nerves, you just gotta thug it out. Like it doesn't matter. You just gotta walk up, be confident. Dressed up nice, smelling good,
Nice.
great body language. Just introduce yourself. Hey, I'm Shabaj. What's your name? And you just have to see how the other person responds. If their body language is receptive, you can talk to them. But if they're very like reserved, then just say hi and move on. That's what I've learned.
This is exactly why you work at Amazon, man.
It's exactly how
what school did you go to? Like, and do you? Yeah, go ahead.
I went to it's a state school in California. It's called Cal Poly.
Nice.
Yeah, that's where I went.
Cool. All right. How many leak code questions you've done, and like, what's your level? I need to figure out.
My lead code is Yummy Shooter. I'm Yummy Shooter.
Well,
I've done like about 300, and I can do like mediums, and most of the mediums in like 15 to 20 minutes.
I see. Most mediums in 15 to 20.
Yeah, okay. Like I've done like all the Blind 75 list, all the Premium Explorer cards, like when I used to grind in college for like, yeah.
I see.
Yeah, so I would say I'm definitely like I can like I've solved 22 hards, but yeah, like let's just have fun, dude.
Yeah. Let's get
Give
this.
me the most insane hard question.
No, we'll warm it up.
Oh, we're gonna warm up. Okay, let's do it.
You like to use Python?
Yes, Python. I actually don't use Python for anything, but for interviews, yeah, like
I see.
It's a lot easier. Okay, where are we gonna get?
Yeah, we're gonna try to do 2 questions in the span of 40 minutes, 20 minutes each. Let's hop in this right now.
Yeah.
So you're given the root of a binary tree. Imagine you're standing on the right side of it. Return the values of the nodes you can see, order from top to bottom.
Okay. Can you give me an example of like how the tree? So given the root, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom.
Okay, I'll show you one example.
Okay.
Go, hit the drawing board.
Oh, you're on the drawing board. Oh, I see. Yeah, I see the drawing board.
2, 5 right here.
Yeah. 2, 1, 2, 5. Yep.
Okay, if I want to see the right side of the view, what does that even mean? What do you think?
I think it should be 1, 3, 4.
Exactly.
Yeah, 1, 3, 4.
What about if I have like a 6 here?
Yeah. 1, 3, 4, 6.
What if I have like a 0 here?
4. Yeah, 1, 3, 4, 6.
What about if I have a 2 here?
1, 3, 4, 6, 2.
All right. Okay.
Yeah. Okay. So let's like write it down in the code comments so we can use this example. Or unless, okay, fine. So we have 2, we have 3, we have 5. Wait, oops. 5, and then we have 4. Then 5 had, okay, 0, 6. And then 2, okay, or let's just say 7. So 1, so 2, okay, I just want to make sure I have the tree out in the comments. I have it look correct. Okay, so in this case, if we want to see the right side of this tree, it should be 1, 3, 4, 6, 7. So that looks fine. And if it's like let's just think of like what are some like normal, like if the tree is just a node with 1, the answer should just be 1, correct?
Yeah.
Oh yeah, cool. So I think the first thing that comes to my mind, what we can do is we can do traversal of this tree. So we can traverse all the nodes in this tree. So traverse all the nodes in the tree, and we can either pick BFS. I think both would work. And each time we traverse, we just keep track of the level that we saw that node at. So keep track of level the node was discovered, and then so it's more like a level order list. So let's just say on level 0 we saw 1, on level 2 on level 0, on level 1 we saw 2 3, on level 2 we saw 5 4, on level 3 we saw 0 6, and level 4 we saw 7. So it looks like, okay, so I think in this case we should do DFS, traverse all the nodes in the tree using DFS, where and where we visit the left, or I mean, oh wait, let me close the drawing board.
Yeah.
Wait, how to, okay, done. Where we visit the left subtree first, right second, um, and then keep track of level the node was discovered, and then once we're done with the traversal, return the last element from each level. And I think this approach would take time of O of n and time complexity of linear time complexity and linear space. So that's the first solution I can think of. What do you think of this?
I think that works. Linear
Mhm.
time, linear space. Yeah, go ahead and code it up.
Okay, cool. Okay, let's just see right side view, and like I'll just make like a class node, just so let's just say it has like self left something, self dot right not something, and it'll have, like, we can implement this class later, but just to have it as a reference, like it'll have a left right, and we'll probably be past the root node. If root node none, just return none. And then we here do DFS. We can pass in, so we'll need this helper method to help us do DFS. If node none, return none. And let's just say level map. Let's set this to something. Let's also pass in the level map in the DFS function.
Sure.
Well, we'll also need current level to keep track of the current level that we're at. And then we'll call this our helper function. We'll pass in our root node. We'll pass it our level map, and we'll pass it our current level, which should be 0. So once we're here, we will add our current node to the level map at that specific level. So this should be level map, and so it also has some value which set to 0, and we only need to return the values of the nodes. Okay, so we only need to return the value of the node. So level map at current level should be level map dot get the current level. If current level, if it doesn't exist, return an empty list, and then we can just add node.val. So level map, we get the current level. Then from the level map, we get the current level. If nothing exists, we return an empty list, and then we append that. And then what we then have to do is DFS node.left level map current level +1, then call node OK. Wait, level map current level +1. And once we're here, once we're done with this DFS, once we come out, let's just say like right view can be, this is our answer, and then at the end we will return our right view. So now here we just need to populate that right view. So our min level is 0. Our max level would be we can just do max of level map dot keys. So we can just like get the max key from our map. Then we can just do for IDX in range min level max level plus 1 right view dot append level map. Let's use the level. That's a better variable. Level map at level the last element. So we start from the 0th level, and we find the max level, or the max the max level, and then we our level map. We look up that specific level and grab the last element.
Okay.
Yeah. Let's do a dry run. What do you think?
Yeah.
What do you think?
Dry run it.
Oh yeah, cool. Let's do that. Okay. I'll copy paste this here. We'll also make our level map and our right view. Okay, cool. So let's okay. Looks fine. Okay, so we have our root node here on line 52. We have our level map, which right now is empty, and our root node is here, and our level is currently, we're at the 0th level. So we're going to call DFS here. We're going to call DFS on the root node. We're going to pass that root node. We're going to pass that node here. So right now, our node is going to be 1, which is the root node. Our level is going to be 0. Our level node is going to be empty. Our current level is going to be 0. And then what we're now going to do is level map. So let's also store so our level map. So we're going to do level map get 0. There's nothing in the 0th level, so we'll return an empty list plus the value of that node and set that level in the map. So
yeah.
Okay. So 0, and here we'll set 1, and then we will then do DFS on the left subtree, which should be 2. So this would be 2. Our level map is here, and then our level would just become 1. So we'll come here. Our node is not none, so we will then see our current level, which is 1, and we will set its value. Yeah. So this will be 2. So now similarly since we're still at 2, we will then look at it doesn't have a left child, so for the 2 we'll go to its right child, which would be number 5. Level map, we have that, and our current level will be 2. So once we come here, we see we have nothing for 2, and we'll set level 2 and set 5. And then now we're at node 5. We will then go to its left child, so which would be 0, level map, then level would be 3.
Okay.
And then we would set 0, so we would populate this list, and similarly, we would explore its left. It only has a left child called 7. So then we will come back up. We'll come back to 5. And where did we see 5? So 5 had 0 on level 3. So we saw 5 at level 2. We explored its left subtree. Now we will explore its right subtree, which is 6. So 6, once you come back up the recursive stack, it'll be 6. At that point, the level would be 3, and the level would be 3. And once we come here, we see that the level is 3. We already have set it to something, and we will just append 6. And so this would be we're now done with the whole entire left subtree, starting from
Yeah.
root 1.
I see. Okay. Let's move on to the next question.
All right.
Good job. Yeah, chug that water.
It's Diet Coke, actually, bro. It
Why
helps.
diet?
Well, it helps with restricting hunger. Or it's like the same effect as caffeine.
I see.
Ooh, okay. You're given a network of nodes labeled from 1 to n. You're also given times, a list of travel times as directed. Source node signal to travel from the source to target. We will send a signal from a given node K, return the minimum time it takes for all, if it's possible, for all the nodes to receive the signal. If it is impossible, return 1. Okay, let me read it through. You're given a network of nodes labeled from 1 to n. You're also given times, a list of travel times as directed edges. Okay, where UI is the source node, VI is the target node, and WI is the time it takes for a signal to travel from source to target. We will send a signal from a given node K, return the minimum time it takes for all the nodes to receive the signal. Okay. I think I understand.
You can walk through it, whiteboard it for me. Like whiteboard me an example.
Okay. Yeah. So I think so let's just use a simple. I'll use maybe 5. Let's use 5. I think I have like so let's just say this is let's just make this so it's a directed graph. So let's just use arrows, and let's just make an edge from every node to every other node.
Sure.
And then each node has a weight. Each node has a weight. So let's just say like this is node, so it takes like 5 seconds to travel.
Here, let's start with this very basic case.
Okay.
Right. Let's put everything as 1.
Oh, okay.
Okay, this is the source. What should be the answer here?
And no, which is the final node? Oh no, we have to make sure that we have to make sure that if the signal starts from S, how much time will it take for all the nodes to get the signal, right?
Yeah.
So in this case, this node will take 1 second, this node will take 1 second, and this node will take 2 seconds. So it should be 1 plus 2 plus 1. And this one, this node will also take 1 second. So 1 plus 1 plus 1, 3 plus 2, 5. I think it should be 5, right?
Wait, let me draft up this solution to 2. I think it should only be 2, because what we're returning is the amount of time it takes for all the nodes to receive the value.
Oh yeah. I understand. I get it now, because in 2 seconds all the other nodes would have received the signal too, right?
Yeah.
Oh, I get it now. So it looks like the answer would be like the max, like so the answer should be the time it takes to get to the node that receives the signal at the very end. Like, does that make sense?
Yeah.
Oh, I see. I understand that. So it looks like. Okay, let's try another example, just so I can make sure I understand this correctly. Let's try different values. And I'll try to do this quickly. And for let's just say it takes 5 to travel down here. It takes 2 to travel down here. and it takes 4 to travel down here, and it takes 3. Just random values. 1, 3. So it looks like on to me it looks like the shortest path, or not like a shortest path problem, but we're using like a directed, or we're using a graph that has like weighted edges.
Yeah.
Yeah, that's so okay, I see. So I think what we need to do is like from the source node, we need to, okay. So from the source node, if this is the source node, what we need to do is find the shortest path to this, like what's the shortest path to this node right now. Like it looks like, so if you go down 5 4, we don't have a graph that goes this way, so signal is only coming down. So we can take 3 2, it takes 5 seconds, but then to get to this graph we can also take this path, and that looks to be the shortest one for this node. So here the answer should be 2. To get down to this node, we
Are you
only
saying
have,
these are weighted 1 or what?
oh no, these were weighted whatever I had before. Did you not
I don't see that.
Oh wait, you're not seeing them?
Wait, let me refresh.
Okay, no problem.
Okay, 2.
2, let's
2.
just
Okay.
just 2 4
Okay.
and then
So how much time should it take to get to 2?
oh, so no, how much time should it take? Wait, how are you asking how much time should it take to get to this node?
Yeah.
2 seconds, I think.
Mm-hmm.
Like that would be the shortest path, because right now there are 2 paths to get to that node. Either you go from the center or you like take the direct route. But if you go from the center, it'll take you 6 seconds. But if you go from the source, it'll take you 2 seconds. So the shortest path to that node is 2 seconds.
Okay.
So this should be 2. So that's 2. Then to get to this node, let's just say there's also a path from there are 2 paths. So you can go directly from the source, or you can go from the middle. And let's do this one differently. Let's just say from the middle it's faster. So you take 2 seconds to get to the middle, and then 1 second to get to that. So it'll be like 3 seconds total. So the shortest path to get to that node is 3. The shortest path to get to the middle is 2. And then the shortest path to get to this node will either be 4, or no, will either be 3 plus 4, either be 7, 2 plus 3, 5, or 2 plus 4, 6. So the shortest path to get to the final node would be to start from the source, go to the center, and then go to the last one, which should take 5. So the answer of this should be 5, because within 5 seconds, all the nodes would have received the signal.
Okay. So what's your answer? Or
Answer
like,
is,
what's your algorithm?
so the algorithm is we need to find the short. Let me write this out in the comments. So
Sure.
So the algorithm is shortest. So starting from the source, find the shortest path. Find the shortest path to every node in the graph. So starting from the root node in the graph, and once we find the shortest distance from the root node to every other node in the graph, the answer will be the node that is the farthest away from the root. So we have to find the shortest path from the root node to all the other nodes in the graph, and then the answer would be the node that was the farthest.
Okay, how are we gonna do that?
How are we gonna do that? Okay, so we so we should use, so since we're doing shortest path, we can use a breadth first search traversal, because in breadth first search, whenever we discover a node for the first time, we know that the path that we took to get there was the shortest. So we will use BFS because uh, because the path taken to a specific node from a given
Yeah. Is that true though?
um
Like, what if we come back on the drawing?
yeah,
What if we have
yeah.
like?
I think I so in this case, so that is true if the graph is unweighted. That's true if the graph is unweighted. So I think maybe we can modify the algorithm to take the weighted edges into, because here this is where the edges are weighted.
Yeah.
So what I'm thinking is like we just need to tweak the algorithm a bit to take the weight of the edges into account. Because in this case, like if you look at the graph, like the
Okay.
shortest,
How are you thinking of tweaking the algorithm into it?
I think that would be because in BFS, wait, so in BFS, what we can do is hmm. Now that I'm thinking, I wonder if no. I'm just thinking like if you could just do a depth first search, or like just do a normal depth first search, and no, wait, I take that back. I think so. The way we append. Oh, so the way we can do this is whenever. Okay, let me draw. Okay, let's go back to the drawing board. I'm at the drawing board.
Yeah.
And we have, so in BFS we use a queue. We use a queue. So let's just say we start from the source node, and we start from the source node, and right now we have three neighbors. We have the neighbor at the very right, the neighbor at the very below,
Are you
and then
in the whiteboard?
yeah, I'm in
Okay.
I'm in the whiteboard. You might have to zoom out.
Okay.
Yeah.
Okay.
So
Well,
in
yeah.
this case, starting, I don't think if you can see if I highlight, so I'll
I
draw
see.
it. So I start from here, right? This source node has three neighbors. This one, and this one. Do you see me mark them?
Yes.
So so the way we can append them or push them onto the queue is we can just push by the, so we know that the one on the very, like this one, the one on the very right is the furthest one, so we will push this node on the top, and we can keep track of the distance that it took to get to that node. So we can see to get to that node, like this node, let's just name this node node J. We know that to get to J, it took us two. And then we know that the next farthest, so then we have the middle node, and let's name this node Q. We know that the Q is now the one that is the second closest. We know that this time it took to get to Q is 2. Then we know, and let's just name this Z. We know that the time it took to get to Z is 5. And let's, okay. And let's name SJ, and let's name this X. Oops. How do I, wait, I need to delete this. Okay. Okay. So we know that the time it took to, so now we have visited, we have we have visited S. So now we're done with S. Now we know that the next node is we now that the next node that we're gonna traverse is J. Let's also keep track of like the min distance that it took. So we know that the time it took to get to S was 0. Now we're gonna traverse J. We know that the minimum time that it took for us to traverse J
Okay,
was
so what's your data structure here? You're just using a simple queue?
yeah. This is a queue. So this is a queue, and the other is just like some sort of a hash map to like keep track of like the minimum time it took to get to that specific node.
Okay.
Yeah. So we know that we got to J in 2 seconds. So now we're gonna take that off the queue. Now let's just see which neighbors does J have. So J only has one neighbor called X. So we will then push X onto the graph, and we know that it took for us to get to J, it took 2 seconds. So for us to get to X, it will take 2 plus 4, which is 6. So it took us 6 seconds to get to that. So now we're done with J. Now we will explore Q. So till now, we know that to get to Q, the min distance was 2. The minimum distance that it took for us to get to Q was 2. Um, it took 2 seconds, and now let's see, what neighbors does Q have? Q has neighbor J. Q can go to Z, and Q can go to X. So I think here's where we can like look it up. So Q has a neighbor called J, and if we want to get to J from Q, it will take us uh, how many seconds? It took us 2 seconds for us to get to Q. And now if we want to go from Q to J, it will take 2 plus 4, 6. So for us to go from Q to J, it will take 6. But if you look in our hash map, we know that we got to J in 2 seconds. So I don't think we should push this onto our queue, because we've already, till now, we've got to J in the shortest path. We have not seen a shorter path yet.
Mm-hmm.
So we will not push J onto the queue. Now let's see Z. And let's, oh, I didn't write this. So let's just say from Q to Z, from Q to Z, it takes 1. It takes 1. So if we want to get from to Z from Q, it will take 2 plus 1, 3. It will take us 3 seconds to get to Z, but we haven't seen that yet. So till this point, we haven't gotten to Z. Like, even though we did push Z onto the queue when we were at S, we haven't really visited that node yet. So I would still append Z here. So for us to get to Z, it will take 3 seconds, and then for us to get to X, it will take 2 plus 3, 5. We haven't seen X yet, so let's just add that. So X, 5. So now we have visited Q. We can now remove Q from the BFS queue. Now we're visiting Z. So we're at Z, and we know that right now the path that it took for us to get to Z
Okay,
was,
let's go down to this last exam. I think I see where you're trying to go, but I'm not sure if it would actually work every time.
yeah, I can see. The only problem I have is if there's like an infinite loop. The only thing I have
Yeah.
to keep, if it keeps infinite looping, that's the only difference. I think you, yeah, sure. Yeah, go ahead.
Okay, how would you solve this case right here? Like, what's the answer for this bottom one?
Bottom one. Okay. So this is 1 1. Wait, this is 1 1. The other one is 5. And what's the from 2 to 1? Is that 1?
One, yeah. What's the
And
answer?
what's the source node?
This one. Source is here.
So the answer should be yeah, in this case the answer should be 3.
Okay. Let's say these are all bi-directional too.
Oh, these are all bidirectional. These are all bidirectional. It should still be 3. I would think because you go from this node to this node in 1 second.
Yeah. I mean, yeah,
And
it's 3. Okay, run your algorithm on this, and let's just
then,
like what I need to make sure is that like how do you handle infinite loops, like you mentioned?
infinite loops. I think the one case that in this case. Oh wait, how do I handle infinite loops? Okay,
Yeah.
okay, okay, fine. Okay, let's like draw it out so it's a lot more visibly clear. And let's see, because that's the only concern I have is what if it starts to infinite loop. Let's just say it's bi-directional.
Well, let's work through this specific example.
This one, right? The one that you
Yeah,
drew.
yeah.
Yeah, I'm just like redrawing it so I could like it's like easier to keep track of
I
it.
see. I see.
Yeah. So I'm just constructing that. And so we can go both ways, and this this the weight here is 1, the weight here is 1, the weight here is 1, and the weight here is
5.
right?
Yep.
Okay, and let's name these nodes A, B, C, and D. Let's create our queue here, and let's just also create our like hash map. Do you see it? You might have to zoom out.
Yeah, I see everything.
Okay, sure. So we're gonna start. So A is the source node, right? A is the source node, right? Correct.
Yep.
So A is the source node. So we know that to get to A, we're gonna start at A. So we know that to get to A, it took us 0 seconds. We just started from there.
Yep.
And so now A has 2 neighbors called B and C. We know that the closest one is B because it is 1 second away. Hold up. I need to put the charger.
Charge it up. Charge it up.
Charge it up. It's gonna die. Okay.
Let me fill up my water. Keep talking.
Okay. Yeah. No. So for us to get to B, it's gonna take 1 second. For us to get to C, it's gonna take 5 seconds. So let's just put B onto the queue first. We'll put B, and we know that it takes 1 second to get there. And then we'll put C, it takes us 5 seconds to get there. And now we visited A, and now let's go to B. Now let's go to B. So B can go back to A, right? Because there's an edge back. And so how much time would it? So we're at B. It took us 1 second to get to B, and for us to go back to A, it will then take another second. So it'll be 2 seconds back to A.
Yep.
But if you look in our map, it took us 0 seconds. So we've already discovered a shorter path.
Sure.
So I don't think that we need to push that onto the queue because we already saw A before, so it doesn't make sense.
Sure.
So now from B, we can go to C, and that's this other neighbor. And to get to C, it will take whatever time it took for us to get to B, and the time it will get for us to get to C, which will be 1 + 1, 2. We haven't seen C yet. So we'll just like add that to our queue because we haven't seen it. So now we have visited B. So let's just store it in our map, and let's take it from our queue. Now we're at C, and now we're discovering the path. Now we're discovering the longer path. So from A to C, which we know was 5. C can go to B, and from C, okay, so from C we can go to B, from C we can go to A, and from C we can go to D. So first let's check the case where we go from C back to A. And just want to make sure that in this case the weight is also 5, right? Like both directions, it's 5, correct?
Yeah.
Okay. So in this case, the time for us to get to C, if we look at the top of our queue, was 5 seconds. for us to go back to A, it's going to take another 5 seconds. So that'll be 10 seconds to get back to A. But if you look at our map, we discovered a shorter path. Like we know there's a shorter path, so we don't need to append that. Because like it doesn't make sense. We already visited A using a shorter path. Now, if we want to go from C to B, it will take us 5 plus 1, 6.
Yeah.
But we saw a shorter path, so I don't think we should append that. Now, for us to get from C to D, we haven't seen D yet. It's not our, so let's add it. So for us to get to C to D, it should be 5 plus 1, which is 6. So let's add that. So D it will take. So now we have visited C, and we've seen that it took us 5, and now we can pop it off from the stack. And now we're gonna visit C again, but from the path coming from E. And I think here's where we can tweak the algorithm, because now we're revisiting C, but we took a shorter path, because before we took a longer path. So maybe we should here's where we can tweak the algorithm and just do the same math again. Like now we know that we got to C from a shorter path, so let's prove that. We do the same again. We can go back to A. We can go back to A from 2 plus 5, 7.
Okay.
If you're going to go back to A from C, it'll take us 7 seconds, but we got to A quickly, so we don't need to do that. If we want to now go from C to B, it will take us 2 plus 1, 3 seconds to go back to B, but it took us 1, so we shouldn't go back. For us now to go from C to D, it'll take 2 plus 1, 3. We don't have D stored, so let's just put 3. And let's mark that that took us 2 seconds to get to C.
Okay. That stopped you there now because we're 45 minutes in. I think, yeah, you're kind of getting there, but I don't know for sure if your solution would actually work. You can hear me, right?
I'm trying to think. Is this a leak code? I've never done this, but I'll try it.
Have you done a Dijkstra's algorithm before? That'd be the optimal.
No, so I never did Dijkstra's algorithm, because I think most of these graph problems are usually unweighted. That you see in these interviews, and so you can replace that with BFS. So I
exactly. But since it's weighted, you have to do a Dijkstra's or something.
Oh, I understand. Yeah, I know. I've never had to use Dijkstra's.
Okay.
So I see. I get your point. Yeah. So okay. Yeah. I'll probably tweak. This is a good one.
It's a good one, right? Yeah.
I got my brain to work. It could work. I do not know. I have a feeling it worked, but the only way to know.
It might be try it and send it. I think it just might be inefficient because I think.
Yeah. It might be inefficient. You're correct.
Because pretend I get to this one, I already seen it, and maybe. Yeah, I don't even know. It might be inefficient. I think we'll just need to.
It might be inefficient. I think it will work, but it might be inefficient. I could get TLE. Yeah. That's it. Yeah. But no, this is a good one. This is fun, dude. Thanks.
Yeah. All right, Shabaj, nice to see you. We should do some more collabs, work on some projects.
We should do it in person or something.
Yeah, I'm down, bro. All right, catch you on the next one.
All right, thanks for the stream.
Right, peace.
Bye.
Okay, we got our last interview. Yeah, yo, chat, I think we need to use Dijkstra's for that, right? What are y'all thinking? Okay, we got our last interview. Daniel, hop in. Yo, Daniel was good. Can you hear me? Yo, I can't hear you, by the way. Daniel, what's up? Can't hear you.
Hello? Can you hear me?
Yeah, what's up? How you doing?
How's it going? Good, man. How are you?
I'm pretty good. Nice to get you on. You're the last one. Gotta finish off strong.
Yeah, man. How long has it been? 11 hours?
I have no idea. Probably. I have to update the title. But yeah, here, I'm gonna hold up. Let me quickly end this. Have you seen any of the last people go?
Yeah, I watched like the last 3 people go.
I see. Where do you think you are in terms of level? I need to make sure I get the like. Would you be able to do those questions I've asked them?
Maybe like I'm not sure. I've done like 180 legal questions, so
I see. I see.
maybe like mid level.
Okay. How's the sound, everyone? Chat. Could you? How's my voice compared to his? Is it good level? Get a good. All right. I'm gonna set up the coder pad.
Sounds good.
You got school tomorrow?
Yeah, man.
God damn. Okay, let me find it. I'm gonna send you this. I got work tomorrow, so my last one. This was a fun stream though.
Do you stream every day?
Try not to, but I always feel like it's fun to stream, so I end up
Yeah.
streaming every day. Are you in? Just don't put your
Just
okay,
join
okay.
the coder pad,
Yeah. Don't put your full govy. All right. I'm gonna start this video. I'm allowed to say what school you go to and stuff.
Yeah.
Yeah, okay. There's a nice clickbait. All right, okay. This is gonna be its own video, so yeah, I'm gonna start it and I'm gonna introduce you and or I'll just like let you introduce yourself, give as much or little information as you want. But
Sure.
yeah,
What do you want me to talk about? Like,
I mean, like I'll ask
what can
you
make it the best title.
probably like just talk about your school, what companies maybe you've worked for, maybe what companies you're aiming to get into when you graduate, how many lead code questions and stuff like that. Just like high level description of like where you're at.
Sure, sounds good.
All right, okay, I'm gonna start this up. Hey everyone, so today I have Daniel on the chat or on the live stream. He's a University of Waterloo student. Could you just give a quick background on? Yeah, I guess you go to University of Waterloo. Like, what year are you in? What companies have you worked for? Maybe what companies are you aiming to try to get into when you graduate?
Sure, yeah. Hey everyone, my name is Daniel. I'm a 3rd-year software engineering student at the University of Waterloo. I've completed around 180 lead code problems. I'm going to be interning at Stripe this summer, and in the future, I'm looking to kind of break into more big tech roles. So, kind of just trying to get some practice in through mock interviews.
Nice, yeah. Stripe is a really good private company. Are you trying to break into like fan companies too, or you want to stay at like Stripe level companies?
I think like I've worked at like Stripe is gonna be my 2nd unicorn, and then I have something lined up for fall as well. So that's gonna be my 3rd unicorn.
Wow.
Hopefully, I kind of want to try out like working in big tech as well. So yeah, definitely try to transition into FANG at some point.
What's your next unicorn, if you don't mind sharing?
It's gonna be Verkada.
Oh, nice. The camera company.
Yeah.
Are you gonna be moving to the States at all, or it's all like in Waterloo?
So Stripe is in Toronto, and then for Verkada, that's gonna be in San Mateo.
Cool. So, what do you think your lead code skills are at right now, compared to maybe your peers?
I think my lead code skills are like average. Like I've done lead code style interviews before, and I think I've like held up decently. But for most of my like interviews at unicorn companies, they weren't really lead code style, so I kind of want to prepare myself for more like big tech interviews.
I see. Okay. I see. Okay, we're gonna get to the first questions then. It's like let me pull up. So how we're gonna structure this interview is pretty much we're gonna ask you 2 questions. You have about 20 minutes for each question. We're gonna try to keep it around 45 minutes for the whole interview, and yeah, like when we hit about the 20-minute mark for the first question, we're gonna move on to the second question. Just yeah, don't mind if I interrupt
Sounds
and we
good.
move on to the next question. I'll give you feedback at the end to see where you're at and let you know where you're at. Okay. So I'm gonna post the first question in here.
Okay.
So yeah, I'll let you go ahead and read this question and clarify all the requirements and stuff.
Okay. I'm just gonna take a minute to read through the problem.
Go ahead.
Cool. Okay, so after reading the problem, it seems like we have an integer array of n buildings, and then each building is, or the value at index I indicates the height of the building, and then we're gonna have an ocean to the right of this list, and we basically want to output a sorted, or like in order, what buildings have an ocean view.
Yeah, exactly.
Just to clarify, like if two buildings are the same height, then the one that's comes before on the left wouldn't have like a view, right?
Yeah, exactly. Like if a building is just as tall as you, you're not gonna see anything, right? You have to be taller than it at least.
Yeah, okay, cool. So I think off rip, my initial thought is, wait, hold on. If we have like a building of height, is it possible to have a building of height 0?
No. Every building
Okay.
is one or more. 0 means it's no building there. But let's say every
Yeah, okay.
building is at least one story.
Got you. So I think like what comes to mind initially is we can just start from the back and then iterate to the front of the array, and then we can maintain like the highest building we have so far. And then if we have a building that exceeds the height of the previously highest building, then we can just say that yes, this building has a view of the ocean. We can store it in our solution array. And then we can update like the variable that keeps track of the highest building we've seen so far. And then I guess we're just adding these indices in order to an array. And this would also keep it in like a sorted order, so we can just return from there.
Okay. Can you wait?
Would you
Can
like
you
me to go through
Yeah, walk me through a small example here of like.
Sure, I'll just go through the first example.
Yeah.
So basically, we have like some ocean, which is like here.
Sure.
And then we have like some buildings of certain heights here. So if we're gonna walk through this input, then we basically have like one obviously can see the ocean because previously we have maybe like a beach that's height 0.
Yeah.
So we would have like 0, 1, 2, 3, and then 3 is higher than 1, so 3 also has a view in the ocean. So we also have 2 here. And then 2 doesn't exceed the highest height we have so far, which is 3, so 2 would not be added to our solution. But then when we move to the last element in our input array, we have 4, which exceeds the maximum height so far of 3. So we would have to add this index as well to our solution. So the answer would be 0, 2, 3, which are the 3 buildings that can see the ocean, and these are also sorted by increasing order by indices. So I think I'll type my. I'm gonna begin. Does this approach make sense?
Yep, that makes sense.
Okay, so I'll just type this out kind of LeetCode style.
Sure.
Dev. We'll say like find ocean view, and then we'll do as well as I guess, yeah, that's all we're taking in. So can do like a for loop, or we can initialize to our max height. We're gonna initialize to 0, and this is basically gonna hold like the max height of a building we've seen from the right. And then we can iterate backwards. So we'll do like for ind x or height in enumerate buildings. We'll do like, we'll have this reversed. So we'll do if the height exceeds our max height. If the height exceeds our max height, then we can add the indices of this building to our solution array. So we have to define like a resulting array. Do red.append ind, and then we'll do max height equals height, and then let's see, what order would this return? What would our results array look like after this? Just put this here for now. If we go through backwards, the indices are going to be reversed, so I guess we have to account for that. So we'll do like
what does this do? Does this create a copy of the buildings and actually reverses it?
Yeah. I think we could also, in Python, there's like, you can use like the reverse keyword, but I don't know, this is the way I know how to do it. Like this just creates a copy in reverse order.
I see.
So
No, like why not just use an index and go backwards? Have an index.
Yeah, that's true. You're right. Yeah. We can do like
because if it's like a massive array, it's like if it's a bad way to like go backwards on an array.
Yeah, if we make an entire copy, right? So yeah, that's true. So we'll just do like buildings, n minus 1. All right, so instead we're going to iterate backwards using an index, and we basically just compute like where the matching index is at the back of the array, and then we want to append this and not the actual index. We can access our height using this, and then if the building exceeds our max height, then we should append this index and then set our new max height to this height. But what order are we appending our indexes in? We have to return like our resulting array in reverse order, I guess, since we're going from the back to the front and we're appending. Yeah.
Sure.
I guess like it's not clean to like make a copy, but like I think it's like O of n to just insert into the front of an array.
Yeah.
Because like
the
problem here is like, yeah. So I guess we can just return a copy of our results. And in terms of like runtime, or did you want me to like run through a test case?
Yep. Do a dry run.
Sure.
With this example again, and like trace your code along with it. Sorry.
Okay. result is this. We'll do like all right, let's see what it prints out.
Or we're not running the. Let's not run the code. We're gonna dry run it. If like, walk me through how the code is and like store all the variables.
Oh, okay. Yeah, I got you.
Dry run it.
Okay. Yeah, okay. So, like, if we were to input the buildings into this method, we're gonna first start by initializing our max height as well as our n. Like the buildings, so we're gonna first compute the number of buildings. So we have 4 buildings, and that's gonna be passed into n, and the result is initially going to be empty. We're gonna iterate through each index from 0 all the way to n, and then we're on the first iteration. We're gonna say, the height that we're examining is equal to 4 minus 0 minus 1, so that's gonna be 3. So we're gonna be looking at the last value here, which is 1, and then 1 is going to be I'm actually going to adjust this since I already computed height. Since 1 is greater than the max height, which is currently set to 0, we're going to record this index, which is going to be 3 inside our resulting array. So we append this 3 here.
Sure.
We append this 3 here, and then we set our new max height to the height of the building we're looking at, which is 1. Sure. And then on the second iteration, we have int equals 1. So the index that's passed into here is going to be 2. And we're looking at this building right here, 3. And then 3 is going to exceed 1. So we're going to add this index here. And then our result is going to hold 2. It's going to hold 2. And then we're going to set our max height equal to 3. And then on the third iteration, we eat in a building 2, or our index is now 2, and then we're going to access this building, which is of height 2. But since 2 doesn't exceed what our max height is, which is currently 3, we're not going to do anything on this iteration, and we're going to move on to the next. And then now our index is 3, so the height that we're going to access is the first one in our input array, which is going to be 4. And since 4 exceeds the max height of 3, we're going to add the index here, we're going to add the index here, which is going to be 0. And we're going to set our max height to 4. So that's going to be it for our loop, and we're going to exit it. But now our res is 320, which is the reversed order of what we're looking for. So we make a copy and return the reverse order. So res turns into like 023 instead, which is what we're looking for.
Okay. What's it called? Let's see. Yeah. Makes sense. What's your time and space complexity?
So in terms of extra space, in terms of time complexity, we're doing O of 1 operations within our loop, and we're iterating n times. So it's going to be O of n. And then in terms of space complexity, we're going to need an extra variable to store like the length of the building's max height, but this is negligible compared to our resulting array. And I guess worst case scenario, we have like all n buildings are able to see the ocean, so the space complexity would be O of n.
Space is n. Okay, cool. Let's move on to the next question.
Sure.
I'm gonna drop it under this. Okay. This one's. I'm gonna explain this to you because it's a bit more wordy.
Okay.
So we're pretty much gonna be given a list of accounts, right?
Okay.
It's gonna look like this. This is the input. So we're gonna be given a list of accounts. This is account 1, account 2, account 3 here. So the first element is the name of the account, and then they have a bunch of emails, right? So what I'm just gonna post in the rest. So it's a name. Each element is a name, and the rest of the elements are emails. So we want to merge the specific account, right? And we want to merge accounts that belong to the same person, and they belong to the same person if they share email. So look at 54 and 55. Are these two accounts the same?
Yeah, these two are the same because they share this johnsmith@mail.com.
Okay. What about this last guy? Is he the same John as the other one?
No, he is not the same John because he doesn't share any common emails with any other John.
Okay. So basically what we need to do is we need to output the final result here. Like this. Where you see how in the first one we have you see what they're asking here, right?
Yeah.
So the first one is the first John, but now all of their accounts are merged. The next one's Mary, and then the third one is just John, but it's not the same John as the other one. So write an algorithm that can take a bunch of accounts and return this as the output.
Okay. So like, just to clarify the input, would there ever be the case where like, or I guess what would happen if like we have like a John with john00@mail.com, and then maybe Mary also has an email named john00@mail.com. Is this like a possible input?
No, like a person can have any number of accounts, but all of their accounts have the same name.
All of their accounts have the same name. Okay, gotcha.
Like this, it won't be the case that Mary has like John here.
Yeah. Okay. I'm just gonna take a minute to think.
Sure. What are you thinking? Like, what comes to mind?
Yeah. So, like, when I'm looking at this problem, it looks like we need to use like something. Well, operations to do with sets, and then maybe like union them, or like finding like what if they even have any elements in common, and then if they do, like we want to merge them, kind of. But like, if I want to process this input, what I can do is say like, if we go through every email, and then if we've seen this email before, we can find like the account that is associated with, and then immediately just append all remaining emails that's associated with this name into that existing account that we have. But I'm just wondering like how we might be able to do that. Like if we had like a dictionary where we have like an email where the key is an email and the value might be a user ID or something, just so that we can avoid like overlapping Johns that might be different. So like for example, if we process this account first, we might have johnsmith@mail.com associated with like user ID 1, which is a John, and then we also associate this email with that. And then when we come to process this account, we see that we have johnsmith@mail.com again. So we have an existing associated like user value. So any remaining emails should just go into this account, and then we can kind of organize it into a data structure in this manner. Does this approach kind of make sense to you?
So you're gonna be using a hash map, or like what are?
Yeah, I'm gonna be using a hash map with the key as like an email, and then like the value is going to be like a user ID, and then we also maintain like maybe a user ID to a name.
Okay. Can you walk me through that? I still don't completely see if it's gonna work.
Yeah. I'm not too sure myself. I'm just kind of thinking out loud. So like if we were to go through receive this account input, we want to kind of process these in order, and then we're gonna first identify that we have some user named John, and then we're gonna go through like all of his emails and then see if we have like an account that is associated with this email prior, and if we do, we're just gonna immediately add all remaining emails to like the set. But if not, then what we should do is assign a new user ID to John, and then say like, okay, one is John's user ID, and these are his emails. But like, I guess this doesn't work because if we have like, let's say we have like John with johnsmith@mail.com and John_New York@mail.com, and we eat in another John with like, sorry, I'm just gonna reorganize like this or copy this input. This is demonstrate an example. If we have like 3 John accounts, and the first one has johnsmith@mail.com, and the second one is also like John with this email, and then we eat in this third account, then I guess we would have to merge these 2 existing accounts if we were to use like my approach. So I guess this doesn't work. Does that make sense?
Yeah. So what are you thinking? Just keep thinking. Just keep going like that. I like how you're thinking.
Yeah.
You just need to get to the approach. Like you're making some progress.
Yeah. I think like something that would work is like if we consider it as like a graph.
Sure.
We can say like.
There's a whiteboard here too, by the way.
Oh yeah. Okay. So if we have like this, this is cool. So we have like a John here, and then if we have like johnsmith@mail.com, we know that like this belongs to like, let's say it belongs to this blog, and then if we have like a john00@mail.com again, we know that there's like another blog, and then if we have this third account that's in this like input over here,
yeah,
and we have johnsmith@mail.com and John_New York@mail.com, we can kind of like make the association where we draw like, okay, we have already seen both these emails and they point to these accounts, and then we know that like later on we're gonna have to merge all of these together. So like I guess we can maybe construct like a forest from that, and then union all the emails of associated accounts, and then find like all the accounts combined together. Does that kind of make sense?
Okay, so how are we gonna construct this forest? Like I posted down here. We have
down where?
Like how are we gonna construct this forest? I just need more specifics on that.
Yeah. Okay, so I'm just gonna take them to. Okay, so like let's say we have a bunch of accounts as inputs. We're just gonna immediately make like associated like identifiers for each account, and then also say like it's kind of tricky.
Which part?
I don't know. This implementation that I'm thinking of seems like way too complicated for what the question's asking. So basically, I want to just have like an associated like account number for every account that I eat in, and then every time I also want to populate my hash map with like a email and what account it's associated with, and then basically whenever I see a new email, I want to see like, have I had this email before, and if so, then I'm gonna point my account to whatever account belongs to that, and then in the end, I kind of want to like do a graph traversal of each tree or like each component in my graph, and then merge all the accounts or merge all the emails into one account. But like, I don't know, it just seems like overkill for what the problem is asking. I'm sure like there's
I mean, you're going to
a better
the
way.
right approach, but I'm just not understanding the ID part. Like, could you just repeat that and be more specific?
Like, let's say for every account, we want to
Yeah.
eat in, because since these names aren't unique, like it's hard to make an identifier for like an account. So every account that we eat in, we might say like this first one is 1, second one is 2, third one is 3, fourth one is 4, and so on and so on.
Sure.
So then later on, like if we want to point an email to another account, we won't have to say like this is pointing towards like John. If we have like multiple Johns, if it's pointing towards like account 4, and we know exactly what account 4 like represents, then we can like extract the contents from there and then merge the emails.
Okay. I think the ID part, I mean, we can get to it, but like, how are you gonna figure out which emails belong to each other? Like, how do you group the emails? 'Cause that's essentially what the problem is asking, right?
How are we gonna group the email?
Exactly, because we need to return a group. Like, in the final output, we need to group all the emails and then just assign them John. Like, I mean,
Yeah. I'm wondering like, is there a way we can like maybe sort the inputs so that we can ensure that emails can, or like we can have like a larger group come before a smaller group, so that way we're not like, when we merge later on, we're not creating like two divergent groups.
let's just work through a very small example, right? Let's do this example right here, but let's move. Like, what should be the output here? Right?
Yeah, so the output for this is John's. The output for this is going to be like a solo account for this John, and then this John is going to merge with this John as well.
Let me add this.
Yeah, so
what would be the solution?
The solution for this would be like all the Johns mixed into or merged into one account. So it'd just be like John with the John Smith email plus the John _ New York plus the John00@mail.com account. I think like maybe what we can do is like basically whenever we see an email that we've seen before, we're gonna merge that account into ours. So then that way, like if we ever have the case where we have like this smaller account, then this other smaller account, and then this bigger account, we can just, when we reach this, we can populate this bigger account with, or we can just get rid of the smaller account and get rid of this other smaller account by like union merging the sets of emails from the previous accounts. So I think we can kind of do that as we go along. Maybe I might like write out like a little blurb of text just to explain kind of what I'm thinking. So basically, for each input account, associate email account for each new input. If we see an email we previously processed, merge that account into ours. Merge that account into ours. So I kind of want to now think of like how I want to do. So merge that, and then at the end we should have a hash map of accounts with unique emails. Process that to formatted accounts, and then like implementation can use like use map email to an ID in one of the maps, and then the ID mapped the ID to a list of. We can do like.
Seems like you're like
couple.
thinking of like a union find or something. Are
Yeah.
you familiar with that at all?
Yeah, union find, like it's.
Have you
union find
implemented it
supports
before?
like. I haven't implemented it before. Like I'm taking algorithms right now, so we like kind of learned about it last month, but I guess I didn't study hard enough for that data structure. Union find has like a parent, like find if it has a parent, and then like union two different components within a graph, right?
Yeah. I mean, let's go back to the drawing board. Like,
yeah.
What is there a way that we can think of this as like a graph? Pretend we have like three different. Pretend. I'll just give you a like. Let's remove these emails because it makes it harder.
Okay.
Pretend John has email 1. John has email 2 here.
Yeah.
And maybe 3.
Uh-huh.
And then we say this other John has email 3 and 5. If we think about this as a graph, right? We have one John with email 1, one with email 2 and 3, and another with 3 and 5, right?
Uh-huh.
You see how like building a graph might lead like how many different accounts will be here?
It's just gonna be like 2 accounts.
Yeah. And then like which ones
like
belong?
John 1.
Yeah.
Yeah, but I'm not like, to be honest, I'm not familiar with like the implementation of a union find.
I mean,
data
this
structure.
would just be like a simple DFS, right? Like finding connected components in a forest.
Oh, you're right. Yeah. Yeah, so I guess like we could just go through all the accounts. John. And then like, so I guess like every email can like branch off into whatever accounts they're associated with. And then we basically just have to DFS like starting from any given email and then identifying like every component within that section of the graph. Does that sound right?
Yeah. So yeah. How are you thinking of like parsing out? How are you thinking of building up this graph?
I think like we're gonna have to have a data structure that associates emails with different accounts, and then we basically like after we parse our input and then make these data structures, we can just start from. Hold on. I feel like running a DFS, like I'm not super confident on like how I would approach like this DFS solution. I feel like the solution that I was kind of writing out before has like a similar complexity, like runtime.
Mm-hmm.
I don't know, like is there or do you see any like edge cases that I might not be catching in the way that I was looking to process it before?
Okay, could you just quickly explain again? Because it
Yeah,
didn't. Yeah,
sure.
I thought you were going the wrong direction, so I just wanted to give a hint if you want to
Yeah,
try this
so
out.
yeah. So basically we receive like a list of accounts and then we're gonna assign like an ID to the account initially.
Yeah.
And then when we see we're also gonna say like this email is mapped to this account, and then we're just gonna go through our array this way. But then when we see an email that we've seen previously, then that means our map is gonna be able to identify like an account that we've seen before. So we're just gonna immediately merge that into here, and also at the same time update this email's account value to our current account and maybe like all accounts associated with this previous account. And then we're just gonna traverse like this way. And then at the end, we're gonna have basically a map where um, we're gonna have like IDs that are we're gonna have like a map of IDs to like whole accounts.
Okay.
That are like merged with all associated ones.
Okay, we have about 5 minutes left, so let's just get to coding it, and then let's see where we get to.
Sure. Does this kind of make sense to you?
I think so. Let's see the implementation and see.
Okay. This. And then we'll do like. Alright, I guess CoderPad doesn't really like this type. It's more like Lego style, but I can just get rid of it for now. For account and accounts, we're gonna have to identify like email. Email. For an account and accounts. The ID is going to be email to account of this email equals ID, and then for email and emails, and then ID to account of this ID is going to be equal to the set of emails. We'll make it a tuple for names. Or we can't put a set in a tuple, so we'll do like a list. Names, set, emails. And then email to account, every email is going to be associated with this ID. And then after this, we're going to have to increment the ID. But like this is just the processing part, so I guess we also need to account for like the implementation that we thought of earlier here. So if we have an ID that we've seen before, so for email, before we can even do this, or create a new account. So for emails, you're going to have to merge all previously accounts with the email. We'll do like if email to account, if email in email to account. If we have an account that has the email previously associated, we need to do identify the account existing ID equal email. And then for this account, we have name, emails, existing emails.
Wait, what's emails here?
For email, oops, I just accidentally. So emails is like, the name is the first element, and then emails is going to be the remaining ones inside of the list. And then basically here is like, for every email in this account that we're eating in, if we find one that we have like a previous one associated to, we're going to identify the existing ID, and then we're going to say like the name and the existing emails are going to, the set of existing emails is going to be equal to the value of this existing, associated with the existing ID. We have to put existing name, ID to existing. So for all these existing emails, what do we need to do? We need to first delete the previous account. So email for delete the existing account. So ID to account dot pop. And then we're gonna have to merge all of these emails from this set into the emails coming into this new account. So we can do
Okay, we're at 45 minutes, so I'm gonna stop you there.
Yeah, I think like okay, looking back at the problem, this is definitely like not as optimal as doing like a traversal, but I think like it still should work.
I see. Yeah, I think I'll have to look for if there's an edge case. It might TLE, that's the main thing, but how do you think you did overall?
I think it would TLE. I expected myself to like be able to solve both problems. The first one was like a warm up, but this problem was definitely definitely a lot more challenging. I'm kind of disappointed that I wasn't able to get like the DFS or like identify like it's like a graph and we need to do like DFS on all the components. I wish I would have like communicated my thought process more. But overall I thought I did decent.
Yeah.
I know your scale is like 0 to 4, and I think I'll probably give myself like a 3 at best.
3 at best. Yeah, I think this one, I mean, it's hard to say because okay, let's talk about everything. I think Q1 definitely really easy, like you solved it really easily. It's not, some people like it's not the, I mean, it's an easy question, but it's still a medium, so it's still a good job on it in general. You're able to figure it out. I think there's just like some weird syntax with like, I mean, like why not just use something like range here, right? Like going backwards.
Up here.
Yeah. So like, I mean, this still works, but it's like a bit more convoluted.
Yeah.
And then what else? Oh yeah, somebody said like your solution might not, Q2 might not work because of cycles, but let's focus on Q1. I think, yeah, there's just like also with reversing, why not just like call like the reverse? This is like kind of a nit thing, but like reversed and reverse are functions that they created on arrays that do exactly that. Like you're using slicing in order to flip it,
Yeah.
but like it's just more convoluted. I would say like why not just use the function that's already built in?
Yeah. Yeah. I guess like at this step, I think I should have just looked up the syntax because I knew that like this existed, but like I just went with the way that I knew, like to reverse.
I see.
Because
Okay.
this would like create a copy and like use extra space.
Yeah, and then when you're another tip would be like when you're trying to point at a specific element instead of highlighting it, you could just use a caret to just point at that specific one and then work backwards.
Yeah. Okay.
That's a small thing, but overall, honestly, you're a solid yes on the first question. Like you clarified everything well. You wrote really clean code, and you did a dry run really well, talking about all the variables and where they're at, and then like built up the variables like you basically compiled the code and like basically I want you to be a compiler when you're doing the dry run, and that's what you did. Like you walk line by line, you didn't skip any lines, so I'll give you a solid yes. Second question, I think just need more practice, like figuring out identifying when it's a graph question. Like it is a harder medium than usual, but it's still like a medium. I think when you get to doing harder questions, this is a valid interview question. Also, like I've seen this been asked.
Yeah.
I think identifying it's a graph question, would help you there. Like, I couldn't say that you. I think definitely. It would just be more practice. Like you obviously know how to code. You obviously know, like, I just don't know if you were making good progress towards the question though. Like I didn't think.
Yeah.
Like I think you did. You wouldn't have known it's a graph question, unless I said it there. Like on the interview, maybe by yourself you would have done it, but like So I would think I honestly this would all depend on how many people actually got it right. But if more people got it right, then it would be a 2. But I think since this is hard, I actually don't know if I got enough signal. So I'd probably make you have to do a follow up. But I think a lot of candidates would actually like 30% would figure out or 40% might figure out it's a graph question. Like I think why I'm leaning towards a no instead of a yes because you didn't notice it's a graph problem.
Yeah.
And that part would be like if you figured out it's a graph problem but couldn't implement it, then I'd lean to a yes. But I think you're just not at the right solution. So that's why I would like lean to a no. Does that make sense?
Yeah, no. Yeah, no. It makes sense. I'm like, I'm kind of disappointed that I didn't like identify that. But
awesome.
It's just comes with practice.
Yeah.
Anyways.
No, you're good. Hit me up as always. We could do more of these. Cool. Thanks for taking the time out.
Yeah, no, thank you for your time, James.
Yeah.
I'd like to book like another slot sometime.
Well, you have me on LinkedIn. Just message me, and we'll do other questions as well. That's fun.
Sure, sounds good. Anyways, Thank you.
See ya.
Yeah.
Yo, chat. How did I go? 11 hours? How was that? That was my last interview for the day. I'm gonna go eat some dinner. But I hope y'all learned a lot of stuff. Yeah, I got work tomorrow, but I'm feeling good. I'm gonna go eat some dinner. And then I'm gonna go grind tomorrow too. We're gonna don't worry, I still go hard at work. But I probably there's gonna be more stuff on the weekend. All proceeds are going to Coding Jesus paid course. Shout out to everyone who jumped on the stream. Everyone was actually really good, which was fun. I think everyone learned a lot of things. But I'll catch y'all on the next stream. We'll definitely do this again. I have a ton of people from all types of different schools. I have like a Netflix guy. I have like some quant guys, like bunch of different people that I could put up on this, like do interview style. But overall, this was fun. I'll see y'all in the next stream for sure. Let me close this out. Thanks for tuning in. And thanks Shabaj for another $11. Appreciate y'all.